This is Renesas. Renesas was born after 3 Japanese technology giants, Hitachi, Mitsubishi Electric, and NEC, took the bold step of merging their semiconductor businesses to create one company. It is from this rich technological heritage derived from these companies that the foundation of Renesas is formed. Our proven technology and unwavering commitment to quality are what set us apart from our peers as a world-leading semiconductor company. More recently, Renesas began expanding its footprint in Silicon Valley, first with the acquisition of Intercell in 2017, and then IDT in 2019. Renesas successfully combined its proven quality with top-class safety standards and technical competency with the innovative products and entrepreneurial spirit of Intercell and IDT. In 2021, Renesas completes its acquisition of Dialog, expanding its footprint in Europe. With Intercell, IDT, and Dialog now in the fold, Renesas enters a new era as a truly cosmopolitan company with a progressive mindset and a modern vision to lead the industry. What is Renesas's purpose in business? Our purpose is simple: to make our lives easier. We do this by harnessing the power of technology to complement human capabilities. And our lives don't just mean the people who use the final products that are powered by our technology. It means the lives of our suppliers, customers, our employees, and their families. To make human lives easier, our products provide advanced driver assistance systems, alternative fuel vehicles, robotics and human-machine interaction for smart factories, state-of-the-art medical devices, home appliances with intelligence, data centers handling big data and data explosion, fast and low-latency 5G wireless communication networks. To make our customers' lives easier, we deliver a vast array of semiconductor products such as MCUs or SoCs, analog and power to provide complete coverage for the broad signal chain in electronic systems. Renesas customers win by tapping our rich portfolio of analog power and embedded processing solutions. Our winning combinations help customers accelerate their designs and get to market faster with high performance and high quality products. The winning combinations address the needs of new and expanded customers and continue to power our customers' systems with compelling products and solutions designed with our proven technology. Renesas has weathered many storms and changes and is in a constant state of transformation to become a stronger organization. We will continue this journey to make a better world through our technology and make a positive impact on the way we live and work. Here at Renesas, everyone can make a difference. Together, we can make change happen.
Kenetom is an engineering services provider for embedded systems and industrial automation, based in Thessaloniki, Greece. Today, Kenetom employs more than 180 people, and the team keeps growing. Our vision at Kenetom is to get established as a customer-oriented center of excellence in the field of embedded systems. Our philosophy of delivering the highest quality engineering services is built on our values of trust, evolution, commitment, talent. Since 2014, we have established partnerships with some of the largest Tier 1 automotive electronics suppliers, gaining significant experience and developing know-how across our team. Our customers come from 4 major sectors: automotive, industrial automation, medical, aviation. They include major Tier 1 automotive electronic suppliers and global market leaders. Having significant experience in both agile and waterfall development, we tailor the development processes to our customers' requirements. Our main activities lie in the areas of basic software development, application software development for control and automation, testing and validation of ECUs, electronics design and development, systems engineering, software requirements, and architecture. Our strength is our people, and that's why we offer excellent working conditions, challenging projects, and significant development opportunities. We are happy to be one of the most popular employers in Greece, and our strong connection to the academic community enables us to constantly strengthen our team with highly talented people. As we focus on developing automotive, safety-critical embedded systems, we comply with quality, information security, and functional safety standards. For major Tier 1 automotive electronic suppliers, we develop, integrate, and validate hardware and software modules for powertrain, interior, and ADAS ECUs, from requirements up to system qualification tests. Kenetom actively supports its customers from prototype to series production. Thanks to our extensive collaborations, we have gained significant experience with different technologies and tools. Our customer satisfaction is the key factor in our constant growth. So if you are looking for a reliable partner, Kenetom's team is ready and motivated to create a positive and productive partnership with you. Kenetom. Embedded Engineering Excellence.
This is Renesas. Renesas was born after three Japanese technology giants, Hitachi, Mitsubishi Electric, and NEC, took the bold step of merging their semiconductor businesses to create one company. It is from this rich technological heritage derived from these companies that the foundation of Renesas is formed. Our proven technology and unwavering commitment to quality are what set us apart from our peers as a world-leading semiconductor company. More recently, Renesas began expanding its footprint in Silicon Valley, first with the acquisition of Intercell in 2017, and then IDT in 2019. Renesas successfully combined its proven quality with top-class safety standards and technical competency with the innovative products and entrepreneurial spirit of Intercell and IDT. In 2021, Renesas completes its acquisition of Dialog, expanding its footprint in Europe. With Intercell, IDT, and Dialog now in the fold, Renesas enters a new era as a truly cosmopolitan company with a progressive mindset and a modern vision to lead the industry. What is Renesas's purpose in business? Our purpose is simple: to make our lives easier. We do this by harnessing the power of technology to complement human capabilities. And our lives don't just mean the people who use the final products that are powered by our technology. It means the lives of our suppliers, customers, our employees, and their families. To make human lives easier, our products provide advanced driver assistance systems, alternative fuel vehicles, robotics and human-machine interaction for smart factories, state-of-the-art medical devices, home appliances with intelligence, data centers handling big data and data explosion, fast and low-latency 5G wireless communication networks. To make our customers' lives easier, we deliver a vast array of semiconductor products such as MCUs or SoCs, analog and power to provide complete coverage for the broad signal chain in electronic systems. Renesas customers win by tapping our rich portfolio of analog power and embedded processing solutions. Our winning combinations help customers accelerate their designs and get to market faster with high performance and high quality products. The winning combinations address the needs of new and expanded customers and continue to power our customers' systems with compelling products and solutions designed with our proven technology. Renesas has weathered many storms and changes and is in a constant state of transformation to become a stronger organization. We will continue this journey to make a better world through our technology and make a positive impact on the way we live and work. Here at Renesas, everyone can make a difference. Together, we can make change happen.
Kenetom is an engineering services provider for embedded systems and industrial automation, based in Thessaloniki, Greece. Today, Kenetom employs more than 180 people, and the team keeps growing. Our vision at Kenetom is to get established as a customer-oriented center of excellence in the field of embedded systems. Our philosophy of delivering the highest quality engineering services is built on our values of trust, evolution, commitment, talent. Since 2014, we have established partnerships with some of the largest Tier 1 automotive electronics suppliers, gaining significant experience and developing know-how across our team. Our customers come from 4 major sectors: automotive, industrial automation, medical, aviation. They include major Tier 1 automotive electronic suppliers and global market leaders. Having significant experience in both agile and waterfall development, we tailor the development processes to our customers' requirements. Our main activities lie in the areas of basic software development, application software development for control and automation, testing and validation of ECUs, electronics design and development, systems engineering, software requirements and architecture. Our strength is our people, and that's why we offer excellent working conditions, challenging projects, and significant development opportunities. We are happy to be one of the most popular employers in Greece, and our strong connection to the academic community enables us to constantly strengthen our team with highly talented people. As we focus on developing automotive, safety-critical embedded systems, we comply with quality, information security, and functional safety standards. For major Tier 1 automotive electronic suppliers, we develop, integrate, and validate hardware and software modules for powertrain, interior, and ADAS ECUs, from requirements up to system qualification tests. Kenetom actively supports its customers from prototype to series production. Thanks to our extensive collaborations, we have gained significant experience with different technologies and tools. Our customer satisfaction is the key factor in our constant growth. So if you are looking for a reliable partner, Kenatom's team is ready and motivated to create a positive and productive partnership with you. Kenatom, Embedded Engineering Excellence.
All right, good morning, everyone. I'm very glad to welcome you on the second day of the conference. I hope you had an excellent day yesterday and enjoyed the social event as well. My name is Vasilis Pavlidis. I'll be chairing this session, the morning session. We have a set of splendid papers covering everything from devices, circuits, all the way to architectures. Without further ado, we're already 10 minutes in the program, so I will ask the speakers to do their best to meet the time specs, and I would really, really appreciate that. So the first talk, unfortunately, the speaker couldn't join us, so it will be online from through the Zoom platform, I guess. The speaker is Mr. or Professor Dimitrios Simeonidis, and he will be talking about the analysis of SQRL strengths and weaknesses compared to other authentication mechanisms. So let's give the floor to the speaker, please.
I'm a PhD candidate. I'm not a professor yet. I'm a PhD candidate in the University of Economics, Varna, in the University of Economics. Analysis of SQRL, let's start with the presentation. Analysis of SQRL, a comparative study with traditional authentication mechanism, strengths, weaknesses, and challenges. Authentication plays a vital role in ensuring digital security. Traditional authentication methods suffer from vulnerabilities such as password reuse, weak passwords, and susceptibility to phishing attacks. Introduction of SQRL, Secure Quick Reliable Login, as a modern alternative to address these vulnerabilities and enhance the authentication process. Strengths of SQRL: robust security. Advanced cryptographic techniques ensure high resistance to interception, eliminates the need for passwords, mitigating the risk of password reuse and weak passwords. Usability and user-friendliness. Simplifies the login process with QR code scans, reducing the need for complex passwords. Enhances user experience by eliminating the burden of password management. Potential to replace traditional methods. SQRL security and usability advantages position it as a strong candidate to replace traditional username password authentication. Offers a modern and secure alternative for online service access. Weaknesses of SQRL. Dependency on additional applications, relies on external applications, particularly for secure key storage. Users may need to manage additional software, which can be inconvenient. Vulnerability to DNS spoofing. SQRL lacks inherent protection against DNS spoofing. Users and service providers must implement additional security measures to mitigate this risk. Device compatibility and resource limitations. Effectiveness may be constrained by device limitations, especially on older or resource-constrained devices. Storing cryptographic keys may demand significant memory resources. SQRL versus passwords. Strengths of SQRL. Security utilizes advanced cryptographic techniques, enhancing resistance to interception. Phishing prevention. Unique identity creation for each web domain makes it challenging for phishing attacks to succeed. simplifies account creation, eliminating the need for email addresses and complex passwords. Weaknesses of SQRL: requires users to create a master key and save a rescue code, potentially deterring some users. QR code adoption: transitioning to QR codes for authentication may require adjustments to existing processes. User errors: security depends on user vigilance, and stolen devices can lead to data breaches. This is a graphic for how SQRL is functioning. SQRL versus password managers. Strengths of SQRL: security, prioritizes security with advanced cryptographic techniques. Reliability, offers reliable authentications and recovery mechanism. Weaknesses of SQRL compared to password managers: usability on untrusted devices. Password managers may expose passwords on untrusted devices, unlike SQRL's QR code scanning. Phishing vulnerability: both SQRL and password managers are susceptible to phishing attacks. Dependency on passwords: password managers rely on passwords, hindering the goal of password-free authentication. SQRL's unique features: anonymity and phishing prevention. SQRL offers anonymity by eliminating the need for email addresses. Its unique identity creation based on domain names helps prevent phishing attacks. Unique user identities for domains. SQRL creates a unique user identity for each web domain visited. This uniqueness enhances security, making user identities useless to intruders on phishing sites. Effectiveness and ease of learning. SQRL simplifies authentication, enhancing usability. It offers reliable authentication and the ability to recover from identity theft. SQRL's potential to replace passwords benefits websites and users alike. Conclusion. Key points. SQRL is a promising alternative to traditional authentication. It addresses vulnerabilities like password reuse and weak passwords. SQRL offers security, reliability, and ease of use, enhancing digital authentication. SQRL has the potential to improve the overall landscape of digital authentication. It prioritizes security and user-friendliness, making it a compelling choice. Addressing limitations. To achieve broader adoption, SQRL limitation must be addressed. Collaboration between technology providers, service operators, and users is essential for a more secure online experience. This is the references, and this is the end of my presentation.
Right, thank you very much, Mr. Simonidis. That was particularly on time, great. So we have time for questions from the audience, if there is any, but if there is any, please wait for a couple of seconds until the technical people back.
I'm not hearing you very well. Can you adjust maybe the microphone? I can't hear you very well.
You can't see me or you cannot hear me?
Here.
Okay, can you hear me now?
Yes.
Okay, great. So I was just asking the audience whether there is any question. Are there any questions from the audience? No, okay, so maybe I can ask one question. You mentioned some of the limitations of SQRL. I wonder if you can tell us briefly what is the primary limitation that prevents SQRL from becoming the standard for, logging in basically in our machines and so on.
It is the need of the device having a lot of memory to store the master key. the necessity of storing the master key needs a lot of memory, and many devices hasn't this possibility.
I see. All right. Great. Thank you very much. Any other question? Right. I don't see any hands being raised. So let's thank our speaker. Thank you very much, Mr. Simeonidis. So we can move to the next paper, and this time the speaker is with us, so it's Mr. Vasilios Vasios, right? And he will be talking about a quite interesting topic, which is about fault detection in analog circuits by utilizing current supply transit. And I want to listen a few words about this as well. So the floor is yours, Vasilis.
Good morning. My name is Vasilis Vasios, and I'm from the International Hellenic University, the Department of Informatics and Electronic Systems, and I will present you our work in fault detection in analog circuits by using the current supply transients. Fault detection, especially in electronic devices and products, is a key feature for the quality of the companies. It is a large area of interest and research. Our mode of operation here is to detect a faulty or a good circuit in an automated mode. This brings us to the part of the digital circuits and the analog circuits. The digital circuits are easier to detect any faults because the test procedures are well defined and have a limited number of faults. On the other hand, the challenges for the analog and mixed signal circuits is that there is a variety of faults in short open circuits, also a stack and fault conditions. Also, the non-linearity issues of the semiconductors inside the electronic products and the parametric fault tolerances of all electrical elements in the circuits. Some methods that are used in the past were fault dictionary, sensitivity analysis, model-based analysis, and some measurement-based analyses, such as power supply current, output, and nodal voltages monitoring. The circuits are classified in various methods. Main methods are the statistical analysis, just the standard deviation, or topological analysis, just like a Euclidean space or Malakhanobis distances. A block diagram of our work consists of the heart of the device, which is an MCU, which controls a programmable power supply, measures the current that feeds the device, and sends all the information back to a PC or a laptop. Also, the MCU feeds the stimulation of the analog circuit, which produces the desired outputs. The algorithm. For the economics of time, I will pass this, and I will explain it with pictures. The circuit under test that we tested the algorithm is a simple common emitter amplifier, and we measured the current that passes through the circuit but with a twist. We drop the power supply voltage by 10%, hold it steady, and we return its voltage power to the nominal voltage. This produces this current. This wave is a bit difficult to process. It needs to be refined. By measuring and calculating just the RMS values as previous works have done, we came to the conclusion that the calculation of the mean values and the RMS values have no differences. Thus, by using this formula, we can decompose the signal to its mean component and its AC component. It is clearly different. The blue line is the mean value, and the red line is the RMS value of the previous waveform. In this waveform, we seek 12 points, 3 on each transition. Here are 3 points denoted: the maximum point, the minimum point, and the relaxation value. The damping point, the damping point is produced by taking the 2 points of interest, produce a line, and calculate the gradient, the point that has the same gradient as the aforementioned line. Each block here is the detection region, which is defined as a plus minus 3 sigma deviation around all points. For any given circuit under test, in any given measurement, a good circuit must have all 12 corresponding points inside these blocks. If any of those measurement has a point outside this block, is classified as faulty and is discarded or is sent back to the testing area to be processed there. The second circuit under test that we tested the algorithm is the negative feedback amplifier, the two-stage negative feedback amplifier, which we have induced faults in every element of the circuits. The induced faults is done by 2 waves. The first way is to short the corresponding element by introducing a less than 1 ohm resistor parallel to the component, and a short in an open circuit, which we use a resistor of a very high value in series with the resistors and every other element. In order to achieve this, we build a microcontroller, not a microcontroller, excuse me. We designed a system, a programmable power supply and a data logger, which is the black circuit, and it sits on a STM32 Nucleo board. A do-it-yourself PCB that we made, which is both our CUTs, and we inject the faults by using these breakers. All the algorithm, all the programming is done inside the STM32, inside the microcontroller, and the data are fed back to a laptop where MATLAB processes the signals, the measurements for visualization. For our testing, we checked the algorithm with 100 CUTs in an equal distribution, 50 good ones, 50 fault ones, and the results are given in this table. For the common emitter, for the common emitter amplifier, 22 faults are induced and all were detected. For the negative feedback amplifier, 46 faults are induced and also every fault is detected. We also researched the range of the detection region according to these values, from 1 sigma to 6 sigma. And we came to the conclusion that it does not improve the overall accuracy, but it does improve the precision and the recall, which means we have detected less negative faults, less negative goods and positive faults. For our future work, we are planning to design a new programmable power supply which can produce symmetrical voltages to feed systems and circuits that are based on operational amplifiers. Also, we will planning to test the algorithm, refine it and planning to test this on filters, comparator, and DACs. Thank you for your time.
Great. Thank you very much, Vasilis. Excellent use of time. So the floor is open to questions. Okay, great. I'll start from the youngest this time. So please wait for the mic. Yeah, it's coming to you.
Thank you very much. Very interesting presentation. I would like to know more about your analog to digital conversion for the signal acquisition. Do you need specific requirements for the ADC circuit? I mean, in terms of bits, so I don't know, 12, 10 bits.
We tried it from the STM2 Nucleo development board. We tried it and we had too much noise because of bad designing. The ADC lines of the STM32 sit right above the power lines of the Ethernet chip. So we had a lot of noise. The noise was backed down with a digital filter that ran inside the STM32, and it cleared the noise. It also produced the results that you saw.
Okay.
The new plan is to use an external
ADC
at 12-bit analysis, but with a twist, a simultaneous acquisition
to compensate the
the difference in the sampling time. By the way, the sampling time is 32 kilohertz. It's a small sampling time because we wanted it to be more versatile. If someone wants a larger sampling frequency, you can use it. 30 kilohertz is, to our calculation, a good frequency for a 1 kilohertz signal.
Sample, yeah. Thank you very much.
Thank you.
Right, so if you can pass the, Professor Chatouchas.
According to your current view, if you see that background currents, the inherent variation of background currents, meaning the bias currents, the leakage currents?
Can you repeat? I can't hear you very well.
All right. I have to ask that if you, according to your current view, you believe that the inherent variation of leakage currents, background currents in general, may affect the capability of your technique in order to discriminate defective, with respect to no defective circuits, or this is not an issue for your technology?
No, this is not an issue. This was not an issue. At the unipolar circuits, for one power supply, for symmetrical power supply, we haven't investigated yet.
Thank you.
Thank you.
All right. I think we can move on to the next paper. So let's thank Vasilis again. Thank you. Right. So the next speaker is Professor Tsiatouchas from the University of Ioannina, a good friend of mine as well. So Yorgos, please, the floor is yours.
All right, thank you, and good morning to all of you. Unfortunately, Mrs. Dounavi, it was not feasible for her to be here with us today, so I will present this work, which is related to aging issues in model schemes that are in-memory computing subcircuits that are using that we are using in cases where we need fast computations. This work was supported by the ONI project at the University of Ioannina. We have huge demands today for efficient and fast computations, especially in applications related to artificial intelligence. And the classical von Neumann architectures poses many constraints with respect to the performance loss and the huge power consumption that it is needed in order to transfer data between the memory unit and the processing unit. So we need a new design paradigm, and this today is in-memory computing, where we perform computations near memory or even inside memory. In the later case, we are talking about in-memory computing. On the other side, we have large problems today with aging phenomena, and the most severe among these phenomena is the binary temperature stability, which affects transistors, the BTI phenomenon, and this phenomenon also affects the operation of SRAM memories. This work is focused on 8 transistor SRAM memory in-memory computing schemes. BTI decreases the threshold voltage, degrades the threshold voltage of transistor, meaning that the absolute value of this parameter is increased over time, gradually increased over time. So we need to provide proper techniques in order to alleviate this aging mechanism due to the fact that this increment of the threshold voltage will result to performance degradation and finally to the generation of errors. SRAMs are affected by this aging mechanism. We can categorize BTI aging in 2 main categories. This one that is related to DC, permanent stress, which affects rapidly the performance of a transistor, and the case where we have relaxed phases where the transistor is not stressed, and with the word stress we are meaning increased voltages on the terminals of the transistor, the VGS voltage, as well as increased temperatures of operation. In that case, where we decrease the voltage stress, we have relaxed phases, and in that case, for this phenomenon, for the BTI phenomenon, we have a recovery of the threshold voltage, so we can alleviate the aging of this device. Now, this is the typical structure of an 8T SRAM memory. We have the 6 transistors that form the memory cell and 2 extra transistors that are involved in the reading path and the computation path of this memory. We are trying to protect we are trying to protect these 2 transistors that are involved in the computing path of the memory. Now, what we are doing for in-memory computing, this is a case, we can extend this to do arithmetic or logic computations. Here we have a scheme for logic computations. We activate 2 read word lines in the memory and in parallel, concurrently, and a voltage is developed on the read bit line, the RBL, depending on the contents of the 2 memory cells and the current paths that are generated through the 2 computing transistors. And we have extra circuitry attached in the read bit line in order to convert this voltage level that it is developed on the RBL to a digital value. Aging affects almost all transistors in this memory cell. However, the 6 transistors that belongs to the memory subcircuit does not contribute to the performance of this in-memory computing scheme. So we will not discuss the aging of this transistor. There are various techniques in order to alleviate aging, and our lab has developed such techniques in order to protect these transistors. We will focus on these 2 transistors that belongs to the computing path, and we need to protect this transistor in order to retain a reliable operation of the memory. Among these 2 transistors, the MN6 transistor is not affected by aging due to the fact that it is activated for a small time periods during the operation of the memory. So the stress on this transistor is limited, and the aging of this transistor is almost negligible. On the other side, the MN5 transistor, the MN5 transistor, and depending on the value that it is stored on the memory cell, is affected by aging, and this is a DC stress on this transistor, which means that we will have a rapid degradation of its performance. This means that the current path that it is established during the computation phases will be less, and this will affect the reliable operation of the memory, since the voltage that is developed on the RBL will be less than the expected one. So errors will be generated after some time of operation of the memory within the expected lifetime of the circuit. So we need to protect this transistor. Right now, the only known solution in the literature is to add an extra transistor on the side of the RBL in order to support overaged transistors to maintain the correct voltage level on the RBL. So in that case, in case that the MN5 transistor is affected by aging, we have to activate this transistor in order to keep the voltage level below the expected threshold voltage on the RBL. However, for this operation, we need to insert and embed in the circuit proper aging detection mechanism. We are capable to do this, but this is not a trivial task. And moreover, the problem here is that the aging of the transistor is not uniform. So in that case, you have every time you are starting a computation to know if the transistor involved in this operation are overaged or not. So this will, we believe that this makes this approach not realistic for the alleviation of BTI influences. What we propose here is a rather simple solution. We are removing the ground from the source terminal of the MN5 transistor, and we replace this with a source line. And we are properly bias this line with a positive voltage in order to reduce the voltage stress during the idle periods, the inactive periods of the cell. So in that case, we can eliminate the stress, so the aging of the transistor, and in case that the voltage that it is used on this S line is equal to the power supply, we eliminate the aging of this transistor, so the effect of aging on this transistor is equivalent to this of MN6 transistor, almost negligible aging throughout the lifetime of the circuit. Okay, this is a simple mechanism. It is easy to implement this at the layout level, at the cell layout level, just removing this metal that grounds the source terminal of MN5 transistor from the ground. So we have this very simple modification. However, at the higher levels of the layout at metal 3, we have to do some adjustments in order to provide the capability to pass the power supply to the cells. So we expect in the worst case an increment to the area about 14%. However, in many cases, especially when we are doing in-memory computing, we need this extra source line, so this will not be an extra cost for this technique. Now, the influence of BTI can be seen in this simulation, where for the case where we have a fresh cell, the discharging of the read bit line is below the threshold voltage, the predefined threshold voltage, so we have a correct operation, computing operation. However, when the threshold voltage shift is above 14 to 45 millivolts, then in that case the voltage level at the RBL is above the threshold voltage, so we have the generation of errors, and we expect this phenomenon under severe aging stress conditions to happen even after 2 years of operation. This means that inside the lifetime, the operating lifetime of the circuit. So we have to do something, and we propose this simple modification in the memory array. However, we are gaining in reliability, meaning that we can eliminate aging in case that we are using the power supply for the biasing of this extra line, or we are reducing the aging in case of a lower voltage, but we have to pay on power consumption. And this cost is above 50% in case of VDD as bias, and it is reduced below 20% in case that the half of the power supply is used for the biasing of this extra line. However, if you notice, when we are activating this memory cell, we have to charge the read word line and discharge the source line, And when we inactivate this memory cell, we have to do the opposite operations to discharge the read word line and charge the source line. So there is plenty of room here in order to exploit charge sharing, in order to reduce the power consumption, and we have developed such techniques in the lab in order to reduce power consumption in such systems. Right now we are working on this issue with respect to this memory scheme. On the other side, we do not have any performance penalty with respect to this technique because we can hide the discharging of the extra line, the source line, below the pre-charging operation of the read bit line and also the charging and discharging of the read word line. So we do not expect any performance degradation during the circuit operation. The main issue that remains is this trade-off between reliability and power consumption, and a designer have to select which one of these two problems is the most severe in order to decide for the adoption or not of this approach. So we propose a simple but effective solution in order to alleviate or eliminate aging phenomena in the computation path of an 8T SRAM in-memory computing scheme in order to maintain reliable operation and this way extend the lifetime of a memory. We expect that under severe stress conditions, we can extend the lifetime from 2 years to more than 5 years of operation. So we have drastically improved the lifetime of the circuit. Thank you. Right now we are working on other more complex in-memory computing schemes in order to alleviate aging and propose also faster ways to do the pertinent computations. Thank you very much for your presence here. And
thank you, Yorgos. Great, very interesting topic. If there are any questions from the audience? Yes, Manolis, do you want to wait for the mic? Just, yeah.
Okay, so if I got yours correctly, in memory computing, main advantage is to reduce power, right?
Yes.
But by doing this, I guess we have these aging issues. And then you propose something that, if I got again correctly, you increase the consumption. So overall, by doing in-memory computing and implementing the technique, what is the power budget that you are getting out of it?
This is actually right now under our studies in order to see what we gain, what we lose. I have to mention that this power consumption that I presented is related only to the memory array, not the whole memory. Okay. So the actual increment of the percentage increment of the power consumption is much less than this value. So we're see how we can alleviate this extra power consumption according to the approach that I presented earlier, doing recycling of the charge between these two lines in order to have a viable solution also with respect to the power consumption.
Do you actually fabricated this? You have actual
No.
Not yet.
These are only
simulation. Okay, got it. Thank you.
In 25 nanometers, 22 nanometers technology.
Right. Thank you for the question. So in the interest of time, I propose to stop here, if you don't mind, Yorgos. Yorgos will be around for the rest of the day, so you will have the chance to ask the question.
Thank you very much.
Thank you again. Right, so we're switching gears a bit, so moving from circuit design papers to another important aspect of semiconductors, which is design automation. So the next papers will be dealing with issues that have to do with design automation and will be presented by Mr. Christos Giamousis, who is a PhD candidate. No, they're already there.
I have an updated version here.
I have to ask our... Okay, can he plug it in to the? He has a new version of his presentation. All right. There is any USB port left. All right. Right here. Oh, you got it there. Okay. All right, so the first paper will be on the reduction of large-scale RLCK models via low-rank balanced truncation, and we'll see a lot of linear algebra, if you remember that from your degree.
Okay. Hello, everyone. My name is Christos Giamousis. I'm a PhD candidate at the University of Thessaly, Department of Electrical and Computer Engineering. And I'm going to present you today two papers. The first one is reduction of large-scale RCK models via low-rank balanced truncation. Electromagnetic simulation of modern ICs is one of the most challenging problems facing the EDA industry. EM models extracted by industrial tools, such as ANSYS Raptor X, consist of a large number of parasitic elements that introduce significant limitations in the simulation process. So there comes model order reduction that can reduce the complexity of such models by producing reduced order models that retain an accurate approximation of the input and output behavior of the circuit at each of the ports. That results in accelerated electromagnetic simulation with lower memory requirements. So model order reduction methods are distinguished into two main categories. Moment matching techniques are typically employed in industrial tools due to their robustness and computational efficiency. However, they do not provide an a priori estimate for the accuracy of the ROM, and the final ROM size is based on an ad hoc selection of the number of matching moments. On the other hand, balanced truncation techniques offer a reliable bound for the approximation error and may result in more compact ROMs. Nevertheless, they require the solution of computationally expensive Lyapunov equations and involve the storage of dense matrices, even if the system matrices are sparse. Our contribution is an efficient low-rank balanced truncation method for the reduction of RLCK models. Our method produces accurate and compact ROMs, makes use of the extended Krylov subspace to accelerate convergence, and ensures great accuracy given BT's reliable error estimation. It is also computationally memory efficient, handles sparse and dense matrices with block matrix operations, exploits parallelism using CPU and GPU, and since it's an iterative process, it employs a computationally efficient convergence criterion. The modified nodal analysis description of a node and branch P input and Q output RLCK circuit in the time domain is shown here. Cn is the capacitance matrix, Gn is the conductance matrix, M is the inductance matrix, E is the node to branch incident matrix, V and I are the vectors of node voltages and inductive branch currents, B is the input to node connectivity matrix, L is the node to output connectivity matrix, U is the vector of input excitations, and Y is the vector of output measurements. Now, if we denote the model order as n capital equals n plus m, the state vector x and G, C, B, L as shown here, then the above equation can be written in the descriptor form as it's shown here. So the essence of model order reduction is to project the initial system into a system with a reduced dimension R, where simulation can be performed much more efficiently. Overall, BT relies on the controllability and observability grammars, P and Q, and provides a global error bound before the computation of the ROM. To obtain the grammar matrices, we have to solve the Lyapunov matrix equations, and the next step is to compute the singular value decomposition of the grammar matrices to obtain their square root, and then compute the SVD of the product of the roots, and use it to calculate and truncate the transformation matrices, which then, as a last step, we use to project the initial M&A matrices and to obtain the reduced system. The limitations of the initial BT method are its high computational complexity, which derives from the solution of the Lyapunov equations, and the need to store the dense grammar matrices, even if the system matrices are sparse. To overcome these limitations, we have implemented a low-rank method for the solution of the Lyapunov equations. The idea of low-rank BT-more is to project the large-scale Lyapunov equations onto a lower-dimensional Krylov subspace, and then solve the resulting small-scale Lyapunov equations to obtain an approximate solution of the initial equation. This is done iteratively until we get a close enough approximation of the solution. The kth dimensional extended Krylov subspace looks something like that. Looks like that. The method starts by the pair in step 2. Then we solve, at each iteration, we solve the small-scale Lyapunov equations and check for convergence. If it has not converged, we go here and add another pair of vectors to the Krylov subspace and do this iteratively until we get a close enough approximation to the initial solution. The size of the subspace increases by the number 2 times the number of ports of the circuit at each iteration. The main advantages over the initial balanced equation is that we now have to solve only the small-scale Lyapunov equations instead of the large-scale equations. And the general dense inverse matrices, GC and BC.
Autonomous vehicles are...
The inputs of the algorithm are only needed in matrix vector products and can be implemented as linear solves. To efficiently perform linear solves, we have split the matrix C into its blocks, the sparse Cn matrix and dense M matrix, which includes all the mutual inductances. For the sparse matrices, we have employed parallel CPU optimized methods, and for the solves for the dense matrices, we have chosen to use GPU accelerated techniques. The convergence criterion is actually the residual of the Lyapunov equations as if we were solving the full equations. This can be calculated by back-projecting the small-scale solution using the current subspace and applying it to the full equation. However, it has been proven that this equation equals R transpose AX, which is what we have used as a convergence criterion, since it's much more computationally efficient. To evaluate our method, we evaluated our method on some large-scale RLCK models extracted using the ANSYS RaptorX tool. All experiments were executed on a Linux workstation equipped with an 8-core processor and 64 gigabytes of RAM. The characteristics of the benchmarks are shown here. We can see they're pretty large. To test the accuracy of our methods, we evaluated our ROMs with respect to reference ROMs obtained by RaptorX, since the simulation of the original models is infeasible. The comparison is done in terms of S parameters. And as we can see here, our ROMs closely match the reference ROMs across the frequency range. By looking at the size of the ROMs that each method has produced, we can tell that our method has produced roughly 3.1 times more compact ROMs than Raptor X. As of performance, our tool has higher reduction time and memory requirements, but they're still reasonable and can be further improved in future work. So to sum up, we presented the low-rank BT-more approach to reduce large-scale models with accuracy comparable to commercial tools. The proposed method is evaluated across a large set of large-scale models, and experimental results indicate that our ROMs achieve sufficient accuracy in terms of S parameters, while being up to 5.5 times smaller than the ROMs obtained by Raptor X. This was my presentation. Thank you very much.
Thank you, Christos. Are there any questions from the audience? Christos will be around for the next paper as well, but if there are any questions, you can ask now. If not, I have one burning question. So, Christos, so from what I understand, the last table you showed to us, it takes longest to extract the model, right? But it will take shorter time to simulate it, right? Once you do that.
Yes.
Is that the purpose of your work,
yes,
right?
Yes.
So
you do the process one time and then
yes.
you simulate it.
Sure, sure. So is this, can this longer extraction time be reduced by parallelizing more heavily your method? Is your method parallelizable? That's the question, basically.
Yes, if we had some a farm of computers and run this method in parallel, we could make use of, we could achieve better reduction time, but with the trade-off of higher memory requirements.
Sure, okay. All right, thank you very much. Are there any other questions from the audience? All right, so if not, let's move on to the next paper, so you can just switch the slide deck, right? So the next paper, until you find the right slides, is Morsit's Model Order Reduction Techniques for Electromagnetic Models of Integrated Circuits. And I know a bit more about this, is some part of it. This is a project, one way or another. This conference is about demonstrating the links between industry and academia. So this is a project that is supported by the Greek government, where the University of Thessaly, Aristotle University of Thessaloniki, and ANSYS have sat together to produce some cool techniques to speed up the simulation of circuits. And Christos will tell us a few more things about it. So Christos, go ahead.
So let's move on to our second presentation. Again, the accurate modeling of electromagnetic behavior of ICs is one of the most important challenges in EDA. Integration of all parasitic elements dramatically increases the size of the extracted EM models, where the simulation involves solving equations with dimensions approaching hundreds of billions. This, of course, is a massive mathematical and computational problem to which current EDA tools cannot provide a satisfactory solution. Model order reduction methods are used to produce reduced order models of lower dimensions with insignificant losses in accuracy. Moment matching techniques are typically employed in industrial tools due to their robustness and computational efficiency. However, they do not provide an a priori estimate for the accuracy of the ROM. They rely on ad hoc selection of the number of matching moments, and the final ROM order is highly dependent on the number of ports. On the other hand, balanced truncation techniques offer a reliable bound for the approximation error and are independent of the number of ports. Nevertheless, they are much more computationally expensive and have high memory requirements. So let's talk about the Morsis project. Morsis is a collaborative project between University of Thessaly, Aristotle University of Thessaloniki, and ANSYS, funded by the operational program Competitiveness, Entrepreneurship and Innovation. Our main goal is to perform model order reduction of electromagnetic aware RLCK models with more than 1 billion elements in less than 24 hours. Current third-party algorithms can take up to weeks. The expected output of this project is for our methods to be integrated into ANSYS RaptorX and Exalto tools to serve the increasing needs in fast-growing, high-value markets such as cloud, IoT, and 3D ICs. It can also enhance the research activities and innovation in the semiconductor field, where Greek universities wish to maintain their international competitiveness. At the current time, we have developed a cross-platform EDA tool that implements an initial and a low-rank version of the balanced regression technique. The initial BT method is used for reducing small-scale models, while the low-rank version is used for large-scale models. Both methods produce accurate and compact ROMs while being efficient in terms of reduction time and memory consumption. We have also designed diverse and complex circuits to challenge the algorithms, and we evaluated our BT methods over the moment matching methods used in industrial tools, such as Aristotle, and we have seen that we can produce 5.5 times more compact ROMs with sufficient accuracy and reasonable runtime and memory requirements. Here we have a representation of a circuit in descriptor form. C is the capacitance and inductance matrix, G is the conductance matrix, X is the vector of unknown voltages and currents, B is the input-to-node connectivity matrix, and L is the node-to-output connectivity matrix. The essence of Moore is to project the original system into one with a reduced dimension R, as we can see here. As part of the Morses project, we developed a tool that performs Moore and simulation. The cross-platform Morses tool was developed in C++ using the CMake automation software. The only input to the tool is a configuration file where the input matrices and certain Moore parameters are specified. The specification of the model can be either given through a SPICE netlist representation, or we can just input the M&A matrices in binary or triplet format. Our tool then performs more simulations, such as DC transient or S parameter, and has the option to dump the reduced M&A matrices in binary or triplet format, or export its S parameters in touchstone format. Now let's take a look at the core of our tool, which is the main reduction algorithms that we have used. Here is the first algorithm, which is a standard balanced regression. It relies on the Lyapunov equations. Again, we have to compute the SVD of the grammar matrix to find the square roots, compute the SVD of the product of the roots, to get to those transformation matrices and truncate them to then use them to project the initial system onto a reduced. Its limitations is its high computational complexity and the need to store those dense Graham matrices. To overcome these limitations, we use an extended Krylov subspace method to obtain low-rank approximate solutions of the Lyapunov equations and use that instead for the reduction process. What we gain from this method is that we only have to solve small-scale Lyapunov equations, and the generally dense inverse matrices GC and BC, which are the inputs of the algorithm, are only used in matrix vector products in steps 2, 4, and 11, and can be implemented as linear solves. In addition, even though the size of the subspace depends on the number of ports, P, the truncation of the transformation matrices does not rely on it. We can have a subspace that's too large, but the final ROM size can be reduced even further by truncating the transformation matrices in step 5 of algorithm 1. Hence, BT can handle models with multiple ports, in contrast to moment matching, where the ROM size highly depends on them. Moving on to the experimental evaluation, we evaluated our initial method on small-scale RC and RCK models of real transmission lines extracted by RaptorX. Here we can take a look at our models. All reduced models have been compared to their original models through simulation, since they are too small and the original models can be simulated at this point. The reduction percentage to achieve great accuracy is within 65 to 78%, which is acceptable because the models are already small and cannot be further reduced. In the C analysis, we get mean relative error and max relative error of below 0.62%. For the S parameter analysis, we get a mean runtime error below 0.73% and a max relative error below 1.89%. As we can see here, the initial BT is invisible even for 20K order models because the inductances introduce additional overhead to the memory and runtime of the algorithm, to the solution of the Lyapunov equations. For our low rank method, we designed a diverse set of circuits. UTH designed a diverse set of circuits in the GlobalFoundries 22 nanometer technology. Their respective models were extracted also by RaptorX. To challenge the efficiency of the developed algorithms, the implemented circuits target basic building blocks in RF and mixed signal systems of different functionalities and various operating frequencies. The evaluated designs include hybrid and Wilkinson couplers and typical transceiver blocks like low noise amplifiers and oscillators, which are highly sensitive to their parasitic content. We can see the specifications of the designs. On the left, we can see their operating frequencies, while on the right, we notice the different metrics we use to evaluate the designs once the designs are simulated with both their active and passive components. Here we demonstrate the magnitude and the phase of the S parameters for the hybrid and Wilkinson couplers, both those operating as power splitters at 28 GHz. As can be seen, the S parameters of the Morse's ROMs closely match those of RaptorX across the frequency range, and most importantly, at the frequency of interest. The insertion loss error is lower than half decibel, while the respective phases differ by less than 2 degrees. By looking at the sum of the ROMs that each method has produced, we can tell that our method has produced roughly 3.1 times more compact ROMs than RaptorX. And as of performance, our tool has higher reduction time and memory requirements, but they're still reasonable and can be further improved in future work. To conclude, we presented the Moses project, where we have developed a framework using balanced allocation methods for the reduction of large-scale RSK models. The developed techniques are evaluated over moment matching methods used in industrial tools with complex designs that challenge the algorithms. And experimental results indicate that our tool produces up to 5.5 times more compact ROMs with reasonable reduction time and memory requirements, maintaining sufficient accuracy. Thank you very much.
Thank you. Right, so are there any questions from the audience? Yes. Can we have the mic, please?
Thank you. Very interesting presentation. I have a question regarding the computing. The computing infrastructure that you run in simulations, because I saw some gigabytes of RAM, etc. Did you exploit some HPC infrastructure for the simulations?
No, we haven't yet done something like that. We're still developing the algorithms. We try different versions of subspaces to see whether we can get better accuracy with even more compact models. And then we will move on to some better optimizations regarding the memory and reduction time.
Thank you.
Yeah, the hope is that we'll use the cluster, the HPC cluster here in here. Yeah, I think it's more, it's computationally more stronger than theirs. So at the University of Thessaly, so we'll use ours maybe. All right. Any other questions from the audience? Right, so let's thank Christos again and move on to the next paper. So the next paper will be presented by Mr. Stavros Kalapothas, right? Who I think also comes from the University of Thessaly. Is that correct, Stavros?
University of Peloponnese.
Oh, Peloponnese, sorry about that. All right, so I saw Fotis Plessas as the co-author and I made the assumption that you are also from
so the main author is the Kalimera, and thank you for the floor. And on behalf of our team, we are great honored to be here and present our work.
All right, so I'll let you move on with your presentation.
Thank you very much. So our work is about design and implementation of a compact RISC-V based machine learning accelerator on low-end FPGA. Our main motivation is actually based on the fact that we our exploratory work is working on exploring the machine learning on resource-constrained and low-cost hardware, deep learning inference on RISC-V architectures, as well as exploit hardware accelerator design frameworks for FPGAs. In order to do that, we exploited some already publicly available tools, such as online platforms and data sets in order to produce the inference. We also used the CFU playground, which is released in 2022 by Google, custom function units platform that creates custom hardware accelerators as well as soft cores to accelerate machine learning and AI applications. We've also used the Xilinx Vivado hardware design tools, and in this particular demo and work, we have used a low entry FPGA publicly available development board for the testing and our deployment. We actually exploited the FOMO lightweight object model. FOMO stands for faster objects, more objects, which is released by Edge Impulse, but the SDK it's openly available. We measure and locate objects in an image, so object detection main use case. We are actually monitoring numerous objects in real time. We have seen 30 times less computing power and memory compared to MobileNet single-shot box, as well as YOLO 5 version 5. And it's also it's considered a first, as far as we know, the first implementation on a RISC-V soft processor. Of course, we will dig into a bit more later, but the actual results we have seen is 3.7 times inference speed up at 180 milliwatts of power consumption, which consumes 5.5 K of slicing logical units, which corresponds to the 26.4% of the actual of the total LUTs inside the board. We have also slice register allocation of 4.3, which corresponds to 10% of the total available in the Xilinx Arctic 7 FPGA. Our compact accelerator produced consumes only 368 slices LUTs, as well as 110 slice registers. Object detection for non-real-time demanding embedded application at resource-constrained entry-level FPGA devices. So this is a diagram of the FOMO, which is, as already mentioned, a trunked version of the MobileNet V2 model. It corresponds to, so it's trunked down up to 27 convolutional layers. You can see on the top, I mean, it's not really visible right now, but it's the input, the image input is 96 by 96 pixels, and the output is 12 by 12, so 1/8 reduction. Our proposed accelerator design is for a RISC-V soft processor complemented with a custom accelerator. The hardware accelerator is connected to a CPU with custom function unit CFU interface. So the CFU playground gives us an interface, creates an interface to connect these elements. The module has a total of 27 layers. The majority is convolutional, so 95% of inference time is consumed in the two main convolutional layers. The convolution algorithm fetches data from memory, so we are using a dynamic RAM from the FPGA, and we are calculating quantized dot product in order to store the results back in memory, and do the iteration with multiplication and accumulation calculations. This calculation is, of course, quantized product implemented in a hardware accelerator. As a high-level overview of the actual algorithm, we have the full iterations. You see the loops. The main loop shown in a red rectangle is actually denotes the main convolutional layers where most of the computations are taking place and actually consumes most of our time. We have introduced constant convolution parameters replaced by literal values. We also have predetermined values checkings which are stripped in a way in order to reduce the bias. We also eliminate loops in a controlled mechanisms with fixed values. And the main unroll loop, which is shown here again in the red rectangle, we have a reduced factor of 8. The proposed design, which is actually produced by the CFU, is the accelerator which implements the MAC calculation. The architecture is SIMD, so single instruction multiple data, for the multiply and accumulate calculations. It allocates 4 bytes for weights and 4 bytes for input data. There is also a bias addition and as well as quantization. With no, and we have known also from the literature that quantization in inference doesn't have a penalty in the accuracy. Our experimental results targeted to this FPGA includes this. We actually selected this development mode not only for the low resources constraints, but also to the fact that we have an embedded power monitoring circuit inside this board, which help us to monitor the power consumption during inference. We are also doing profiling by running inference, as already explained, by reducing the input image dimensions to a scale up to 1/8 of the initial dimensions. There are 3 districts experiments that were conducted, and the main configurations were executed with the original code, so the main FOMO algorithm online. We have also run it on a software, so only on the RISC-V, based on the previously mentioned optimizations. And we have also run in both software and hardware by including the hardware accelerator that the CFU have produced for us. When we run on the native platform, so you see the classification object detection, you see in the, so you see in the window here, we have the original image on the right, on the left, and then on the right, the detection, where we have the actual percentage of accuracy and the type of person being recognized. This was run in the online platform, and then we moved on the RISC-V software only. First we ran this on a simulated environment, cross-compiling it to the FOMO algorithm to run on a Renaud simulation. And we have already witnessed by introducing this software reductions and optimizations that we have reduced the cycles for the inference computation from 135 million cycles to only 35 million cycles. So this is only for, we have witnessed these reductions during simulation. Going forward, of course, we ran these optimizations. We wanted to see what was the outcome also in terms of software and hardware acceleration by introducing the hardware accelerator. And in this respect, running it on the FPGA directly, we have noticed, we have witnessed a significant reduce from 240 million cycles to 65 million cycles of computation at the inference stage. So this is very good results. In terms of actual speed performance metrics, we have seen here where most of the computation cycles are being consumed. So you see on the left that most, let's say, computations are used in the convolutional array layer. On the left, on the blue bars, you have the original, and on the orange one, you have on the software only implementation, and on the right-hand side, on the gray bar, you have the optimization that also incorporates a hardware accelerator, and you see the reduction that's very significant. Also in terms of area utilization, so meaning the LUTs and the slices that we are actually being used under this FPGA, we have really a significant reduction. It's not really shown here. I mean, the colors maybe are not really visible, at least on my screen. The actual availability of it's almost double. So the available after these reductions and spatial optimization, you have almost double optimization in terms of area utilization. Another very good benefit going into low power and low energy and low latency applications, it's also the fact that we need to reduce the power consumption on the device. So we have measured this in our implementation, and we have seen very significant results, positive results in terms of power consumption in terms of, again, comparing the original as well as the software and the hardware implementation. Here is the links, and our work is available online on GitHub, on our repository of our lab, and that concludes my presentation, and I look forward for your questions.
Thank you. Great, thank you very much. Are there any questions from the audience? It was a really interesting task that Stavros and his team performed. So any questions from the audience? Right, so one question would be, you mentioned, you showed some results regarding the improvements you get during the inference process. What about the training, with all the modifications you have made? Is it an easier task now, or is it, more difficult to achieve?
Thank you for the question. We didn't focus mostly on the training tasks. We are mostly considering inference for edge computing devices. But in that respect, we have only used, pre-trained models. So in that respect, we didn't explore this. But of course, in the future, we also I forgot to mention about future optimizations, which actually to use block RAM, so not dynamic RAM, but also use block RAM inside the FPGA with lower latencies, and most probably will have faster inference times. But for training specifically, we don't have explored these options. Thank you.
I see, and a very short follow-up question. Is the reason why you avoided the use of block RAMs in this specific instantiation of your method?
No. Initially, we used the DRAM option because it was produced by the tool. But so going from DRAM, as we know already that there are more, let's say, faster and low latency going from DRAM to block RAM, it's our next step for future optimizations. Yeah.
I see. All right. Thank you very much. Are there any last and remaining questions? Oh, there is one up down there, so you can.
As you showed, there is a significant performance advantage to your approach in roughly the same power consumption. Is there a way to, for example, have a less significant performance advantage but at a lower power consumption?
As already mentioned, thank you first for your question. Our main goal is actually to reduce power consumption. So we're actually looking ways in order to reduce the power consumption to the minimum because of the actual use case that we're actually looking for. If we, let's say, if I understood correctly your question, if we would feel more okay if less power was consumed or more power was consumed. Okay, can you please reformulate?
Okay, I'm sorry. What I meant was, as I saw, it was roughly the same power consumption, but significantly better performance. My question is it possible to, because as you said, because these are edge cases, like what is the performance penalty in order to lower the power consumption?
So in the given model, let's say we reached the minimum by introducing, you see a bit of higher power consumption due to the fact that we have introduced also the hardware accelerator, which also consumes more power. But so in this specific experiment, we have reached, let's say, the minimum. In other use cases, when we try to incorporate other models, maybe we will see and we will witness higher power consumption. So there's not. So it's only specifically this power consumptions being reached to the minimum. It's only bound to the specific model and use case, I would say.
Thank you.
All right. So let's thank Stavros again and all speakers of this session. The session now concludes, and we can move on to the next keynote talk. Thank you very much all.
Good morning to all of you. Now we have the keynote speech from Professor Doris. I have the pleasure to present, to introduce Professor Kostas Doris, who was one of my best students 25 years ago in the physics department. Then he moved in University of Eindhoven to make PhD studies, and then he worked in Philips. He continued to work and continues to work in NXP. Now he is as a part-time professor in the University of Eindhoven to bridge the gap between industry and academia, and to find very good students to hire in NXP. He will give a speech on the millimeter wave automotive radars. Costa.
Open the microphone.
Good morning to everybody. It's a real pleasure to be here. Last time I've been here was, I think, 7 years ago. So today I will talk about automotive radar and try to give you a little bit of an holistic view about the developments in the field towards autonomous driving. Before I get to the main content of my presentation, I want to give you a little bit of a small intro of what NXP is. NXP Semiconductor is a company with a very old heritage. We focus on 4 main areas. It's a company that focuses on the edge markets: automotive, industrial, IoT, mobile, and communications infrastructure. We have a very global footprint. It's a company of 31,000 people on 30 different countries around the world, combining basically the heritage of Philips, becoming NXP, and since 2019 also Freescale, that was Motorola, merged in one company called the new NXP. So today we'll talk about the automotive part, where NXP is having a very active role. The whole automotive field is emerging. 10 years ago, it was a very boring field to work on. I would actually not want to work there. But then automotive radar came in and many other very interesting developments. Today, it is an exciting field to work on. There is many different type of applications. And you have to realize that an average vehicle today basically has approximately 1,000 semiconductor chips. And this is only increasing. So the relative value of the semiconductor industry has in a car is been changing and increasing substantially. So we're going to talk about ADAS, so autonomous driving assistance systems and automotive radar trends, specifically for the transceiver front end. I will give you a little bit of an introduction on the basic radar principles so that you can navigate yourself into the complexity of the field, especially moving towards high resolution, which is a key word and a key element for future systems. And then enabling technologies on circuit antenna and sensor, and also have a look a little bit what's coming up towards higher frequencies. Before I move on to the main content, I would like to simply steer you up a little bit with a small video that we made with a colleague of mine. So if we can actually play the video.
Imaging radar is important today because it's a new key technology for building safer cars. It allows the vehicle to travel in conditions where lighting is poor or the driver has a hard time seeing, so hard rain, light rain, fog. Cases where the driver can't see well, the radar can still see, and then from that to make the safest driving decisions that's possible. Autonomous vehicles are definitely in our future, and they will become the norm when they become extremely safe. We need sensors to continue to mature, and one of the key sensors is imaging radar.
Hi, I'm Robert Carter, Field Applications Engineer for NXP Semiconductors. Today I would like to introduce you to a new imaging radar sensor that we have mounted to our vehicle. This sensor is powered by an NXP radar chipset, and it's developed by our partner Cubtech. Our chipset consists of an S32R45 radar processor and the industry's first dedicated 16 nanometer imaging radar processor. These processors deliver unparalleled computation power for highly efficient real-time data processing at low power dissipation. To provide data for the digital signal processor, there are 4 cascaded RF CMOS TEF 8200 radar transceivers. These transceivers provide 2 times RF performance improvement for enhanced sensing. 4D imaging radar refers to a radar that measures 4 key parameters of objects that the radar can see in its field of view. The first one is range, or distance between the radar and the object. The sensor in our case is actually detecting short range and long range simultaneously. This capability is due to a sophisticated antenna working with the hardware acceleration on our processor, which provides the processing power to process different modes simultaneously. One of the next things that is measured is the velocity or speed of the object. The radar can determine the difference in velocity between the vehicle and the object. This information is critical, for example, when executing automatic emergency braking, performing adaptive cruise control, or for making safe driving decisions associated with route planning. Another key parameter that is measured is azimuth angle. This measurement describes how far to the right or to the left a detected object lies from the center line of the radar. When multiple objects are in close proximity to one another, imaging radar provides a sub-1 degree azimuth resolution so that these objects can be separated from one another. The final dimension is elevation angle. This is a measurement which allows the radar to calculate the height of an object above the road surface. The radar can determine if objects it detects are safe to travel over or if they need to be avoided. One key use case for this parameter in an imaging radar involves detecting an overpass or bridge structure over the roadway while at the same time detecting if the roadway beneath the structure is clear for safe travel. All 4 dimensions taken together allow the radar to expertly map the scene in front of it. This information can then be used to alert the driver of the vehicle so safe driving decisions can be made. Today, NXP has a leading position in automotive radar. Through our continuous innovation in millimeter wave design, radar signal processing, and advanced algorithms, we will continue to develop products that will keep us in an industry-leading position for years to come.
All right, so by the end of the presentation, you will understand a bit more about the technology behind those imaging radars. So let's start building up this story. So as I mentioned earlier, the automotive landscape is really changing. So today's cars or future cars are more like a robot on 4 wheels rather than, the 4 wheels with a metal weld type of industry behind it. So there are 3 pillars of innovation. One is relating to the Vision Zero. Vision Zero means 0 road fatalities. And there is statistics indicating that 90% of the cases of road accidents relate to human error. So that needs to be taken out of the equation. The second topic relates to the electric evolution. This drives to zero emissions, the whole green energy discussion, and you see that actually changing rapidly around us with electric cars and the whole system that supports it. The third one is upgradable future. Practically, we're talking about a vision to software-defined vehicles. This is how the OEMs today are describing this transformation. The last thing you want is that you have to upgrade your car every time you go back home. There's so much sophisticated electronics in the car, you simply want to experience something that you don't see practically. It's happening as you ride, it's happening as you stop, and everything is actually working, and all the software is decoupled from the hardware in the car. To satisfy this vision, basically, the OEMs today are changing drastically the vehicle architecture. So on the left side here, you see today's systems that are based on a sort of a flat hierarchy. The whole networking in the car is flat, and on a flat architecture, you can think of a harness that actually weighs up to 50 or 60 kilos of cable in a modern, expensive car. That's a lot of weight. And of course, there is no connection between the different sensors or different domains. So that brings basically the industry to move into the domain-based architecture. So we have a central gateway and the different type of applications or domains like connectivity, body and comfort, powertrain, and ADAS specifically. This is a transformer intermediate step to move into the full zonal architectures where everything happens in a central processor, high performance computing, automotive standards in the middle, where all the fusion is taken there, all the information from everywhere around the car, be that from your audio system recognizing a siren moving into your imaging radars or anything else coming and being processed in a central. So that's the user-defined car of the future. Looking at the autonomous driving, the industry has set a few standards, 5 levels of automation. Practically there are 6. Level 0 is the one that you have no automation, but level 1 is the reality today. So on the top you see an evolving bubble around the car, which is the active safety around the car. The car sees around it in different ranges, different things. So today level 1 deals about basic emergency actions, lane keeping, adaptive cruise control. And on the far right is the future where minds-free, hands-free. There is actually no wheel, steering wheel. There is nothing you need to worry about. And in between, there is this very interesting level 2+, where the industry realized how much complex it is to move to level 2 and 3. So they introduced level 2+, where also all the legal aspects on who has responsibility, many other technological things are being addressed. Now, to come to autonomous, full autonomy in driving, we need the redundancy of sensors. There is no single sensor that can make it happen. Different sensors are good at different things. So you have, for example, a camera that is able to detect colors, but he cannot detect depth or distance. You have LiDAR that actually is very precise, but it lacks the velocity capability. And you have radar that actually can give you the velocity capability, can give you the bad weather performance, but it lacks the resolution. So all this combined together into what we call fusion of sensors is the way basically to move forward in autonomous driving. That's redundancy at the sensor modality level. We will focus on radar, mentioning only that the key trend in LiDAR, this is an emerging technology that will come up, is how to reduce the complexity of a sensor that you might see on these Velodyne type of Google cars, that big boxes like this, into something that can fit in the car in a sort of a sub $100 price per unit. That's the big challenge there. So automotive radar. Well, some people tried that before. It's an interesting idea, but that's not what the real thing is about. So how it looks today? Today, we're in a phase where some leading OEM manufacturers will introduce the level 3 cars on their flagship products, where they use multiple different sensors, I said, LiDAR, camera sensors, many of them around. This is Mercedes and this is BMW. And this is where we're standing today. And it's important to realize that the aesthetics of the car play a really, really important role on the adoption of sensors. You cannot just have a sensor sticking out of the car. It just has to be small and be embedded into the car, and that brings additional complexity. Typical example is the bumper reflection. Your radar behind the bumper, it just hits the bumper, gets all the self-reflections and creates major difficulties in dynamic range and things like that. There are several different situations or use cases, we call them, where a car actually, or the radars of the car will be optimized for. So blind spot detection, lane change assist, cross-traffic alert, so you're having a parking, you're getting out of the parking and there is, people walking or another car. Adaptive cruise control for highways, the safety bubble, the cocoon as we call it, and the emergency braking. So these are typical cases. But there are 2 cases specifically that currently are at the epicenter of attention for the next generation radars. And these are, on the left, OEMs have the need at the moment to put to us, we're at tier 2, making the chips, not the sensor. Sensor is made by tier 1s, where you need to provide a system that is able to detect a very small object, such as a motorcycle, and also a vulnerable object next to a big truck at a very long distance. Think about 300 meters, 400 meters. And this is a tremendous difference in dynamic range between the two. That's one use case, and could also be like things that falling off the truck, like you have in the US, these pickup trucks. People put their stuff in it and then they fall on the highway. So you need to detect small objects on the ground, basically, on the street. The other use case relates to environmental mapping. So you need to be able, with your radar, to have such precise capability to basically map your environment around you as you're moving. Maybe your GPS fails, you still have basically a sort of extrapolated location, but more importantly, to really see where you are on the street so that you can position yourself in. And this translates to need for extended range capabilities, better detection, angular resolution especially, and also mapping that into processing and algorithmic capability to be able to separate and classify. This is a pole, this is a human, this is a kid on a trolley. And that's not something that is happening in one step, there is an evolution to it. So, and it started from the early days of around introduction of radar for automotives, around 90. We had this radar cube. I will talk about that a bit later, a bit more. So radar cube is, think about it as the way a sensor actually captures its environment. That is, the larger the cube, the longer the range. The larger the resolution of these small cubicles here, the more refined the space in the volume around you can be detected with a given SNR. In that cube, it started with being very coarse, 24 to 24.5 gigahertz band. These were the resources available 20 years ago, or 13. Being able to see a big car, that's it. Gallium arsenide type of systems, very discrete, very big, bulky, and very expensive. The big bang started moving to 79 gigahertz, so where spectral resources, so wavelength relates to velocity resolution, bandwidth relates to range resolution. So the cube potential was bigger. You can really achieve much more resolution. And in that, initially the step to 76 to 77 for long range, before the 76 to 81 for the complete thing, was implemented with also another major disruption, that was introduction of silicon technology, so silicon germanium. So that increased the available cube that you could achieve. But the real thing that actually brought a major transformation in the industry was the introduction of RF CMOS. We did that in XP in 2010. That was the first RF CMOS chip, and when we went to our customers to show that, they simply would not believe it. They said, no, you're doing it wrong. There's something wrong. You cannot make with RF CMOS something where you need silicon germanium reliability and all that stuff. So that thing, introducing RF CMOS with the combination of what we call fast chirp waveform, allowed basically to span out multiple different use cases, a long-range radar, short-range radar, corner radar, and especially because RF CMOS allowed to bridge the gap with high-performance CMOS microprocessors, allowing today to make one chips, SoCs. And that's really what really accelerated. Today, if a company is not on RF CMOS radar at 80 gigahertz, it's a company that will not exist for long. That's how disruptive that introduction was. But it doesn't stop there. So we're actually moving towards level 2, level 3 with RF CMOS and this type of systems, but we need to achieve more. And the question is how to expand resolution more. Do we need new technologies? Do we need to move to a different band to go maybe to 140 gigahertz? So that's really the interesting question. So what OEMs want is basically seamless scalability. Remember, OEMs, they are integrators. They take so many different technologies and they put them together. It needs to work as something that you don't experience as faulty. So when we give radars and chips, they all have to be integrated, and we're talking about multiple different radars. So front radars for urban pilots, corner radars to see around the corner, high-performance imaging radars to really map the environment and detect sensitive users, radars on the sidecars, you see a motorcycle passing you next to you, and rear radar, avoidance collision systems, or really detection of high-speed vehicles approaching you. This is where we are today. So NCAP regulations basically dictate what OEMs put on the car. That's it. There's a basic front range radar and two blind spot detection radars. Moving forward is the introduction of corner radars. And of course, there is a range aspect to it as gradual evolutions. 4 corner radars to be able to detect the situation around the corners. Then we move into adding long-range radar and rear radar. So basically, the introduction of 360-degree sensing, and finally, imaging radar. Of course, this is happening in gradual steps in the industry, so it's not something you buy tomorrow. And this is gradually moving from very high expensive cars, step by step, into mainstream cars. So by 2030, market predictions are that practically 20% of the new cars sold will be on level 1, having, of course, still a combination of radar, camera, and LiDAR systems. LiDAR 0, it's too expensive still. Moving to level 2 and level 2 plus, capturing practically 50% of the market of the new cars. And level 3 to level 5 cars, basically a mere 4%, which is something to be increased in the future. So a radar, I said aesthetics are important, needs to fit in a size of a core credit card, basically. An imaging radar, maybe make it a mobile phone, that's it. And the available resources you have is you have a spectral resources, here is a wavelength, it's 7651 gigahertz your band, and you have to operate within a 40 to 50 millisecond cycle because that's a safety aspect. That's it, that's your time, frequency, and resources in space. But you need to fit in systems that, as I said, they do 4D scanning. They have a flexible field of view. They are compact and low cost. They are able to deal with interference. If everybody has a radar on the street, then you can easily blast the radar of your fellow other rider or vehicle and simply jam it, and you have no detection. They need to be connected. And very importantly, they need to be safety. There is safety involved, there is reliability involved, they need to work for 10 years, 1 ppm, this is the target of automotive. In extreme conditions like 150 degrees Celsius, and so all that needs to fit in that small box without special liquid cooling and all that stuff. So now, in order to move a bit further into the deeper technologies, let me just spend a few words about the basic principles of radar. So the waveform typically used is what we call the frequency carrier wave modulated radar, FMCW, that's the keyword. So you have a transceiver here, it says a transmitter, typically quadrature, a PA, antenna, receiver, and what you do is you're transmitting a chirp. A chirp is a frequency modulated signal. It starts with a slow wave and then it starts accelerating from, if you see it in a time frequency domain, it starts at F0 to F0 plus bandwidth. It can be 1 gigahertz, can be 4 gigahertz, can be anything. As you're transmitting it, it reaches a given range, it hits the target, comes back. It comes back, of course, with noise, attenuated, a bit distorted, and all that stuff. And you receive it. So you have a time delay. But now if you demodulate it here, the transmit signal as it evolves with the receive signal as you receive it, practically you will see that time difference translates to a frequency difference. That frequency difference is small. We talk about millimeter waves going to megahertz. So you actually come up with a tone here. This is a fixed. You have a fixed difference, a fixed linear chirp. You get a fixed difference, a tone. That tone, let's say it's 10 megahertz. It's here. And then you sample it. You sample it, and basically you can start processing it because that is a detection of an object in range. And the other thing we do is by having it pulsed, it means we can separate the SNR, the longer the pulse, the better the SNR, from the bandwidth, which means the higher the bandwidth, the more refined the resolution. And if you have many pulses in sequence, you realize that as an object is moving, there is a Doppler effect, the sighting on the street with when let's say, a police car is moving around. So that difference in small frequencies, you can use from a chirp to detect velocity. And then you add many of these components together, and you can detect angle of arrival. I will talk about that a bit later. So I mentioned fast chirp. So fast chirp, you could have 40 milliseconds, I mentioned, for a complete radar cycle. You take 20 milliseconds to detect, 20 milliseconds to do number crunching, processing. 20 milliseconds, you can have a very long pulse. Fine, that's the old-fashioned way. But you can have many small pulses. That's the fast chirp. It decouples one of RF noise issues with thermal noise issues. It decouples Doppler with range very effectively. It's very effective for multiple targets at the same time. It has redundancy. You lose a chip, you don't care. You have the next one. So it gives a lot of extra redundancy in the system that you can actually use to make a much better sensor. So in the end of the day, you construct a cube. So you get your ADC output. You make a range FFT, just an FFT. You just want to detect the peak at which frequency bin it is. Frequency bin is a range bin. That's called range gauge here. But then I repeat many chirps, and I do Doppler FFT on top on its range bin. And then I come into the Doppler For a given range bin, I have Doppler information. And if I have many channels next to each other to do beamforming, then I can also do angle of arrival estimation. And that makes the cube. The smaller the cubicle, the better the resolution. The larger the SNR per cube, the better the detection. So here is how it's usually looking like. This is a range, and this is a Doppler, and on vertically we have the SNR. If the SNR is high enough, we have a slicer. Beyond 15 dB SNR, there is detection. And then we create a target list. It's called a target list. But now, how do we detect two objects if they are at the same distance? Remember, a radar sees the environment in a radial distance. So you can only detect two objects in the same radius. So you need angle of arrival estimation. We can do beamforming techniques, so use multiple elements to detect the angle of arrival. It's a phased arrays is one example of it. Typical defense radars are operating this principle. The problem is you need high resolution. Therefore, remember, 1 sub-degree resolution means like 4 meters at 250 meters distance to detect two objects. So you need to go below 1 degree. And if you really make the math, 1 degree means 200 physical elements. That's a lot of elements that you need to operate simultaneously, put them in lambda over 2 spacing on a small area like a credit card. So, let alone the power dissipation. So something needs to be done for that, and the industry is using currently what we call coherent MIMO, multiple input, multiple output. What does this thing mean? You take 4 transmitters, you offset them, and you take multiple receivers, and basically, if and only if you're able to distinguish each transmitter individually on the receive side, you can actually multiply basically the different paths. So make a spatial convolution, because now the permutations around all these elements give you a virtual array, different distances on the receive side. But if you're able to detect the different individual contributions from the TX. So you need what we call orthogonality on the transmit waveforms. The good thing is that here I need 4 plus 4 physical elements. Here I have 8 achieved, 16. And if I want to scale it up to 2,000 elements, you realize the benefit is enormous. So virtual arrays, MIMO, is the path to really achieve efficient angle of arrival detection. How would it look like? You have a PCB here, a chip with 3TX, 4RX, patch array antennas, and then basically you have on the right side a virtual array that it's like implementing an antenna series of twice as large actually as you have on the left. But still the challenge is high because you still have a huge issue with power dissipation. The other point is that you have to find a way, as I said, to distinguish the different transmit waveforms. That's a key differentiation point of a radar. How do you do that? Multiple different ways. There is no single winner. Each one has pros and cons. You can actually start, let's say, take 4 transmitters and you switch on the first one, everything is switched off for the rest, then the second, then the third, and the fourth. That's fine, full orthogonality, it's simple, but you don't have 4 simultaneously transmitting, you have 1, so you lose 4 times the range. That's what you get. And you also lose 4 times the velocity because you have to wait a long time before you get a second chirp of the same transmitter. Okay, so you can do something else. You can do frequency division. You transmit at different frequency offsets. That's also good, but you're compromising your baseband. You're compromising your range. Or you can do time difference. Same story. Another way is to start introducing coding. So I have my transmitter 1 with a different code modulated, transmitter 2 with a different code modulated, chip to chirp. That's called slow time CDMA. Or Doppler division multiplexing. Basically, we can multiplex in the Doppler domain, different small velocities offsets. That gives the benefit of transmitting simultaneously, but you compromise Doppler performance. And finally, you can do full CDMA. You just transmit code streams with excellent autocorrelation properties and excellent cross-correlation properties. So that is, if you have 2 waveforms from different transmitters, they reject each other. They don't have a correlation. Easier said than done. You have issues with coexistence, with legacy of MCW, and a lot of interference. So part of the game is which waveform to use and how to make your hardware to actually make it. I mentioned RF CMOS performance, and what is so nice about RF CMOS performance? Well, first of all, you might have RF-CMOS as a technology platform that actually doesn't have necessarily the best FTF max that people working on millimeter waves typically associate with. But if you really think about it and look at plots like this, you will see that you can have much higher FTF max. So this is red and blue is at 40 and 28 nanometer nodes representing F max and FT. And here we see the current density. So I can bias method compared to a bipolar mass production type of millimeter wave process node here. So you can lack the maximum FTF max, but you can get higher FTF max if you bias the transistor at a low current density. Low current density means low power dissipation. The whole game in using RF-CMOS is to find ways to save losses. That is, to find ways to simply eliminate how much signal you're losing. You don't need to generate 20 dBm signal and lose 5, just generate 16 and lose 1. And you have the game. And that is not only the device, you have to engineer the device, you fragment it, you combine it in an optimal way, you need to satisfy reliability constraints and all that stuff, which is a complete, let's say, expertise by itself. And also differentiate in the way you do the passives. Millimeter wave circuits are resonant circuits. So you have tanks, and you're losing a lot if you don't have the right inductor transformer. So by optimizing the way you do that geometrically, you can get substantially different quality factors. It's a factor of 2. This is an external vendor type of inductor. This is an internal optimized one with a given design process in mind. And also the way you do matching. So all these techniques you have to reconsider in a way that actually you reduce losses. Typical transmitter power efficiency on an automotive radar, best case 10%. 10% means for every watt I'm spending DC, I get 100 milliwatts of signal. So you have to really see that multiplication factor of 10. Remember how many transmitters I need. So saving energy, saving signal is essential. But you keep going. So you have RF-CMOS, so you can do fancy stuff like calibrations. So a phase rotator. So here you see a 6-bit phase rotator changing the phase of a millimeter wave carrier with 5-6 degrees of resolution to make DDMA. But you can calibrate. So you don't need big devices. You can use RF-CMOS to make small devices, therefore reduce losses. You don't need to generate one PA stage with 15 dBm. You can use power combining in the package, on the die, with smaller PAs. So all this interplay of let's say, approaches, you need to tune the design to the process and not do the same thing. Same thing on the baseband. You use a passive switch. CMOS technology is good for passive switches, for sampling, these type of things. And then you make a better converter, data converter, so you can recover your noise figure substantially. A very important point is chirp synthesis. You need to be able to make very fast chirps. And you cannot do fast chirps with a process and very low noise chirps. That doesn't give you 5 volts. So what do? You can use transformations. So we're making a PLL, for example, fractional PLL at 10 gigahertz, or you can use a thick oxide device. You use the redundancy of the process. You can use 2.5 volts, but then use multiple tanks, high performance, high bandwidth tank. And then you can start thinking, well, I have a compressed signal. It's compressing full scale. That means it has a third harmonic inherent into it. Why don't I design a frequency multiplier, basically an impedance matching network with inductors, full passive, that tunes on the third harmonic. So suddenly I have a multiplication without spending the power for it. And then I can use another multiplication by simply forcing that into a transistor and having nonlinearity. So I do 2 multiplications without adding 1 over F noise. These type of transformations are essential in the way today we are making this type of high frequency and very fast chirp generators. But it moves further. You have a silicon, and silicon has good thermal diffusion properties. So here you see a temperature plot across the whole chip. It's 3 transmitters. You can see the hotspots here, and the temperature falling basically gradually around the transmitters. So good thermal properties of the process combined with good thermal properties of the package. So that means low thermal resistance. How much, if I have 1 watt, to how many degrees does it translate in the external world? That's essential. So you need EWB technologies, flip chip technologies, and also by making things smaller, it means that you don't have all this extra need for underfield device for reliability, board level reliability, cracks. So keep things small. And that means you keep also losses small. You put all these things together, and then you come to a chip like this. This is an SoC example from NXP. We just released that. It's the flagship product at the moment of our radar business. I started working on this one 5 years ago. That's the time it takes to really have a product cycle in automotive. Once you do your research homework beforehand, it consists of 4 transmitters and 4 receivers. It has multiple different processors for safe computing, so ARM Cortex, M7. It has a specialized radar signal processing toolbox. You give that to tier 1, they can program whatever fancy algorithms they want. Multiple different interfaces, and also, of course, a hardware security engine and functional safety engine. So that's how it looks like. It's as big as, said, 5 by 5 centimeters if you put in a sensor. You see here the patch antenna array, and the chip is actually back here. It's not visible, and you can see actually how the chip it looks like on a finger. So it has a very small chip and a bit larger sensor to it. Now, this is the thing I showed you on the left side, but there is more you can do at the antenna level to make things better. When one of these emerging technologies in the field is called waveguide antennas, 3D waveguide antennas. So what you do is, you realize that the patch antenna is an antenna of several centimeters that has many losses. It couples next to each other. A loss on a PCB means I need to use an RF expensive material like Rogers 3003. So you make an imaging radar with many of these things, the cost is enormous, the space is enormous. So why don't you simply do waveguides? Waveguides means low loss, zero loss. To do that, you need a specialized antenna, but you also need to be able to launch the wave directly from the die into the waveguide. So nothing in between. So that's the construction we have here. We have the die, it's a flip chip. You go through a substrate of the package, it's a flip chip package, and directly you radiate through a hole in the PCB here where the antenna is. It's a 3D printed antenna, and you can see it here. We did that with Huber & Schöner, is a partner of ours specialized on antenna technology. The benefit is enormous. It's around 11 to 12 dB of SNR improvement. You do nothing on the chip, you just improve your antenna, you get better directivity, you lose the losses, you have less power consumption, and basically you get a much longer range. So here with experiments, you can see detecting motorcycle approximately up to 400 meters compared to 200 meters without this antenna. So that's how important the antenna is, and that's the trend basically. You can do more by integrating the antenna on the die. You can do, for example, what we call artificial dielectric structures. So you have your die, you radiate through an opening, and you use the metal stack of your package. You put some small metal patches in a given specific way, and with that you can bend the wave and radiate on a given angle. So that's what you see here for azimuth and for elevation. The difficulty here is that you cannot scale that up in a package. So this is not picking up yet at the 80 GHz band, but it is essential for moving at high frequencies. But still is a capability that one needs to explore. Imaging radar. So let's take what is it? Let's see on the left the 3x4 system I showed you before. Basically you have 12 degrees of resolution. So this is my colleague Feike. We did an experiment, so we're just like 5-meter range or a bit more. And you can see a detection here. This spot is a detection. Remember the high SNR slicer, this is a confirmed detection, but you don't have the resolution to really see anything further. But if you use 192 elements for 4 of these chips in cascade, practically you can have 2 degrees of resolution. And then you can start seeing detections in the arms, detections on the waist being separated. So you can start thinking, hey, I can make classification here. This might be a human. And this is why you need to have so much better resolution. Typical numbers, mainstream or not mainstream, but actually highly optimized MIMO systems around 200. Some peak in numbers is 2024, Arbor systems, for example, in number of channels, and a lot of high processing computing. Optimized MIMO means we're exploiting architectural redundancy. Therefore, we use, let's assume we want to reduce the number of channels to save power. So instead of using brute force 2000 channels, I can use 192 channels, but then start overlaying at a sensor level different fields of view, like here, I have a system with 3 different antennas. I use a lot of directivity, and I overlay them. So the fact that I have common fields of view gives me ability to solve ambiguities. I'm interleaving different type of chirps. And that combination, you see here 4 cascaded chips synchronized, waveguide launchers on the PCB here. So that's the board, through a stabilization port here onto the antenna, and on the bottom the complete macro procession. This is a box, yeah, around as big as a mobile phone. And that's the way basically to reduce also the number of channels without needing to resort to really huge physical arrays. With that, we made the video you've seen in the beginning. So this is a more elegant imaging radar system consisting of indeed 4 cascaded chips using our latest transceiver chip. And I want to show you a little bit, a small video now on how it looks like in detection in real life or imaging. So let's go to see that one. Oh, it plays very well. So you can see here at the bottom how the radar practically sees the environment as it moves. And at the bottom you see the objects. So you will see the curves of the road. You will see actually different bushes or trees here on the left side. And so you will see also some vehicles approaching. So the car has a 360-degree cocoon, so corner radars, imaging radars. So it can really detect all things happening around it. And if your eyes is sharp, soon you will see also the bubble and the field of view, but it's very difficult to see that from here. So now there's a car approaching from the back, you start seeing the detections, and you see the more it approximates, it comes closer, you will start seeing that there's another car just crossed by. And that's what we typically call imaging, mapping around the environment. So you see that car coming back on the backside here. You see the detection list increasing, more hits. It's a very typical thing for radar. You cannot see the whole thing. You just see multiple spots around it. And that you need to put in an AI engine and a classification engine to really, make up a certain certainty that this is a... Okay. So I hope you get a little bit of a picture. I think here is visible the field of view, that gray part, how this thing looks like in real practice. An important point to mention is the radar interference. It is a topic heavily been discussed. It's a topic that requires a lot of attention because you have so many devices, one jamming the other and all that stuff. So what happens in practice is you have a chirp. This is the blue thing here, the blue line. You have a delayed chirp, that's your target. If you demodulate, it's coherent. You see this black line here that you're sampling. But if you get another radar crossing by, it could be an arbitrary slope, an arbitrary delay, you just don't know anything about it, and not coherent. So when you demodulate it, because you don't convert it with your own reference, you will see just a burst. If the frequency difference is large, then it's out of frequency, you filter it. But if it isn't, the part it isn't, that really jumps your radar. And you can see it in a range Doppler plot. So here is the detection, and this is what you see, basically another object interfering. There are multiple approaches to mitigate that. Random chirps, a compass method, that is, you have a rear radar and a front radar, they have different polarization. Or you're changing the way your radar emits in different bands as you're turning. So it's really different angles, different sub-frequencies. And finally, band regulation. But nobody wants to do that so far because waveform is a differentiation feature. It's not like communication. We have a standard. There is no standard. You have a band, and how much you're allowed to emit, you do whatever you want in it. And that's how they're making their money in let's say, in a tier 1 level. Last part, coming to the end, is, well, there will be a point where we use the best of technologies, we use the best of ideas to bridge the innovation gap of where we are today to how much this 76 to 81 gigahertz band allows us to do in such space and with this time. And there is no more to do there. What then? Well, we can go to higher frequencies. We've done that before. We went from 24 to 76, and we live in an evolution of 20 years now, maybe another 10 or 20. So we can go to sub-terahertz imaging, or before that even, to 100 to 300 gigahertz radars. Very refined resolution, small cubes. We can even move to optical LiDAR, as I said. These are things we're exploring. These are real demonstrators. How to make it small, that's the big bet. But also there are new opportunities, joint sensing and communication, augmented automotive safety, meaning that you have use cases, you have base stations, poles, etc., giving to the car a sensing capability, but through augmenting. That is, you get buildings with sensors, they sense the situation, send it as a message on the car. So many use cases that actually come up, and this is just how a typical of these beamformer chips could look like. This is a 6G demonstrator we have in the company, will be demonstrated in the Congress with Ericsson in a few years. You need to do a lot of things to get there. First of all, it's not easy to generate signal power, so you need a wireless optimized technology. CMOS might not be enough, you need something else. How to do that? Will it be FinFET? I don't think so, because you cannot generate, but you need FinFET for mixed signal performance. Will it be FD-SOI? Maybe. Maybe, however, you can use indium phosphide to get really 900 gigahertz of FT-SAF max, and you can use a scaling of BiCMOS technology. How to radiate effectively? I said, no money in the middle. You cannot go to a strip line anymore 140. You lose all your signal just going through a ball, a copper pillar or a ball from the die to the PCB. Forget it. You need to radiate from the chip somehow and use directivity. So we go to focal planares, lenses, millimeter wave lenses, how to do that to connect it to the chip. Heterogeneous integration. Well, I cannot do everything with one node, so why don't I split in chiplets? Well, I can do different things in different nodes. And then I also start butting different wafers on wafers, so I can do my SIGI for long range power amplifiers, but I can do my mixed signal data converters and beamformers on FD-SOI, for example. And finally, there is an explosion of data processing. There is more channels, more effects, more processing needed, higher resolution. So in the end, how do you deal with all that? You need, the 5 nanometer processors, you need the 2 nanometer, you need carbon nanotubes. It's a big thing. So it's a big explosion that forces you to start thinking, maybe I should simply exploit the redundancy of inference. A radar is a system with inference. It's not a communication transmitting bits per second, information fixed. It's something might happen, and for the rest, I'm burning power for nothing. So these are the type of different paradigms that actually are at the moment currently explored. And with that, I come to my summary. So millimeter wave automotive radar is evolving towards 5-level automation. The market is growing strongly, and there's a lot to do there. Innovation is the driving force behind that. Introduction of new processes, new architectures, advanced packaging. And I said, this will keep us going for quite a long time still. There are fundamental barriers, boundaries. The moment we start getting close to that, we need to consider shifting to a new node. It's only a matter of question of when rather than if. And finally, when we do that step, I think from moving everything to an SoC and all this CMOS integration direction we had for many years, we now move into a new paradigm also with the packaging platform becoming the cauldron of innovation where everything is coming together. With that, I conclude. Thank you for your attention, and the floor is open for questions.
Thank you, Professor Doris, for the interesting speech. He started from the application, then to the systems, then to the circuits, and finally to the new technologies which will be used in the near future for the cars of 2030, maybe. If there are questions, please.
My question is this: since more and more cars are going to have radars on them, how do we, how is it possible to actually recognize the other? Let's say we have two cars. They both have radar, so one is trying to detect the other by reflecting the signal on the car. How do we keep them from not interfering with each other's signal?
Well, that's a good question. So think of the radar you have. It's a coherent system. So you're transmitting with a given fixed carrier. It's locked to a crystal oscillator, and you're receiving coherently with the same signal reference to your own clock. A radar from another source is incoherent. So it's not captured as something that when you demodulate it, it will be a tone, a fixed tone. Because it is random, it moves left, it moves in phase, moves in time. So in that sense, it becomes an SNR problem. That is, I get something in, and it distorts my SNR. Or I get something in, it's so strong, and I need to reduce my gain so that I don't clip. Or if I clip, I replace the clip signals. I said I have fast chirp. I can have a few things going wrong. That's the type of approach is used to simply not mix up the two radar systems together.
Thank you.
Yes.
Thank you for the presentation. Just a quick question about the in-chip antennas and the waveguides. Do you rely only on the aperture of the signal propagation in this particular use case, or you actually use the beamforming with multiple waveguides in an array?
So I said it's a MIMO system, so you use multiple antennas on transmit, multiple antennas on receive. So a typical waveguide 3D antenna will have multiple of them. I said it can be 16 by 16 or 4 by 4, so a total of 8 or 32 antennas. So you will have to radiate into these antennas. That's how it is used. So you really have, this is not a phased array system, so you need to place them in a given configuration, and we'll go into also another interesting field. It's called a sparse array. You don't just shift them around, you shift them in a very specific way to guarantee low side lobes and everything. And you make your antenna, your waveguides fan out through a metallized plastic type of material. They fan out to where the locations of the antenna should be to guarantee indeed that performance on the electromagnetic field.
Thank you.
Concerning the safety of the humans that are around the cars in a city, in a future city where every car has many radars, people, pedestrians, will receive a lot of radiation from all the cars. How safe is for the health of the people passing through in the city?
Yeah, this is practically the only real regulation there is out there. Well, maybe not the only, but at least the most dominant one, which limits the effective radiated power to approximately 10 dBm per transmitter, and total 30 dB, the ERP actually around the 30 dB. So that's really the key point of limitation, how much you can radiate, which means you cannot just start blasting as much energy as you want to get your SNR at a distance. You have to be smarter to use the available SNR or the available power, because it's limited, as much as you can, as good as you can. Similarly, you go to LiDAR systems, they look, for example, eye safety. And then you say, look, I need to choose 1550 nanometers for indium phosphide LiDARs because these are safer compared to using maybe 900 nanometers of LiDARs because the retina absorbs too much at 900. So these are indeed the type of first discussions and decisions in the regulations or options before you get in the industry and start making all the stuff.
Yes, but for one car, you can limit the amount of energy. If there are many cars, the one person will receive from many different cars.
Think about that a radiated wave attenuates with 40 dB per decade. It's 20 if you have a system at the first reflection and another 20 coming back. So yes, you will get energy, but you're not getting the energy that the radar radiates. You're getting a substantially attenuated version, and then you need the statistics around you. How many cars can be so close by to you to radiate directly on you, on the main lobe, those 10 dBm? So it's really fading out really fast.
Somebody else? Another question, please. Okay. I have a question.
One more question there.
I have a more generic one. I mean, in particular, we have a well-known car manufacturer in the world that says that doesn't rely at all on LiDAR and millimeter wave radars in order to achieve higher levels of autonomy. So they only rely on computer vision. Is there, I mean, something concretely limiting as a limiting factor to reach these levels of autonomy solely on computer vision?
Well, that's not the case. Even that manufacturer changed its mind, and they're making their own radars now.
Okay, thanks.
Another? So, last question from me. We don't discuss about the cost of such a car because last year's cars are very expensive. So, do you have any idea, for example, how...
Right. A complete radar sensor, to make sense, needs to be below $30 per piece.
Below $30?
Yes, the complete sensor.
Okay.
You have to see, of course, that an imaging radar sensor, it's a high-end thing, so today it will cost much more, but tomorrow it is also to cost as much as $30. Otherwise, it won't be easily adopted on the mass market cars or vehicles. Yesterday I was in the visit on an OEM, big OEM, that is also making very nice motorcycles, by the way, and I've just seen the first big radar, imaging radar on an expensive motorcycle, but it's an expensive motorcycle. And that means basically if you want to bring that back to a level where every single motorcycle or car has it, the price of such an imaging radar I've shown you needs to really be decimated down. And that's a really, really difficult thing currently. That's why we need new technologies, new fabrication methods, lower material, and shrink the size.
And you think that with new technologies such as indium phosphide or gallium arsenide, it is possible to be applied in this application because we need material, raw material.
Right, and large wafers.
This is no silicon.
I will give you my view, and I don't think there is a say in the semiconductor business that says if you can do something on silicon, it will be done on silicon. And if you can do something in CMOS, it will be done in CMOS. So I think first somebody needs to prove that we cannot do it in silicon germanium for, let's say, this 300 gigahertz, 140, and in advanced CMOS like FD-SOI or what have you, before we start thinking about making it. There's fantastic work being published out there, and some foundries are really making it. But in the end of the day, the economics of scaling up indium phosphide are very complicated. The differences in the wafer size is enormous. 300 millimeter wave, so 300 millimeters wafers with a quarter of it is not going to get us anywhere. So I believe it's going to be more in the direction of scaling up silicon germanium type of devices, combine heterogeneously integrated with RF CMOS devices rather than simply expecting. Maybe for specialized applications, you might get away with indium phosphide.
Okay, thank you. Thank you very much for your very interesting speech and that you have accepted this to give this talk by traveling from Germany, I think. Yeah.
Yeah, I was on a trip with multiple transitions. So I came last night at 12. Thank you very much. It was my pleasure. It was my pleasure really to be here. So thank you very much, all of you.
Καλημέρα και από μένα. Μπορούμε να ξεκινήσουμε την ημέρα καριέρας, η οποία περιλαμβάνεται στο πρόγραμμα αυτού του συνεδρίου. Και η πρώτη ομιλήτρια είναι η κυρία Κατερίνα Παπακότα από το Career Office του Αριστοτελείου Πανεπιστημίου, την οποία και ευχαριστούμε πολύ για τη συμμετοχή της, και η οποία θα μας παρουσιάσει θέματα συγγραφής και... όχι, οκ. Οκ, έγινε. Σας ευχαριστώ πολύ.
Λοιπόν, καλημέρα και από μένα. Χαίρομαι που είμαι μαζί σας και θα σας παρουσιάσω τις υπηρεσίες του Γραφείου Διασύνδεσης και πώς αυτές μπορούν, του Αριστοτελείου Πανεπιστημίου Θεσσαλονίκης, και πώς αυτές μπορούν να σας βοηθήσουν να προσεγγίσετε τους επαγγελματικούς σας στόχους. Αναρωτιέμαι αν έχουμε εδώ και εκπροσώπους από τις εταιρείες που είναι έξω. Έτσι, και αυτό το ρωτάω, μήπως κάποιο θα ήθελαν να ενημερωθούν και για τις υπηρεσίες που μπορούν να έχουν οι εταιρείες για να μπορέσουν να βοηθήσουν και αυτές τη σύνδεση του Πανεπιστημίου μας με την αγορά εργασίας. Ευχαριστώ τον Οργανισμό της Χετίας για την πρόσκληση και ειδικά τον κύριο Χατζόπουλο που πάντοτε έτσι έχουμε μια καλή συνεργασία. Είμαι η Κατερίνα Παπακότα, είμαι ψυχολόγος και εργάζομαι στο Γραφείο Διασύνδεσης σαν σύμβουλος σταδιοδρομίας. Το Γραφείο Διασύνδεσης είναι βέβαια μία υπηρεσία του Πανεπιστημίου μας, το οποίο είναι το μεγαλύτερο πανεπιστημίο της χώρας, και θέλω λίγο να σταθώ σε αυτό, με την έννοια ότι έχει 41 διαφορετικά τμήματα και, όπως καταλαβαίνετε, πολλές και διαφορετικές ειδικότητες. Είμαστε ένα πραγματικό πανεπιστήμιο. Τώρα, ειδικά το Γραφείο Διασύνδεσης είναι μία υπηρεσία η οποία είναι ενταγμένη στο οργανόγραμμα, λειτουργεί από το 1998 και έχει σαν στόχο την σύνδεση, γι' αυτό λεγόμαστε και Γραφείο Διασύνδεσης, τη σύνδεση των σπουδών με την αγορά εργασίας, και κύριος στόχος μας είναι να βοηθήσουμε τους φοιτητές και τους απόφοιτους του Ιδρύματος στην ομαλή μετάβαση από τις σπουδές στην αγορά εργασίας. Οι κύριοι στόχοι μας είναι αυτά που αναγράφονται: η πληροφόρηση, η υποστήριξη, η δικτύωση και η ενθάρρυνση. Σε αυτούς τους δύο άξονες, δηλαδή στο Γραφείο Διασύνδεσης μπορεί κάποιος να πάρει πληροφόρηση για τις σπουδές, πληροφόρηση για την αγορά εργασίας, έχουμε τη δυνατότητα για συμβουλευτική υποστήριξη, τόσο σε σχέση με την μισθωτή εργασία, όσο και προσπαθούμε να ενθαρρύνουμε την επιχειρηματική δράση κάποιου. Πιο αναλυτικά, μπορεί κάποιος να βρει πληροφορίες για μεταπτυχιακές σπουδές στην Ελλάδα, στο εξωτερικό, στις διάφορες χώρες. Στην ιστοσελίδα μας συγκεκριμένα υπάρχει μια βάση δεδομένων που ενημερώνεται καθημερινά με τις μεταπτυχιακές σπουδές στην Ελλάδα, ενώ διοργανώνουμε διάφορες εκδηλώσεις για τις μεταπτυχιακές σπουδές στο εξωτερικό. Επίσης, στην ιστοσελίδα υπάρχει μια βάση δεδομένων η οποία ενημερώνεται καθημερινά με τις δυνατότητες παροχής υποτροφιών, οι οποίες μπορούν να αφορούν τόσο τις προπτυχιακές σπουδές, όσο και μεταπτυχιακές και διδακτορικές. Επίσης, παρέχουμε πληροφόρηση για προγράμματα κινητικότητας. Βεβαίως υπάρχει στο Αριστοτέλειο το Γραφείο Εράσμους, που παρέχει πληροφόρηση για τις δυνατότητες τόσο για σπουδές όσο και για πρακτική Εράσμους, και με τους οποίους συνεργαζόμαστε. Όμως υπάρχουν πολλά διαφορετικά προγράμματα κινητικότητας, διεθνούς, δηλαδή το να πάει κάποιος και εκτός Ευρωπαϊκής Ένωσης, τόσο με διάφορες συνεργασίες που έχει το ΑΠΙΘΙΤΑ, όσο και από αυτές τις πολύ δραστήριες ομάδες, όπως είναι η IEEE, η ΑΕΣΤΕ, η BEST κτλ. Οπότε έχουμε πληροφορίες και για αυτές τις δυνατότητες. Και βεβαίως, καθημερινά αναρτούμε και ανακοινώσεις σε σχέση με σεμινάρια, συνέδρια και οτιδήποτε αφορά τη συνεχή επιμόρφωση. Αναφορικά με την πληροφόρηση για την αγορά εργασίας, στην ιστοσελίδα μας μπορείτε να βρείτε ανακοινώσεις από ανοιχτές θέσεις εργασίας, τις οποίες μας στέλνουν οι συνεργαζόμενοι φορείς, δυνατότητες για πρακτική άσκηση, εκτός από την θεσμοθετημένη πρακτική άσκηση μέσω ΕΣΠΑ, η οποία οργανώνεται από τα τμήματα και από το Γραφείο Πρακτικής Άσκησης. Εμείς ουσιαστικά έχουμε πληροφορίες για δυνατότητες πρακτικής άσκησης από αυτές που χρηματοδοτούνται από τις ίδιες τις εταιρείες ή διάφορα διεθνή προγράμματα πρακτικής άσκησης, σαν αυτό που σας ανέφερα από την ETCEI ή από άλλους φορείς. Και γενικά προσπαθούμε να έχουμε πληροφορίες για προγράμματα αρχικής απόκτησης αρχικής επαγγελματικής εμπειρίας. Έχουμε βεβαίως πληροφορίες και ειδικά για τους γιατρούς σε σχέση με την ιδιαίτερη σταδιοδρομία τους για τα αγροτικά και τις ειδικότητες τόσο στην Ελλάδα όσο στο εξωτερικό. Και στην ιστοσελίδα μας μπορείτε να βρείτε και προφίλ επιχειρήσεων, καταλόγους εργοδοτών, στοιχεία σε σχέση με τις διεθνείς και τοπικές τάσεις της διεθνούς και τοπικής αγοράς εργασίας. Το δικό μου κομμάτι είναι αυτό που αφορά τη συμβουλευτική υποστήριξη. Αυτή παρέχεται τόσο σε μορφή ατομικής συμβουλευτικής, μπορείτε δηλαδή να κλείσετε ένα ατομικό ωριαίο ραντεβού σε σχέση με τη σταδιοδρομία σας, το οποίο μπορεί να ποικίλει, τα αιτήματα ποικίλουν, είτε σε σχέση με τη διερεύνηση των επιλογών σας. Έχω τελειώσει ένα τμήμα, ηλεκτρολόγοι, φαντάζομαι είστε σήμερα εδώ ή από το τμήμα πληροφορικής, αλλά δεν ξέρω αν θέλω να ασχοληθώ με την ενέργεια, αν θέλω να ασχοληθώ με το computer engineering και αν θέλω να πάω στο data analysis, μπορούμε να συζητήσουμε μαζί αυτούς τους προβληματισμούς. Επίσης, σε σχέση με το να προετοιμάσετε κατάλληλα και αποτελεσματικά εργαλεία αυτοπαρουσίασης, να δούμε δηλαδή μαζί το προφίλ σας στο LinkedIn, να διορθώσουμε το βιογραφικό, να σας προετοιμάσω κατάλληλα για μία συνέντευξη κτλ. Η συμβουλευτική παρέχεται και σε επίπεδο ομαδικών εργαστηρίων συμβουλευτικής, είτε δηλαδή σε αντίστοιχα θέματα, πώς να φτιάξετε το βιογραφικό σας, πώς να παρουσιαστείτε στη συνέντευξη. Φέτος όμως, ειδικά, αυτό το εξάμηνο, έχουμε ένα καινοτόμο ή καινούριο τέλος πάντων πρόγραμμα 6 συναντήσεων σε συνεργασία με το τμήμα ψυχολογίας. Λέγεται «Βρες τη σούπερ δύναμή σου». Το πρόγραμμα αυτό υλοποιείται και σε άλλα πανεπιστήμια, στο Πάντιο, στην Ιωαννίνων, και είναι με όρους θετικής ψυχολογίας, πώς μπορεί κάποιος να βρει τα δυνατά του σημεία για να μπορέσει να σχεδιάσει καλύτερα τη σταδιοδρομία του. Επίσης, η συμβουλευτική παρέχεται και για τις ευπαθείς ομάδες και μια καινούρια υπηρεσία που έχουμε εισάγει είναι το δίκτυο Mentor. Αυτό παίρνει 3 διαφορετικές μορφές. Έχουμε το δίκτυο μεντόρων, που εδώ θα καλέσω, αν υπάρχουν εκπρόσωποι της αγοράς εργασίας με μεγάλη εμπειρία, μπορούν να γίνουν μέντορες και παρέχουν αυτοί συμβουλές στους φοιτητές ή στους νεοεισερχόμενους στην αγορά σε σχέση με το δικό τους επάγγελμα. Έχουμε ένα δεύτερο δίκτυο μεντόρων επιχειρηματιών. Είναι αυτοί που έχουν κάνει κάτι δικό τους και άρα θα στηρίξουν όσους ενδιαφέρονται να αναπτύξουν μια επιχειρηματική δράση. Και ένα τρίτο δίκτυο είναι οι junior mentors, που είναι αυτοί που έχουν πετύχει, μπορεί να είναι φοιτητές ή πρόσφατα απόφοιτοι, οι οποίοι όμως έχουν πετύχει κάτι που μπορεί να ενδιαφέρει κάποιον άλλον φοιτητή. Για παράδειγμα, έχω πετύχει να έχω μια υποτροφία από το τάδε ίδρυμα και άρα μπορώ να βοηθήσω κάποιον που θέλει να διεκδικήσει την ίδια υποτροφία. Έχω πάει εράσμους πρακτικής στον τάδε οργανισμό στο εξωτερικό και άρα μπορώ να μεταδώσω την εμπειρία μου, αν ας πούμε είναι, καλό να κάνει κάποιος σε σχέση με τα ηλεκτρικά αυτοκίνητα, αν κατάλαβα καλά την προηγούμενη παρουσίαση, στη Γερμανία ή σε κάποια άλλη χώρα. Τώρα, αναφορικά με την επιχειρηματικότητα, αντίστοιχα μπορεί κάποιος να υποστηριχθεί από το Γραφείο Διασύνδεσης σε επίπεδο ατομικό ή ομαδικό, είτε για την έβρεση χρηματοδότηση, είτε για τη δημιουργία του business plan. Προσπαθούμε δηλαδή να δώσουμε τη δυνατότητα στους φοιτητές μας και στους αποφοίτους ότι η επιχειρηματικότητα είναι μία μορφή απασχόλησης και εγώ θα έλεγα ότι πολλές φορές η επιχειρηματικότητα χρειάζεται και στη μισθωτή απασχόληση για να σκεφτείς καινοτόμες ιδέες, να δημιουργήσεις κάτι άλλο. Πολύ συχνά πραγματοποιούμε μεγάλες εκδηλώσεις. Η κορονίδα των εκδηλώσεων είναι οι μέρες καριέρας, οι οποίες συνήθως γίνονται τον Μάιο, λαμβάνουν χώρα εδώ πέρα στο ΚΕΔΕΑ, και η διαφοροποίηση είναι ότι εμείς τις οργανώνουμε σε συνεργασία με τις συνεργαζόμενες επιχειρήσεις, κάνουμε και εργαστήρια προετοιμασίας και όταν έρχονται εκείνες οι μέρες, έχετε τη δυνατότητα να περάσετε πραγματικές συνεντεύξεις. Οι εταιρείες δηλαδή παίρνουν το βιογραφικό σας, αξιολογούν και κλείνετε συγκεκριμένα ραντεβού, τα οποία λαμβάνουν χώρα εδώ έξω. Μεγάλες εκδηλώσεις είναι αυτές που κάνουμε επίσης για τις μεταπτυχιακές σπουδές στο ΑΠΙΘΙΤΑ. Και τώρα μπορώ να σας πω ότι 1 Νοεμβρίου θα γίνει διαδικτυακά η εκδήλωση για τα μεταπτυχιακά και τις υποτροφίες στο εξωτερικό. Ίσως ως μαθητές της Τρίτης Λυκείου να γνωρίζατε και την άλλη μεγάλη εκδήλωση που κάνουμε με την πενθήμερη για το τι σημαίνει σπουδάζω στο ΑΠΙΘΙΤΑ, που είναι για τους μαθητές της Τρίτης Λυκείου και σε συνεργασία με όλα τα τμήματα. Εδώ βλέπετε κάποιες έτσι ενδεικτικές αφήσεις προβολής. Ως προς τα δίκτυα συνεργατών, που βεβαίως προσπαθούμε να έχουμε ενεργά, αυτά αφορούν τους εργοδοτικούς φορείς και τα στελέχη των επιχειρήσεων, είναι δηλαδή οι συνεργαζόμενες επιχειρήσεις, οι οποίες ξεπερνούν τις 2.000. Προσπαθούμε να έχουμε συνεργασίες με μορφωτικά ιδρύματα των ξένων χωρών για να κάνουμε τις εκδηλώσεις μας, συλλογικούς φορείς επιχειρηματικότητας. Συνεργάτες μας θεωρούμε και τα μέλη ΔΕΠ του ΑΠΙΘΙΤΑ, οι οποίοι συχνά αποτελούν και το δίκτυο ακαδημαϊκών συμβούλων. Αυτοί είναι μέλη ΔΕΠ, οι οποίοι εθελοντικά έχουν δώσει τα στοιχεία τους στο Γραφείο Διασύνδεσης και παρέχουν πληροφορίες τόσο για τις προοπτυχιακές σπουδές, όσο όμως και για τις μεταπτυχιακές σπουδές στις εκάστοτε χώρες, αλλά και για τις προοπτικές απασχόλησης. Και αυτό γιατί είναι σημαντικό. Γιατί μπορεί κάποιος να έχει τελειώσει ένα τμήμα, αλλά να θέλει να κάνει ένα άλλο μεταπτυχιακό που προσφέρεται από άλλο τμήμα. Άρα πηγαίνοντας, ας πούμε, αν είναι κάποιος από το τμήμα φυσικής και έχει δει ένα ενδιαφέρον μεταπτυχιακό στο Πολυτεχνείο, πηγαίνοντας στον ακαδημαϊκό σύμβολο μπορεί να πάρει πληροφορίες σε σχέση με αυτό. Ή εγώ συχνά δεν μπορώ να απαντήσω στο ερώτημα είναι καλύτερα να κάνω το μεταπτυχιακό στο Πανεπιστήμιο της Στοκχόλμης ή στο Πανεπιστήμιο, της Χαϊλδεβέργης. Δεν είμαι του αντικειμένου, άρα οι ακαδημαϊκοί σύμβουλοι μπορούν να σας βοηθήσουν σε αυτό το επίπεδο. Τέλος, μπορούν να σας δώσουν πολύτιμη πληροφόρηση σε σχέση με τις προοπτικές απασχόλησης στον κλάδο. Σε σχέση με το αίτημα να ασχοληθώ με την ενέργεια, να ασχοληθώ με το computer engineering ή να ασχοληθώ με το data analysis. Βεβαίως, κάποιος που είναι από μέλος ΔΕΠ μπορεί να σας βοηθήσει σε αυτήν την λήψη απόφασης. Τώρα, το Γραφείο Διασύνδεσης έχει και ένα... προσπαθούμε να έχουμε διεθνή προσανατολισμό. Για το λόγο αυτό, συμμετέχουμε σε ευρωπαϊκά προγράμματα. Αυτή την περίοδο, μαζί με μεγάλους φορείς όπως είναι το Erasmus Student Network, το University Autonoma di Madrid, το University of Tilburg της Ολλανδίας, το LLP από τις Βρυξέλλες και το ELM από την Ολλανδία, τρέχουμε το Erasmus Careers, που είναι ένα πρόγραμμα που έχει σαν στόχο κατά πόσο μπορεί η εμπειρία που έχει αποκτήσει κάποιος από το Erasmus είτε σπουδών είτε πρακτικής να του φανεί ωφέλιμος στην σταδιοδρομία του. Έτσι, εμείς βοηθήσαμε για τα focus group, για τις δεξιότητες δηλαδή που αναπτύσσουν οι άνθρωποι που συμμετέχουν στο Erasmus. Κάναμε μια μεγάλη έρευνα για την αγορά εργασίας, κατά πόσο οι ελληνικές εταιρείες δίνουν σημασία στις εμπειρίες Erasmus και τώρα θα εκπονήσουμε έναν οδηγό για τα γραφεία διασύνδεσης όλης της Ευρωπαϊκής Ένωσης, πώς μπορούν αποτελεσματικά να οργανώσουν υπηρεσίες, ώστε οι φοιτητές που είτε οι εισερχόμενοι είτε οι εξερχόμενοι να είναι κατάλληλα προετοιμασμένοι για να αξιοποιούν το Εράσμους. Επίσης, το Γραφείο Διασύνδεσης αυτή την περίοδο ολοκληρώνει τις μελέτες απορρόφησης. Υλοποιήσαμε αυτήν που ηγείται και σχεδίασε η ΕΘΑΕ με το, το Ευρωβαρόμετρο, νομίζω, που αφορά τους απόφοιτους. Υλοποιήσαμε άλλη μία με τους τελειόφοιτους και την εμπειρία σπουδών που είχαν από το ΑΠΙΘΙΤΑ και 2 σε σχέση με την αγορά εργασίας. Η ερευνητική μας ομάδα ελπίζω ότι σύντομα θα έχει περισσότερα να σας πει σε σχέση με τα αποτελέσματα. Τώρα, το γραφείο διασύνδεσης που μπορείτε να μας βρείτε, θα σας δείξω μετά αν έχω λίγο χρόνο. Όχι, δεν έχω χρόνο. Okay. Το site μας είναι το career.outh.gr και εκεί πραγματικά μπορείτε να βρείτε όλες τις υπηρεσίες και όλα αυτά που σας ανέφερα. Θα σας πρότεινα επίσης να μας ακολουθήσετε στα social media, στο Facebook, στο LinkedIn, στο Instagram και στο YouTube. Θα ήθελα να πω εδώ κάτι πάρα πολύ σημαντικό. Το γραφείο διασύνδεσης είναι ίσως η μόνη υπηρεσία ή από τις λίγες υπηρεσίες που θα σας συνοδεύει για πάντα στη ζωή σας. Γιατί έχουμε σαν ομάδα στόχο όχι μόνο τους φοιτητές, αλλά και τους απόφοιτους και η σταδιοδρομία είναι συνεχής. Λέω πάντα είναι διαβίου, ακόμη και πώς θα διαχειριστείτε στη σύνταξη θα είναι μία απόφαση που θα πάρετε. Και ειλικρινά σας λέω ότι εγώ είμαι εκεί πάνω από 20 τόσα χρόνια και έχω συμβουλευόμενους που είχαν έρθει στο γραφείο σαν φοιτητές, τους συναντώ έξω και με χαιρετάνε, με θυμούνται, σαν επαγγελματίες. Έχω ανθρώπους που κάναν αλλαγές, μεταβάσεις, χάσαν τη δουλειά τους ή επιλέγουν να αλλάξουν, θέλουν να φύγουν από την Ελλάδα ή θέλουν να γυρίσουν από την Ελλάδα. Έχω και τέτοιους, το brain gain. Αυτούς που θέλουν να βρούνε πλέον είναι στο εξωτερικό και θέλουν να γυρίσουν. Οπότε συνδεθείτε με το γραφείο διασύνδεσης γιατί είναι μια υπηρεσία και έχουμε σαν στόχο να σας βοηθάμε. Και κάτι ακόμα. Είμαστε από τα λίγα γραφεία διασύνδεσης που την πληροφόρηση την παρέχουμε προς όλους. Δεν την έχουμε κλειδωμένη μόνο για τις δικούς μας. Είναι λίγες από τις υπηρεσίες που τις έχουμε ειδικά για το απειθήτα. Το να γραφτείτε και να παίρνετε το newsletter είναι μία από αυτές. Είναι πολύ απλό. Κάνετε μία σύνδεση επάνω. Βρίσκουμε ότι είστε από την πύλη αποφύτων, απόφυτου το απειθήτα και μετά λαμβάνετε το newsletter, όπως επίσης μπορείτε να αφήσετε το βιογραφικό σας για να το δουν οι εταιρείες και να σας καλέσουν αυτές. Συμβαίνει και αυτό. Μπορείτε να έχετε ατομική συμβουλευτική μαζί μου μόνο αν είστε το απειθήτα και νομίζω είναι αυτές. Όλες οι άλλες, δηλαδή οι δράσεις που κάνουμε, ενημέρωσης, τα βίντεο που παρήγαμε τώρα για τα σύγχρονα επαγγέλματα, αν θέλετε να ασχοληθείτε με το Agile, δείτε το βίντεο από μία απόφυτο της πληροφορικής που είναι Agile Delivery Lead και λέει πώς τα κατάφερε. Αν θέλετε να ασχοληθείτε με το data analysis, δείτε το βίντεο μιας απόφυτης από το μαθηματικό που αυτή τη στιγμή είναι senior data analyst. Όλα αυτά υπάρχουν στο YouTube, στο site μας και είναι προς όλους. Τώρα, αν θέλετε να μας επισκεφτείτε, υπάρχουν 2 χώροι στην Πανεπιστημιόπολη, στο νομική, στον πρώτο όροφο πάνω από τη Γραμματεία του Οικονομικού, στο γραφείο 114. Το δικό μου γραφείο είναι εδώ δίπλα, στην πάνω φοιτητική λέσχη, στο ισόγειο αριστερά από τις σκάλες. Σας ευχαριστώ και τώρα θα παίξουμε ένα πολύ σύντομο βίντεο, να πάρετε έτσι λίγο παλμό νεανικό. Από μένα, δεν ξέρω αν έχω κάποια ερώτηση. Όχι. Σας ευχαριστώ πολύ. Έχω μία. Παρακαλώ.
Ήθελα να διευκρινίσω, να μας διευκρινίσετε βασικά, αυτά τα μαθήματα και οι συμβουλευτικές είναι για οποιοδήποτε τομέα του απειθήτα, έτσι, όχι μόνο για τις σχολές των ηλεκτρολόγων.
Όχι βέβαια. Γι' αυτό ξεκίνησα λέγοντας ότι εδώ μπορεί να είστε ηλεκτρολόγοι, περισσότερη πληροφορική, αλλά είμαστε για όλους, για τα 41 τμήματα.
Ωραία, τέλεια, ευχαριστώ πολύ.
Ναι, και ίσα-ίσα, ειδικά τα ομαδικά εργαστήρια, να σας πω την αλήθεια, εγώ θεωρώ ότι είναι πιο ωραία να είναι διεπιστημονικά, για να καταλάβουν, εσείς δεν το νιώθετε τόσο, πολλές φορές θεωρούν κάποιοι ότι οι ηλεκτρολόγοι δεν θα έχουν πρόβλημα στην αγορά εργασίας, Κι όμως και οι ηλεκτρολόγοι και οι πληροφορικοί και αυτοί ακόμα δυσκολεύονται να αποφασίσουν ή χρειάζονται στήριξη. Οπότε έτσι καταργείται ο μύθος ότι όταν υπάρχουν θέσεις εργασίας, τότε δεν έχεις πρόβλημα στη σταδιοδρομία. Όχι, μπορεί να έχεις και τότε, γιατί ακριβώς έχει πολλές δυνατότητες. Ευχαριστώ για την ερώτηση. Κάποια άλλη ερώτηση? Ναι.
Ευχαριστώ πολύ. Το γραφείο σας ή το Πανεπιστήμιο κρατάει στατιστικά για τους απόφοιτους, ανασχολεί και τι στατιστικά κρατάει?
Ναι, αυτό ανέφερα πριν, ότι το Γραφείο Διασύνδεσης εκπώνησε μια μεγάλη έρευνα, η οποία είναι πανελλαδική, και ηγείται η ΕΤCEI, η Ανώτατη Εθνική Αρχή Ανώτατης Εκπαίδευσης, σε σχέση με το τι γίνεται σε σχέση με τους αποφύτους. Το career tracking που λέγεται, ας πούμε, διεθνώς. Και είναι η ερευνητική μας ομάδα έτοιμη να παρουσιάσει σύντομα τα αποτελέσματα. Σας κάλυψα? Γίνονται δηλαδή έρευνες σε σχέση με αυτό, με τα στατιστικά. Από εκεί πέρα φαντάζομαι και τα τμήματα μπορεί να έχουν, αλλά σε επίπεδο απορρόφησης εμείς πήραμε αυτή τη χρηματοδότηση, τέλος πάντων, γιατί αποφασίστηκε να γίνει εθνικά, δηλαδή να γίνει σε επίπεδο χώρας. Κάποια άλλη ερώτηση?
Λοιπόν, ευχαριστούμε πολύ.
Να είστε καλά.
Και για τους φοιτητές να αναφέρω ότι θα έχουμε την ευκαιρία ξανά να επικοινωνήσουμε με την κυρία Παπακόντα στην μέρα καριέρας στις 6 Δεκεμβρίου που οργανώνουμε μέσω της IEEE πάλι για ηλεκτρολόγους, πληροφορικούς και συναφείς ειδικότητες. Λοιπόν, τώρα περνάμε στη συνέχεια στις παρουσιάσεις των εκπροσώπων των εταιριών. Ξεκινάμε από την εταιρεία Renaissance και την κυρία Στέλλα Τσαμπούκου. Ωραία, σας ευχαριστούμε.
My presentation is going to be in English. So, my name is Stella Tsamboukou. As a University Relations Coordinator, I'm going to present to you Renaissance Electronics. Our history starts in 2002 with NEC, but the name of Renaissance starts in 2010 with the merging of NEC Electronics and Renaissance Technology. The Greek presence landed in 2021 when Dialog Company is acquired by Renaissance, incorporating two Greek branches, one in Athens and one in Patras. Renaissance headquarters are in Tokyo, Japan, and in additional global network of sales offices, R&D sites, manufacturing facilities in US, Europe, Southeast Asia, and China. Our personnel is consisted of 21,000, more than 21,000, all around the globe. Renaissance, Renaissance enhance a safer, smarter, and more sustainable future where technology can help make our lives easier. As a global leading provider of microcontrollers, Renaissance Electronics combines our expertise in embedded processing, analog, digital, and connectivity to deliver complete semiconductor solutions. With these four winning combinations to accelerate time to market in automotive, industrial, infrastructure, and IoT applications, enabling billions of connected, intelligent devices that enhance the way people work and live. At Renaissance, sustainability is at the heart of what we do. Our products and solutions reflect our long-term commitment to building a sustainable future where, as I said, our purpose is to make our lives easier. Renaissance culture is based on 5 significant characteristics: transparent, agile, global, innovative, and entrepreneurial. TAGI, as we call in Renaissance, is a guideline of conduct that should be shared across the Renaissance Group and all our employees. One of the strengths of Renaissance as a global company is that our employees have diverse experience, perspectives, and values. For that reason, we have set as our commitment to offer equal opportunities to all and culture of inclusion. What we do: Renaissance delivers a vast array of semiconductor products from sensors to actuators across the whole signal chain to help our customers to complete embedded systems, to realize complete embedded systems. These are the functions in Greece. We are separated in 2 sites, one in Athens with 100 employees and one in Patras with 50 employees. Our personnel encompasses software developers and testers, DevOps engineers, IC designers, accounting, PSP engineers, PSP designers, FAE audio engineers, custom support, global operation, finance, IT, HR. These are examples of real products that has embedded Renaissance technology. So, the part you are interested most. To become part of Renaissance requires a basic skill set. For example, embedded C, C++, Python, and all the things I refer here are significant skills you need to have for entering the corporation as an engineer. But, however, I have to emphasize that you need passion and willing to learn to become even better than you are today. A talent who endeavors to become part of Renaissance family will grant a package of privileges, such as career path, talent promotion, lateral move, competitive salary package, annual bonuses per level and performance, benefits, of course, private health insurance, equipment, ticket restaurant card, snacks and coffee in the office for free, training, seminars, conferences to become even better, and innovation and referral awards. I have to say again that we are a global company that brings specific characteristics to all employees. You can relocate, you can travel abroad, you will have all the things that a global company can offer. So, in 10 minutes I can't tell you everything about the corporation, so you are welcome to come in Athens and in Patras and talk about everything furtherly, and I will be happy to invite you and tour you in our offices. Thank you for your attention, everybody.
Thank you, Mrs. Tsaboukou, especially for keeping the time. Of course, those who are interested may contact the representatives of the company outside here at the Renaissance booth.
Thank you very much.
So, we can move on to the next presentation of the Kenotom company by Stefanos Giannopoulos.
Hello, should we keep it in English or? Yeah. Okay. So, hello and thank you for your time. I'm going to present you our company called Kenotom. My name is Stefanos Giannopoulos, and in my few years of experience I have worked in design and verification of safety critical systems, especially in the aviation and the automotive industry. Safety critical systems are called the systems whose malfunction can cause critical failures such as severe injuries or death of people or environmental destruction. So those systems should be extremely reliable. Kenetom is a company that focuses on the development of such systems. Actually is a company that started here in Thessaloniki in 2014 from 2 engineers from this university. And throughout these years, we are now close to our 9th year of existence in Thessaloniki. We have grown and currently we are about 200 people working here in Thessaloniki in Kalamaria. Our main topics are the support, the service providing for embedded systems. And our clients are mostly the major tier 1 suppliers, the automotive electronic suppliers. I think this slide is a little bit useless for this audience, but embedded systems are is a computing system with a dedicated function, which basically is designed in order to save size, weight, manufacturing cost, and power consumption. Regarding our application areas, we have worked on industrial automation development of embedded systems. We have a couple of projects that we contributed in the design and the commission of test benches for the aviation industry. We are currently also working in biomedical engineering project where we develop endoscopes or the embedded systems within endoscopes. But the majority of our projects and our contribution is in the automotive industry for over 85% of our revenue. Now, regarding our customers, as aforementioned, we have automotive tier 1 suppliers such as Vitesco Technologies, Magna, Hofer, Cognizant Mobility, Embotech, and you might have seen some of those logos stuck on the Formula 1 cars, etc. So these are the top automotive suppliers in the world. We have also cooperated with several non-automotive companies where we are contributing again in the development and commissioning of control units. Now, regarding the universities, we have a very close relationship with the universities, mainly with the universities of northern Greece, such as obviously the Aristotle University that is currently hosting us, as well as the International Hellenic University, the University of Thessaly, the University of Thrace, and also the University of Ioannina. Our collaborations with these institutes are regarding mainly internships, since stat coming out of our HR is that our current employees, of the count of 200, 20% of them are internships that have remained and worked full-time with us right after the finishing of their internships. We have contributed in several diploma theses, PhDs, several R&D projects that we have cooperated, such as one that was presented actually yesterday here in this podium. And we have consulted several theses and Master in Science programs. We are also sponsoring the innovative teams of Aristotle, of Art, of Centaurus team, and also SpaceDot. So now, where we are specialized. As I mentioned before, the safety critical systems are systems that need to be reliable. Thus, we need to not only develop them, but also fully specify their needs and also fully test their capabilities against the needs. So we are following this structured, so-called V model from the sign that you see here, and the flow goes from the left to right. Initially, we are specifying our system. We are splitting the architectural decisions depending on the domain, so the electronics, the software, and the mechanical parts of our system. And then we are decomposing those into the different domains. So the software engineers initially need to write their requirements and split their architecture, and then we are proceeding in the development and implementation of the software, equivalently with the hardware one. The right side of the V, as we see it, is the qualification, the verification qualification of our system, starting now from bottom to top. We are testing all our units separately, isolated. We are then integrating and testing the integration process, and then the last part of each individual architectural block is qualified. So it is tested in combination with the real inputs and outputs. Last but not least, the system then gets integrated and then qualified against the initial system requirements and architecture. Our vacancies match basically our development life cycle. So we are constantly seeking for all the seniorities of engineers in all our domains. So we are seeking for systems engineers, for requirements engineers. We are seeking for firmware engineers who will be working closer to the hardware and developing low-level code such as drivers for actuators, for sensors, etc. And the application layer software engineers, which we are developing the representation of the physical system in a software level. Usually the firmware is written in language C, so low level, whilst the application software can be written in C, but the modern model-based techniques are usually developed in model-based tools such as MATLAB Simulink or TargetLink, etc., and then it is getting compiled in lower level languages. This firmware integrated is then introduced into the hardware that the hardware engineers will design, and then we have the verification phase. So the software verification engineers, the hardware verification engineers, and eventually the system verification engineers. For all our vacancies, since the needs are quite dynamic, they're changing, and you can definitely see the open positions that we currently have and always have in our website, and also you can find it in our booth. We have QR code, and also if you want to learn more regarding any specific position that I'm mentioning here, feel free. We will be in our booth right after. You can ask anything you want about our open positions and any career opportunities within our company. The corporate culture is, as a service provider, basically our strength is our engineers. Thus, we are providing our team with excellent working conditions, excellent offices, challenging edge projects, and also we have training plan, special career development path for each of our engineers, and we are promoting open communication. We have several activities that are targeted into the bonding of our team, several sports events, some excursions, and several other events for our employees, for smaller groups, and also for the whole company. Here I would have a video that I would like to show, but as I saw previously, actually it's playing in loop around the monitors that are outside here, so I wouldn't spend more time here. You can always check it right outside. I would prefer to spend the time if there are any questions.
Okay, thank you very much. Please, are there any questions? Of course, you can visit the booth just outside, the booth of the company, and you may ask directly or ask for some more information about employment in the company. So, thank you very much, Mr. Giannopoulos. And now we can move on to the ANSYS company. It will be presented by Manolis Fotakis and Ioannis Georgakis.
Okay, hello to everyone. We represent the company ANSYS, and let us first of all to introduce ourselves. My name is Manolis Fotakis. I work in the talent acquisition department of the company, and I'm responsible specifically for hiring in Greece. I have around 7 years of work experience in multinational companies in Germany, Netherlands, and Greece. I'm very happy to be here and meet all of you.
Hello from me as well. My name is Ioannis Georgakis. I have recently joined ANSYS working as a senior R&D engineer, and I have also studied here electrical and computer engineering, so I'm very happy to be presenting here with you today.
Nice. So, what is ANSYS? ANSYS is possibly the top company in the simulation space with more than 50 years of existence. Specifically, ANSYS is the first company in humanity that introduced the concept of digital simulation back in the 70s. Our headquarters are in Pennsylvania, in the US, but we have presence in different continents, in Europe, in Asia. And our mission is the human advancement through technology innovation. Regarding ANSYS in Greece, we are relatively new. We entered the market in 2019 via an acquisition of a Greek company called Helic that designed microchips products. Our offices are the ones you see in the screen. We are based in Kato Halandri, very close to the city center of Athens. Due to the fact that we have been growing a lot recently, we opened new offices as well in Athens Tower, in 21st floor. At the moment, we are approaching 120 people in Greece, but I will tell you more in a bit. Let's now dive into some key data at a global context. ANSYS is a company of 6,500 people. We have operations in more than 25 countries and offices in more than 80 locations. Since 2020, we have a 24% increase in our personnel, and as a multinational company, we have people from different countries, cultures, generations. It is, though, important to mention the emphasis that ANSYS has been given in the amplification of women in both leadership and technological positions. In ANSYS Greece, we follow a similar path. In the left graph, we can see some data around the increase of our employees in Greece. And I would focus specifically in 2023 because we have, let's say, a big growth. As I told you, we are approaching 120 people, and we are still in October, so we are expecting more people coming till the end of the year. In the right upper side, we can see some data around age diversity and the fact that most of us are young people between 25 and 35 years old. And in the right bottom side, we notice that around 26% of employees in Greece are females. This is an important data point if we consider that the respective percentage in technology companies in Greece is merely 16%. Okay, so can continue.
So, ANSYS provides software for the digital modeling of real-world phenomena, and the range of problems that our software can solve is very, very broad and could range from anything from fluid dynamics, mechanical structures, electromagnetics and electronics, semiconductor systems, embedded software for application with critical safety, as well as optics and photonics and acoustics, among other fields. But so why do we do simulation in practice? If we see around us, the whole world we live in is surrounded by various products, and to improve those products' design, especially when we're talking about high-performance devices, it is considerably costly to construct them and then realize that the design we have made in practice isn't working as expected. For example, think of applications such as autonomous driving. Can you imagine this being tested in the real world and practically failing? So in practice, what can we do? With simulation tools, we can analyze, study, and test the behavior of product design before the actual manufacturing process. And in ANSYS, we use computer-based numerical techniques to solve the underlying physical problems. And in principle, we can represent many, almost practically many phenomena around us with mathematical models and equations. And with the aid of numerical techniques and computers, we can solve the corresponding equations and that describe those models. Here you can take an idea of some of the 1,000 products and customers we have, ranging from aerospace to semiconductors. For example, you can see in automotive the Ferrari and BMW brand, or in semiconductors, NVIDIA and Samsung.
Now, what is our factor of success? Firstly, we would say our teams. What characterizes us is our constant motivation to develop ourselves, learn things from each other regardless of the level someone is, and respect each other's differences. These are some of the elements that make our teams strong. The second factor is the investments ANSYS has made to the research and development area. We notice in the graph that our investments are gradually increasing year after year. Nowadays, around 12% of the whole company work in the R&D area, and we would say that one of the selling points for someone to work at ANSYS is that they are able to do things they did academically, and it's not so common to be found in a business environment. ANSYS is usually looking for people like from electrical engineering, computer science, physicists, mathematicians. Last 2 years, we also employ mechanical engineers. At the moment, we have approximately 8 open positions, and the focus is Greece. It's mainly technical support, electromagnetics roles, and we really like people with who have already used our tools like HFSS and Maxwell. But we also have openings into the R&D engineering area. We expect a big wave of new openings from January 2024. That's why we are here, because it would be great to cultivate a relationship with most of you that I guess you are students. If you want to see more information about us, feel free to visit our website. You can also scan the barcode you see on the screen with your mobile phone. You can check our career openings. In case you cannot find something at the moment, it would be great if you can join our talent community, so that way we will be able to notify you on a regular basis about our upcoming openings. So yes, thank you very much for your time. It was a pleasure, and yeah, looking forward to meet all of you outside in the kiosks.
Thank you, Brian.
Thank you, Mr. Fotakis and Mr. Georgakis. Is there any question? Of course, you can find the people in their booth outside here. So, thank you very much. We can move on to the next company, Deloitte company. It will be presented by Pierina Monastirioti and Irini Papagiannidou.
Okay, thank you. First of all, we would like to thank you for the invitation, and we are very glad that we are here. May I have a question first? Do we have someone that doesn't speak Greek? Everyone speak Greek? Because we would like to mention some things in the native language for the better understanding, because we think that is very important also for your career, and if it's okay also with you, okay. So thank you very much for that. Let's turn on Greek again. Χαίρετε. Σήμερα θα σας παρουσιάσουμε πρώτα τους εαυτούς μας. Ονομάζομαι Μαρία Πιερίνα Μοναστηριώτη και είμαι μέλος στην Deloitte τον τελευταίο 1,5 χρόνο. Σωστά, τον τελευταίο 1,5 χρόνο. Είμαι και εγώ, έχω περάσει και εγώ πριν αρκετά χρόνια από το ΑΠΙΘΙΤΑ, είμαι και εγώ πτυχιούχος του ΑΠΙΘΙΤΑ και έχω ένα συναισθηματικό δέσιμο με το Πανεπιστήμιο, σε ένα τελείως διαφορετικό κλάδο, με την συνάδελφο σήμερα την Ειρήνη την Παπαγιαννίδου, η οποία θα σας πει, θέλεις τώρα να κάνεις το θα σας πει, και η συνάδελφος είναι εξίσου από το ΑΠΙΘΙΤΑ, οπότε η Deloitte ήταν και ένας διαμεσολαβητικός κρίκος, δεν ξέρω πώς θα το έλεγα καν στα αγγλικά αυτό, να μας ενώσει και να μας κάνει ένα redirect στην καριέρα μας. Οπότε εμείς σήμερα θα σας πούμε κάποια πράγματα για την εταιρεία και από εκεί και πέρα φυσικά θα αφήσουμε και 1-2 λεπτάκια αν έχετε οποιαδήποτε ερώτηση, είτε στα αγγλικά είτε στα ελληνικά, να μας ρωτήσετε και φυσικά να σας απαντήσουμε. Τέλεια. Οκ, όπως μπορείτε να δείτε, έχουμε μια πολύ ωραία φράση «You bring ambition, we bring opportunities». Οπότε εμείς εδώ είμαστε να σας δώσουμε την ευκαιρία και εσείς, αν θέλετε, να μπορέσετε να την εκμεταλλευτείτε όπως εσείς πιστεύετε. Ξεκινώντας λοιπόν, σας έκανα ήδη present του εαυτού μου και τη συναδέλφου μου της Ειρήνη της Παπαγιαννίδου. Δουλεύουμε και στο recruiting κυρίως κομμάτι, οπότε ερχόμαστε σε επαφή με πάρα πολλούς candidates καθημερινά. Τώρα σε αυτό το slide θα μπορέσετε να δείτε λίγο το presence που έχουμε όσον αφορά το global κομμάτι. Όπως βλέπετε, πάνω από 411.000 υπάλληλοι και κάτι ανά τον κόσμο, σε πάνω από 160 χώρες, με 695 γραφεία παγκοσμίως. Τώρα, ας μιλήσουμε λίγο πιο εξειδικευμένα για την Ελλάδα. Υπάρχουν τα γραφεία μας, το Deloitte Alexander Competence Center, εδώ η έδρα μας στη Θεσσαλονίκη. Υπάρχουμε στο Ηράκλειο, στην Πάτρα, στα Γιάννηνα και φυσικά στην Αθήνα. Δεν ξέρω αν κανείς γνωρίζει ότι είμαστε τόσο extend και έχουμε αρκετά γραφεία. Γενικότερα, τα πιο πρόσφατα γραφεία αυτή τη στιγμή που άνοιξαν το Μάιο είναι στα Ιωάννινα και ευχόμαστε να μπορέσουμε μελλοντικά να επεκταθούμε και σε άλλες πόλεις. Εκτός λοιπόν από το κομμάτι των πόλεων, το οποίο είναι πολύ σημαντικό, να πούμε και εμείς με τη σειρά μας ότι ο μέσος όρος ηλικίας των ανθρώπων που απαρτίζουν την εταιρεία είναι γύρω στα 33 έτη. Έχουμε μια ανάπτυξη με ένα αριθμό που μπορούμε να πούμε ότι τα τελευταία χρονιά είναι +22% και οι γυναίκες στην εταιρεία μετράνε σχεδόν πάνω κάτω το 42%. Γενικότερα υπάρχουν και πάρα πολλά communities που ενισχύουν τη γυναικεία επιχειρηματικότητα και το γυναικείο και τη γυναικεία ύπαρξη μέσα στον κομμάτι της τεχνολογίας. Θα σας μιλήσει αργότερα η συνάδελφος γι' αυτό. Να μην ξεχάσω να πω ότι αυτή τη στιγμή η παρουσία μας στην Ελλάδα ως Deloitte ανέρχεται γύρω στα 2.700 άτομα. Και τώρα πάμε λίγο σε πιο ιστορικά στοιχεία. Ξεκινήσαμε ανοίγοντας τις πόρτες εδώ στο Deloitte Alexander Competence Center που είναι στο Τεχνόπολης, αν έχετε ακουστά, στη Θέρμη, το 2018. Ξεκινήσαμε ως ένα hub για tech innovation και έτσι έχουμε γίνει involved σε πολλά international project, γι' αυτό και η καθημερινότητά μας και εμάς στην εταιρεία είναι στα αγγλικά. Φυσικά υπάρχουν και τα κομμάτια των ελληνικών που είναι κυρίως των bonding activities, αλλά επειδή δουλεύουμε σε πάρα πολλά international project και με πάρα πολύ διαφορετικούς ανθρώπους από διαφορετικές χώρες καθημερινά, τα αγγλικά είναι ένα πράγμα το οποίο είναι απαραίτητο. Και τώρα θα πάμε λίγο σε πιο δύσκολα ή πρωτόγνωρα πράγματα βασικά για εσάς. Πάμε να μιλήσουμε για τα function της Deloitte. Τι είναι function? Ας πούμε ότι η Deloitte σαν οργανισμός έχει 4 διαφορετικά department. Εμείς τα λέμε function, εσείς μπορείτε να τα αναγνωρίσετε ως department. Το πρώτο είναι το consulting, το δεύτερο είναι το risk advisory, το τρίτο είναι το tax και το legal και το τέταρτο είναι το audit. Το consulting λοιπόν, ας ξεκινήσουμε με το consulting, έχει πάνω από 720 professionals στο Deloitte Alexander Competence Center. Δουλεύει σε πάρα πολλές τεχνολογίες οι οποίες είναι certified globally. Μερικές από αυτές μπορείτε να τις δείτε και στο slide, αν έχετε ακούσει ποτέ για την πλατφόρμα του Salesforce, για την πλατφόρμα της Adobe, για την πλατφόρμα της Oracle, για το cloud. Υπάρχουν όλες αυτές τις τεχνολογίες μέσα στην εταιρεία. Φυσικά υπάρχουν και άλλα κομμάτια που μπορεί να μην έχουν αναγκαστικά πλατφόρμες όπως είναι το mobile, όπως είναι το UI, όπως είναι το IoT, integration services, η πλατφόρμα also του ServiceNow που γενικότερα τον τελευταίο καιρό ανεβαίνει πάρα πολύ σαν τεχνολογικός κλάδος. Μετά έχουμε πάλι ένα department το οποίο έχει και αυτό κάπως τεχνολογικό χαρακτήρα, το Risk Advisory, ασχολείται με την αποφυγή κινδύνων και περιέχει τεχνολογίες όπως cyber security, cloud security, που έχουν να κάνουν κυρίως με αυτό το κομμάτι. Μετέπειτα έχουμε το audit, που αν έχετε κάποιους φίλους στο κομμάτι του οικονομικού και του financial, θα έχετε ακούσει λογικά τη λέξη ορκωτός λογιστής. Οπότε είναι το ελεγκτικό κομμάτι της εταιρείας και ίσως κάποια στιγμή, αν όχι εσείς, κάποιοι φίλοι σας έχουν ακούσει την εταιρεία για αυτό το λόγο. Και το tax και το legal, που φυσικά ασχολείται με κομμάτια που αφορούν το legal και το tax κομμάτι. Αυτά από μένα. Ευχαριστώ πολύ. Ειρήνη.
Οπότε να συνεχίσουμε έτσι λίγο να πούμε και κάποια ακόμα πράγματα. Αναφέρθηκε ήδη λίγο το κομμάτι της τεχνολογίας που θέλουμε να τονίσουμε ότι είναι ο κύριος κλάδος στον οποίο δραστηριοποιούμαστε. Αν παρατηρήσατε και τους αριθμούς, η συντριπτική πλειοψηφία, η αλήθεια είναι των συναδέλφων δουλεύουν πάνω στο κομμάτι της τεχνολογίας, παρόλο που εμείς σήμερα έχουμε έρθει από την ομάδα του HR. Πάμε να δούμε ίσως λίγο και κάποια πράγματα στο πλαίσιο του γιατί Deloitte, είναι αυτό ίσως που μας διαφοροποιεί ή κάτι που φέρνουμε έτσι διαφορετικό κατά μία έννοια. Να τα πιάσουμε λίγο ένα-ένα, να τονίσουμε λίγο, αναφέρθηκε και προηγουμένως από την Πιερίνα. Είμαστε μία ομάδα, μία εταιρεία που δουλεύουμε αποκλειστικά σε international project. Αυτό το αναφέρουμε γιατί είναι πολύ σημαντικό το πλαίσιο στο γεγονός ότι ακριβώς επειδή και οι πελάτες μας είναι international, οι συνάδελφοι μπαίνουν σε πολύ δυναμικά project, εργάζονται πάνω σε αυτά και έχουν τρελές δυνατότητες εξέλιξης. Ωστόσο, έτσι λίγο για να μιλήσουμε και πιο συγκεκριμένα πάνω στο κομμάτι γενικά του learning and development, γιατί θεωρούμε ότι είναι ένα πολύ σημαντικό πλαίσιο μέσα από το οποίο καθένας από εμάς μπορεί να εξελιχθεί. Το κομμάτι ακριβώς του πώς μαθαίνουμε διαρκώς καινούργια πράγματα για να γινόμαστε καλύτεροι και σαν άνθρωποι, αλλά και σαν επαγγελματίες. Βλέπετε στο slide διάσπαρτα κάποια από τα κύρια certifications τα οποία δουλεύουμε εντός της εταιρείας, ανάλογα με την ομάδα στην οποία ανήκει κάθε συνάδελφος, δουλεύουμε κάποιο εργαλείο. Οπότε οι συνάδελφοι έχουν δυνατότητα να γίνουν certified από τα αντίστοιχα εργαλεία και τις πλατφόρμες. Ενώ κάτι που θα θέλαμε να τονίσουμε είναι δύο διαφορετικά συστήματα τα οποία έχουμε μέσα στην εταιρεία. Ίσως η λέξη σύστημα να μην είναι η σωστή. Είναι το body system και το coaching, που είναι ακριβώς δύο δομές που έχουμε μέσα στην Deloitte, ακριβώς για να βοηθούν οι συναδέλφους να μπορέσουν να εξοικειωθούν πιο άμεσα με το περιβάλλον, να εξελιχθούν έτσι ευρύτερα και να εξελίξουν και περισσότερο και την καριέρα τους ενδεχομένως. Τώρα, έτσι σύντομα, επίσης να πούμε στο κομμάτι του τι προσφέρουμε, ότι επειδή ακριβώς για να μπορεί η ομάδα να μεγαλώνει τόσο δυναμικά, γιατί αν παρατηρήσατε μέσα σε 6 χρόνια έχουμε καταφέρει, βασικά ούτε 6 χρόνια, έχουμε καταφέρει από εκεί που ξεκινήσαμε πρακτικά 0 άτομα, να φτάσουμε αυτή τη στιγμή σε πάνω από 1.100 συναδέλφους. Οπότε αυτό για να συμβεί, ένας από τους βασικότερους πυλώνες είναι το κομμάτι της εξέλιξης. Και γι' αυτό το λόγο επενδύουμε πάρα πολύ και σε end αλλά και mid-year evaluations, προκειμένου καθένας από εμάς να έχει τη δυνατότητα να εξελιχθεί πάντα προς τα πάνω. Και με βάση αυτό εννοείται ότι όλοι μας έχουμε και ένα end-year bonus, ενώ μπορείτε να δείτε και κάποια από τα benefits που παρέχουμε, όπως π.χ. το ticket restaurant, ιδιωτική ασφάλιση, εκτόσεις τις οποίες έχουμε σε διάφορα καταστήματα. Επίσης, εννοείται ότι όλοι μας λαμβάνουμε εταιρικό εξοπλισμό, λάπτοπ, αλλά και κινητό τηλέφωνο, ενώ παράλληλα ένα ακόμα εξτρά είναι και κάποια ταξίδια που μπορεί να προκύπτουν λόγω και των αναγκών της κάθε ομάδας. Και σαν τελευταίο κομμάτι που βλέπετε έτσι και κάτω-κάτω στην παρουσίαση, να πούμε ότι είμαστε μια ομάδα που προσπαθούμε να δουλεύουμε υβριδικά. Δηλαδή, μας αρέσει, πηγαίνουμε και στο γραφείο κάποιες φορές την εβδομάδα, δουλεύουμε και από το σπίτι, έχουμε επιπλέον εξτρά μέρες άδειας, προκειμένου να παίρνουμε και λίγο χρόνο για τους εαυτούς μας και να το επενδύσουμε και στο δικό μας προσωπικό well-being, που είναι πολύ σημαντικό. Ενώ επειδή, όπως είπε και η Πιερίνα, τα γραφεία μας η αλήθεια είναι ίσως είναι λίγο δύσκολα προσβάσιμα για κάποιον που δεν έχει δικό του μεταφορικό μέσο. Έχουμε και ένα λεωφορείο το οποίο χρησιμοποιούν συνάδελφοι, προκειμένου να μπορούν να μεταβαίνουν, παράδειγμα, από το κέντρο της πόλης με κάποιον εύκολο τρόπο και στο γραφείο. Και τελευταίο, αφήσαμε κάτι λίγο έτσι σε πιο φαν, για να αφήσουμε έτσι και μία ωραία αίσθηση και μπορούμε να τα συζητήσουμε και αναλυτικά όλα αυτά μετέπειτα. Να πούμε ότι είμαστε πολύ χαρούμενοι και πολύ proud βασικά για κάποιες κοινότητες που έχουν αναπτυχθεί εντός της Deloitte από πρωτοβουλίες συναδέλφων που ενδιαφερόντουσαν για κάτι. Εδώ τώρα έχουμε βάλει τα εικονίδια, είναι π.χ. το Globe, που είναι ένα community που προάγει δικαιώματα και γενικότερα raising awareness issues πάνω σε LGBTQ ζητήματα. Υπάρχουν, όπως προείπε και η Πιερίνα, communities που έχουν να κάνουν με το empowerment των γυναικών και στον τομέα της τεχνολογίας, που είναι πολύ σημαντικό να βλέπουμε παραπάνω γυναίκες και να μπαίνουν στον κλάδο αυτό, αλλά και να εξελίσσονται. Ενώ έχουμε και κάποια communities, όπως παράδειγμα το parent community, pet communities κλπ., που είναι και ένας τρόπος έτσι να έρθουμε κοντά ο ένας με τον άλλον. Βλέπετε και κάποιες φωτογραφίες. Κλείνοντας έτσι σιγά σιγά, για να μην ξοδέψουμε κι άλλο χρόνο, να πούμε ότι έχουμε και κάποια παραπάνω πράγματα όσον αφορά desk stretching activities, που είναι 2 φορές την εβδομάδα κάνουμε desk stretching στο γραφείο, το οποίο ουσιαστικά γίνεται από professional γυμναστές που έρχονται στο γραφείο για να μας βοηθήσουν σε αυτές τις ασκήσεις και ταυτόχρονα κάνουμε και πάρα πολλές δραστηριότητες εντός των γραφείων στα πλαίσια, παράδειγμα, π.χ. τώρα την προηγούμενη εβδομάδα είχαμε ένα well-being week. Οπότε, για παράδειγμα, είχαμε και dog therapies που είχαν έρθει στο γραφείο και κάναμε λίγο interact, είχαμε κάποιο healthy breakfast, lunch κλπ. Οπότε προσπαθούμε να κάνουμε και διάφορα τέτοια activities και να έχουμε έτσι και ένα impact γενικότερα και θεωρούμε ότι είναι και από τους λόγους που έχουμε αναδειχθεί και στα νούμερο 1 workplaces γενικότερα και για το 2023. Επίσης, ένα QR code και από εμάς σε περίπτωση που θέλει κάποιος να σκανάρει και εννοείται θα χαρούμε να σας γνωρίσουμε και να μιλήσουμε και πιο αναλυτικά και έξω στο booth μας. Αυτά από εμάς. Να ευχαριστήσουμε πολύ. Δεν ξέρουμε αν υπάρχει κάποια ερώτηση φυσικά. Τέλεια, ευχαριστούμε.
Is there any question? Okay, of course you can meet the company in the booth outside and you may ask questions you may have. Thank you very much.
Ευχαριστούμε και εμείς.
So the next presentation will be for the Inaccess company and will be presented by Ioannis Sapounadélis.
Hello, everyone. Amazing speeches so far, presentations, and thank you for everyone for being here and having us with you. My name is Yannis Sapounadélis, and I'm responsible for the HR department here in Greece of Inaccess by Power Factors. Before we begin, I would like to say some things about Inaccess and why we are called Inaccess by Power Factors. Inaccess was founded in 2000 by three to four people, and today Inaccess alone is almost 250 people, mainly electrical engineers and software engineers. And in July 2022, there was a merge with Power Factors. Thus, now we are Inaccess by Power Factors. I'm not going to stay and spend so much time here. Yes, we are bold. Yes, we are savvy, but I really want to stick and mention about our mission, which we are very proud of it and passionate about it. It is, we want to fight the climate change with coding. This is our main mission. And now, as a PF, Power Factors, we are a global company. We have a presence all around the globe. We have offices worldwide. As you can check here, we have offices in Canada, US, Sweden, Spain, Greece, even Philippines, and so more. And we are over 600 people. We have more than 150 developers. And I want to mention that we are almost behind the 20% of the global renewable energy production. Here we can see a little bit of the journey of Power Factors so far. So there were many mergers, many acquisitions, many new services, and as you can see in 2022, there was the acquisition of Power Factors to Inaccess. So what we do though? In Power Factors, we are a tech company, and we expertise in the renewable energy. So we don't produce energy. We have services and products that support the energy production globally. And to go a little bit more in details, we have many products. The main product is Unity. Now, Unity is an IoT product that works with SCADA systems, SCADA engineering, Now, what is SCADA? SCADA combines software and hardware together. I'll just give you a very, very plain example. Imagine you own a hotel. In this hotel, you have 5 rooms. So in these 5 rooms, you can check from your home, remotely from your computer. You can see how many energy you have a consumption of energy. You can check what is in use, lights, heating, air conditioning, and you can control it from anywhere in your house. So how do we use that? We use it in renewable energy, so solar, wind, hydro, batteries, even some telecommunication projects. And what does it do? It allows our customers to check, control, monitor, and optimize their systems remotely through our products. Now, you can see here a little bit of our customers. There are huge customers as BP, Total, Shell, NG, and so forth. And here is a little bit of our technology stack. Now, before I discuss a little bit of our technology stack, to complete the capabilities of our product, so mainly what we have what we offer is an end-to-end solution. This solution, we speak with the customers, we design, we take the projects, we assemble the product, we implement the product, and moving forward from the hardware to the software, all the backend and the frontend is designed by us through our developers. And here, you can check a little bit of our technology stack and what we use in order to do this web development. So basically, on the backend, we use mostly Golang, Python, and Java. And for the frontend, we use React and Angular. So as you can see, there are some other buzzwords like AWS on cloud, PostgreSQL. So we use a little bit of top-end technologies. You can always find our openings on career pages. I'm not going to say a little bit many things here regarding this. I'm very happy to discuss with all of you outside to better understand what we do and what are the opportunities through the in-access power factors. What I just want to mention is that we work mainly remotely. We do have offices in Greece, as I mentioned. They are in Athens, in Marousi, but we hire all around Greece and, of course, with other openings all around the world. So that's me for today. Thank you very much, and I'm happy to meet you all outside.
Thank you, Mr. Sapunadelis. Is there any question from the audience? Yes, please.
Yeah, I appreciate this example on this room in a hotel, measuring something.
Oh, just for the microphone.
I highly appreciate this real-life example, making it a little bit more easier to understand it. So how would you measure this heating situation in a hotel room by your solution in the end?
Thank you very much for your question. That's a nice question. So basically, the hotel was just an example, okay? As I said, we use this on renewable energy. So imagine like huge parks, even in desert or even in Greece, in Thessaly, like very big solar panels and parks, which it's very complex. The main, as I said, product is Unity. So imagine it's basically like a semiconductor. It's like a box, which we go to the solar parks. We implement this product, and this product, as I said, with complexity like the semiconductors, the networks, securities, and everything like that, which we assemble in our team in Athens. So this box, let's say, when we go and implement, it collects data. We take this data with Kafka, and all this data that monitors, we have all our web services designed by us. So the people in front of the computer, they access the portal, and when they access the portal, they have a real-time, like 3 seconds delay, maybe or 2 seconds delay. In a real time, they can check and view and monitor their systems. So they can check how much was their production, let's say overnights or during the day, if there was any malfunction, why it happened, and basically they can optimize, control their systems through that. So it's that simple. And and also, as I said, it's a combination of services because everything this goes to cloud. We have other, like the Unity is one of our, like what we used to do in Access as well before Power Factors.
So coming back to this hotel room, so you would measure the electronic power consumption of that room and be smart, and will take care that the solar power is well balanced in a way.
Yes.
No. Thank you.
You're welcome.
Okay, let's thank the speaker again. And the next presentation will be for the ETCEI company, and it will be presented by Mr. Thrasos Axiotis.
Okay. Hello, everybody. My name is Thrasos Axiotis. Hello, everybody. Okay, that's nice. My name is Thrasos Axiotis, and I'm the manager of ETCEI. I will present the company here to you. ETCEI was founded here in Thessaloniki 3 years ago. And today, it employs 21 engineers doing different aspects: digital design, analog design, PCB design, and software, embedded software development. Our expertise is divided in 3 strong competencies. We have the RF, analog, and PMIC design. We have the logic and mixed signal design, and finally, we have the tool chains, so we provide the whole software stack for the chips we are designing. We develop MCUs for the automotive industry. That's our main area of expertise, addressing a wide range of applications. We also develop consumer MCUs, mainly targeting motor control. We have our own lab, which means that we test our own silicon. And finally, we are a subsidiary of a Cortus group. Cortus is a multinational company with presence in France, Italy, Spain, Brazil, and formerly Russia before the events there. What we do? We design system on chips for a variety of applications, mostly focused on the automotive industry. And here you can see chips that are designed by us and manufactured by different foundries. How we do design chips? First of all, one part of the team, about 9 people today, they're doing analog design. We start from the specification of a block, we do the schematic, then we do the simulation and verification, and finally we implement the physical design of the analog blocks. Then we are doing digital and mixed signal design by writing the RTL code, again verification and physical implementation. We also perform mixed signal verification, as our chips are mostly complex chips having RISC-V processors. So it's mandatory that we go through a mixed signal verification to ensure that the interface between the analog and the digital is operating correctly. We developed the software for our chips, the whole stack. We developed the compiler, the real-time operating system, and all the tool chain. So we have a dedicated embedded team that develops this type of software using the Eclipse environment. And finally, we do the PCB for our chips, and we test the chips in the lab. We have our own lab here in Thessaloniki. And here you can see some PCBs of the past and our instrumentation of doing the validation in the lab. So the chips are characterized here in Thessaloniki, and we use an external partner to characterize the chips temperature-wise range. I will show you three of our ICs that we developed here in Thessaloniki the last 3 years. Basically, we develop about one chip takes about 1 year to be developed here in Thessaloniki. Our first chip is an Internet of Things controller for ASM bands. You can see there is a pointer or something. Okay, that's good. So here you can see this is a RISC-V core inside the chip. This is the RAM memory. This is the flash memory. This part here is the analog front end. Here and here are the RF parts. And here it's the power supply. So this is a chip that was designed in 2020. We produce about 30,000 units of this chip. And the main market that this chip is addressing is electrical meters for the front, in France. This chip is sells in France. This is our first MCU for motor control. The name is Lotus One. It's a RISC-V commercial MCU. It's a rather large chip. Okay, here. Okay, you can see the parts of the chip. This again, this was taped out 1 year ago. This one is now, it's characterized in the lab, and now we shipped a few thousand units to different customers for evaluation. This chip, if everything goes okay, it will go to mass production in the first quarter of 2024. And this is the chip we are working now. That addresses the automotive industry. So the chip has challenges, not so much design challenges as certification things that we will have to pass. This is a test chip. This goes to tape out actually next week. And you see it's a very large chip because you have a lot of test structures inside that we would like to see in the lab how they operate. Now, working at our company, what are we looking for? We are looking for digital design engineers in all levels of experience, juniors, mid, and seniors. We are looking digital verification engineers, and also are looking for analog and mixed signal design engineers. For the mixed signal and analog, we are looking for senior guys now. As you know, that's scarce now in the market. And what do we offer? Casual work environment, as most of the companies that are involved in this field. Flexible work hours in a hybrid work environment. So we have people working in the company and we have people working from their homes. We offer competitive salaries. We have a training process for the junior guys. So basically we train every junior guy that joins the company through a very meticulous process before they start actually take over their own blocks. Continuous learning new technologies and exposed to the complete design flow. We are a small company, so every junior engineer is going to see everything from design down to the physical verification and validation of the chip. That's it, guys. Thank you very much. If you have any questions, are doing Q&A?
Thank you. Thank you, Mr. Axiotis. Is there any questions from the audience here? Okay, probably you may find Mr. Axiotis outside in the booth of the company, and you may ask questions.
You also have some of our chips and PCBs there, so if you are interested, you can come and have a look. Thank you.
Okay, thank you, Mr. Axiotis. And we may move on now to the next company, Think Silicon, which will be presented by Giorgos Keramidas.
My name is Georgios Keramidas. I'm an assistant professor at the Aristotle University of Thessaloniki, and I also work in Think Silicon as a consultant. Actually, in this slide, you do not see one company, you actually see two companies, Think Silicon and Applied Materials. Think Silicon was or is, or was, it is better a term, an SME started from the city of Patras in Greece. And Think Silicon was acquired 3.5 years ago from Applied Materials. Applied Materials is a big US company based in Silicon Valley with more than 37 employees and has presence in 18 countries. Now, let's focus on Think Silicon. Think Silicon designs and implements semiconductor IP cores in the field of computer graphics. This is the main business. Our technology is silicon proven, and in the slide you can see some of the customers of the company, like Dialog or Renesas, ST Microelectronics, Microchip, Lattice, Huami, and there are many other customers that are under NDA. So, what is the problem that we solve in the market? The target market of Think Silicon is the so-called MCU market or the microcontrollers market. Typically, the devices, the systems, the SoCs in this market do not have a GPU, so this causes several problems. For example, low quality graphics, slow human-machine interfaces, and poor user experience. Actually, the typical architecture, the typical paradigm in this market is the so-called cloud-first architecture, which is actually that the devices collect the data, sends the data to the cloud cloud does the computations and the results, and sends back the results to the device. So, our solution, so this approach has several problems, so our solution addresses those problems, and we address those problems by designing an ultra-low power, millivolt range, single-digit milliwatt range GPU. And this is a quote from the Lenin conference. It says here that, okay, if you want to design high performance processor, graphics processor, it is easy if power and transistor budget is not in constant. But in our case, we are exactly the opposite. That in our case, we design a small and efficient processor, and this is a real challenge. So, in these slides, you can see the embedded markets and embedded applications that can benefit, that actually benefit from our GPUs. So, our GPUs is an ideal product for devices like smartwatches, smartbands, and smart glasses, and in general, all the smart and connected IoT devices, and even more, our technology can benefit devices that does not include physically a display, like smart cameras. And another important asset of our technology, of our graphics technology, is that our graphics processor also has AI capability. So in our graphics processor, we can run also AI applications. The business model of ThinkSilicon is the so-called IP business model. So we sell to our customers, we provide to our customers the RTL code, the hardware code, we provide the graphics software, we provide the firmware, the drivers, the compiler, since we designed the whole solution, and also the software development kit, the SDK for the AI workloads. The revenue stream is split between IP license and royalties per chip. The value chain. So our customers are the so-called SoC integrators or OEMs. So we provide to them, this is just an example, we provide to them our design, the software and the hardware design, the drivers. This is a particular example that we are very proud of. Our customers there is US-based, Ambic Micro, and the customer of our customers is actually Google. Okay, so if you have a smartwatch, a Google Fitbit in your hand, the graphics technology there has produced mainly in Patras, actually, okay. But just we see here that we have also offices in Patras and Greece. So in general, our technology, ThinkSilicon technology, exists now is in more than 60 million devices and in more than 13, at least this is what I know, I don't know if there are more, 13 smartwatches that are there in the market. So to continue, this slide shows our full range of products. Our first GPU, our first series of GPU, a customer silicon-proven GPU called NEMA. NEMA, the name came, NEMA is the Greek word for thread, because our GPUs are multi-threaded. Okay, there are various versions, various flavors of this architecture that includes with different performance power trade-offs where we increase the number of cores, and also we have extra features. For example, we have a specific version with vector graphics. We have versions with video overlays, able to accelerate video overlays for data centers. And we have also a series of products for display processors. And finally, the second series of GPU called Neox, it is in the top. It is based, the architecture, it is an accelerator based on the RISC-V instruction set, and it is a hybrid, let's say, accelerator that is able to do both graphics and AI. Okay. So let me continue here. So we are designing not only the hardware, yes, we are a hardware company, a processor company, but we provide to our customers a complete ecosystem of tools. For example, we design, and this is one of the problems that we solve in the market, we design our own graphics API. Okay, for example, OpenGL or similar APIs were too heavy for those kind of devices. We have the NEMA GUI builder. The NEMA GUI builder, it is actually a GUI designer. Imagine this like as a toy example, like a PowerPoint or Visio that you, with plug and play moves, you create a screen, you attach, you have, you make, you can make some object to move or to have pop-up menus. So you design this by hand, okay, with your mouse, and by pressing one button, this automatically creates codes for our GPU. Another important tool is the NEMA and NEOX Bits, which is a pre-sales tool and evaluation platform. Actually, practically speaking, this is an SDK card that you can download from our site that includes our whole technology, and you can use it for Xilinx FPGA and check, and our customers, of course, check our solution, both hardware, software, and the drivers. And of course, there is the AI SDK, which is a complete framework that profiles, analyzes, compress and deploy AI models in our GPUs. So let me skip this slide in the interest of time. So we provide to our customers an end-to-end solution here. Okay, which means we build the architecture, we build the processor, we build the compiler, the hardware, the RTL, the drivers, the system software, the tool chain, and we are doing this for graphics and AI. Okay, in order to support our products, we build a multidisciplinary development team, and this is how our company is organized. Internally, we have four main groups. The first group is architecture and modeling group. So we define the architecture of GPUs and the AI accelerators. It is the RTL group within system macroarchitectures, FPGA prototyping, and EDA tools. The system software group, the third group, is doing graphics APIs, embedded software, drivers, and also develops the compiler for our processors. And finally, there is the AI SDK group, which develops the software development kit for AI, for AI application. Consider the positions. Currently, we have two open positions. The digital IC design engineer, a position about digital IC design, and a second position about AI hardware and modeling. This is mostly at the architectural level. And in the bottom of the slides, there is a URL that you can visit, and you can learn more about this position. And finally, since we are in the city of Thessaloniki, it is important to mention here that Applied Materials and Think Silicon have established a direct connection, and there is a sponsor program in the University of the Aristotle University of Thessaloniki that funds PhD and master students in order to work and perform research in all the activities of the company that I mentioned. So that was the end of my presentation. Thank you.
Thank you, Dr. Keramidas. Are there any questions from the audience now? Okay, you may find Dr. Keramidas outside in the booth, so you may have some answers if you have questions later on. Thank you very much. So we can move on to the next company. It's Chip Globe, and it will be presented by Max Merganthaler and Leah Eleftheriadou. I'm not sure about the pronunciation of...
So, hi everyone, my name is Kalliopi, and I'm the site manager of our Chip Globe office here in Thessaloniki. I'm together with my colleagues here to make a short presentation of our company. So Chip Globe is a consultancy company, meaning that our engineers work on clients' projects. We do not have our own product. We have more than 15 years of successful experience and cooperation with other global semiconductor companies like Infineon, for example. I could say that today we have more than 120 senior engineers globally working for Chip Globe. Okay, our motto is that we will try to make you successful regardless of whether you're a representative company or a student. And on the next slides, you can see our design center location. So Chip Club was founded at first in Munich, in Germany, where the headquarters are still today. There's also one more design center in Dresden, in Germany. And outside Germany, our biggest design center is in Belgrade, Serbia, since 2017. I said biggest because in terms of the number of employees, of course. And here in Thessaloniki, our office has been operating since December 2021. Our office is here in the center of Thessaloniki. We are currently around 10 people. And our latest achievement, let's say, is our brand new design center in Sofia in Bulgaria since May 2023. Outside Europe, we have another two design centers, one in Singapore and one in Vietnam. On this slide, you can check all the services that we offer per location. This is all for Europe design centers. And here, the same for the design centers outside Europe, so for Singapore and Vietnam. Currently, we have open positions in the company here in Greece for verification engineers, RTL design engineers, and embedded system engineers. How we attract and select our executives, okay, this is a big issue, but in short, I could say that we focus on corporate culture, salary expectations, recommendations, and name recognition. Here there's a lot of information about the technical skills required for verification engineer positions, separately for junior and senior positions. But because there's a lot of information, I guess that those who are interested, they'd better pass by our booth later on. Same here for RTL design engineers, the technical skills required separately for junior and senior positions. And as for the soft skills required, because our engineers work in teams, communication is a key factor. So a good level of spoken and written English, at least B2 level, is required. Being a team player, able to cooperate with others, being self-driven and self-motivated, good in problem solving, organized and trust are also things we focus on. What we offer to our engineers the opportunity to work for a stable, expanding German company with excellent working environment. The most important thing is that our engineers work always on one project at a time. This is very important for them. That you will have the chance to work with more than 120 engineers, as I said before, from either from our company abroad or from our client's side. Our Chip Club company also supports a lot the balance between private and professional life. So we offer the chance to work with a hybrid working model. Even fully remote is also possible, and some other, let's say, less important benefits like private health insurance with extra leave days per year, ticket restaurant cards, and other benefits. As for the student and graduate programs, in general, we offer internships in the following fields: on verification, RTL design, embedded systems, and embedded AI. Now, the next cycle of internship will be from March until May, and we will have two separate fields, one for embedded AI and the other one for SOC verification. Usually the internships last around 3 months, and there is of course a perspective for a job offer to successful candidates. We are looking for graduates or final students of electronics or computer engineering or other related fields, of course. You can check the email below for those who want to have their internship with us. And we are waiting for you at our booth to meet you and give you more information about our programs. Thank you very much.
Thank you, Mrs. Eleftheriadou. Any questions from the audience here? Okay, probably you may find Ms. Eleftheriadou in the booth and give other questions if you have. So we can move on to the next company, which is ES Systems, and it will be presented by Theodoros Athanasopoulos. Is he here?
Yeah.
Oh, okay.
Good afternoon, everyone. Here we will present, I hope in short and in a nutshell, ES Systems company, its activities, its capabilities, and its needs in personnel, qualified personnel. So, our story. The ES Systems is part of a larger group of companies, of course, a Greek-owned group of companies. All the companies are mainly specialized in the defense industry. ES Systems, though, is a company that is really activated in the area of industrial, medical, consumer goods. The group of companies actually consists of almost 500 people, and it reaches a yearly turnover of, Manoli, if I'm not mistaken, something like 300 million. So in ES Systems, the core technology starts with, in the microelectronics world, with a process of manufacturing MEMS silicon capacitive pressure sensors, a patented technology, a fabrication process that is owned by the company, and the company produces pressure sensors based on that with unique features. Towards this, of course, the company has developed its own tailor-made CMOS ASICs for the calibration temperature compensations of these sensors. That's the start, though. That's the raw ingredients for a better future in higher levels of integration. So if we take the stack of what we do using these ingredients, is we start with silicon, but then we developed a complete product, including its materials, its mechanics, its electromagnetics, its certification, its packaging, to meet the requirements of the end customers in their solutions. To do that, of course, we need specialized equipment, we need labs, we need clean rooms, which we have. As you can see in the pictures, we have a clean room of class 10,000, we have die bonders, wire bonders, wafer probers. This is equipment that you probably might see at a university, but rarely you will see it in a great company. We have a very well equipped lab, and we can perform not only scientific measurements in the terms of oscilloscopes and signal analyzers, impedance analyzers, and so on and so forth, but also environmental testing. So we can measure the performance of our sensors and our systems, but also make the qualification tests before they are released to market. This is a range of our products, some examples actually, that what we want to show here is that using the same ingredients, we make a different product, we design a different shell for it, and different faces, different embedded software that actually will meet the specifications of its use case. So on the left-hand side, on the top left-hand side, you see sensors that are used mainly in the medical industry, but also in the HVAC industry. On the right-hand side, you see sensors that are used in heavy industrial, in maritime applications, and also in space applications. The services we offer, apart from the products, since it's our core competence, we offer custom MEMS design, of course, based on our technology, CMOS ASIC design, and systems design. What we want to do in the company is actually provide solutions to practical problems to our customers, not just offer silicon devices. These are actually used by OEMs that they will need to generate their own product. But here we use our competence from the low level to the highest level to produce complex solutions to the problems of our customers. So the target markets we are in, as you can see here, and as I explained before, is the medical industry, industrial and aerospace, mostly. However, what we want to show is that doing solutions, it's not, we are in a new era of solutions with data. So in previous years, we were making very complex systems to solve the problem. Today, we are trying to make simpler systems, simpler hardware with less components, lower cost, with less power consumption, and transfers this problem to the point of doing mathematical operations at a more capable system. The company encompassed this approach and actually got activated into the area of IoT, mainly with major industrial IoT solutions. I'm showing you here a typical IoT system architecture. On the left-hand side are the things, so mostly the sensors and the actuators. We have the network part, and then we have the cloud part. Of course, here there are several discussions where the data is stored, where the data is processed, pre-processed, where the machine learning is, where the AI is. Okay, but the architecture is always this. The company has worked, as I said, in several mainly industrial cases, but also medical cases, which are according to the company's scope. And you can see that we are working with motorways and to do predictive maintenance systems based on sensors and 24/7, 365 monitoring. LiDAR solutions, oxygen sensors, smart oxygen sensors in hospitals to actually monitor the consumption of oxygen together with the effect of oxygen therapies in of the patients, but also back-end systems for those. And here is the hardware that actually is correlated and performing these functions for us. All of this hardware is designed in-house in all of its aspects. On the electronics part, on the embedded software part, on the high-level software part, on the mechanical, even the installation in some cases, because in most of these products, if someone goes out in the field to do an installation, for this to work, actually, not only the functionality of the hardware is enough, everything works nice in the lab, but not in the field. So a great experience is needed, an understanding of the physical problem you're trying to solve. So an example of this, which the company is very proud of, and actually is rolling out in a higher volume nowadays, is the system that ES System built for condition monitoring of motorway assets. So as you have traveled in motorways in Greece, you will see in tunnels there are a lot of fans on the roofs, but there are also things that you don't see, and they work all the time for you to drive safely. There are generators, UPS systems, heavy electrical systems, pump stations for fire protection. All this equipment must work. They cannot fail. So there has to be a system that monitors them, monitors their health during their operation, and informs you when things need to be addressed. The model that these operate today is that there is a heavy preventive maintenance schedule and program. which costs a lot of money, and it's really and it's implemented really difficult, in a difficult way, by closing roads during the night, having personnel during the night to work, which is something very expensive. What we're trying to do here is replace this or reduce this to a minimum by having a system to do these measurements 24/7 and actually let the system decide after it is well trained when it is necessary to have such activities. Already the system in some of the assets that it's monitoring has produced great results and reduced costs, such as the UPS batteries. And here is an example of how things are showed to our customers and how data is produced and dashboarded in a way that it's immediately apparent if a defect is coming. So, bringing back your image of the architecture we showed, here we put some different images to understand the initial phrase from silicon to the cloud. So, how ES Systems makes their products. We start from the silicon, we get a packaged sensor, which is a component. Then we do sensor systems with aggregation of sensors together with some processing power, usually connectivity, usually battery, for the sensors to be autonomous. Then we have our cloud infrastructure where data or metadata are transferred there and stored. And then we have, or analyzed. And then we have our platforms that actually perform several functions. One is to present the data. The other is to produce notification alarms and actuations back to the system. And the third is to do a higher degree of analysis on the analyzed data that we start from analysis on separate devices, but then on the cloud we perform analysis on the aggregation of all devices. For all of this, we need all these disciplines. We have a very intensive R&D team, and we seek rigorously disciplines like the ones you see here, but especially embedded software, hardware design disciplines. You can see our open career opportunities, and you can also visit our website at the link provided, where you will see all our open opportunities here. And of course, you are welcome to come and see me outside or here for this. And one important aspect for students is that we offer internship opportunities in our R&D department according to university's framework or in different frameworks. Thank you.
Thank you, Mr. Athanasopoulos. Are there any questions? Okay, you may find Mr. Athanasopoulos outside in the booth. And now here we can move on for the next presentation of the company Olympia Electronics by Sofia Hadzifoti.
So, hello everybody. My name is Lena Maravella. Apparently I'm not Sofia Hadzifoti, who is the HR manager, the HR director of our company, and responsible for all that wonderful presentation that I'm about to do, because it's a little bit cold. But she's here for any question outside in the booth or inside after the presentation that I will just go forward. So we are Olympia Electronics, and we are the market leaders in the electronic safety and security industry. The company is active in developing innovative electric safety and security systems by using state-of-the-art technology. Our mission is to promote and implement innovation in all our products in order to gain international recognition. Our business culture is focused on employee-oriented philosophy, high values and traditions, continuous training, teamwork, and innovation. And going back to that, I have to mention, as not big in the HR department, we are extremely focused in continuous training and in innovation. So our company's primary goal is to produce high-quality products, state-of-the-art technology, and innovation and competitive price levels. In order to achieve that, we focus to be an easy-to-do business with company, to apply environmentally friendly techniques at all levels of our operations, and we're focusing on ESG compliance, and to provide impeccable after-sales service and technical support. Now, our products, as I've mentioned before, have to do with safety. And we actually design and provide emergency lighting systems, fire detection systems, gas detection systems, intrusion alarm systems, electronic room thermostats, hotel access systems, and emergency lighting and detection systems for marine applications. We're a company based in Aegynio, but we are exporting in 72 different countries around the globe, which are actually in European Union, Eastern European countries and Russia, Middle East and Gulf countries, Africa, and of course, America. Our sites are, as I've told you, our headquarters are in Aegynio, nearby Thessaloniki, here in Central Macedonia. We have also an innovation hub in Thessaloniki, in Porto Center, and of course a branch in Athens. Our R&D department, its main operations, actually has to do with embedded software firming, new products development, so it comes with the age, you can actually see letters that you haven't written. Okay, analog and digital designing, building and wireless communication protocols, development and support in Microsoft techniques, and database, what it says here, SQL servers. We are actually hiring and have actually in our company graduate specialists from technological fields currently, and which are actually technological studies engineer, junior and senior embedded engineer, software engineer, and cybersecurity specialists. So these are actually the new places, the new stuff that we are looking for, and it's full stack software development, junior and senior embedded software engineer, as you can see, cybersecurity specialist, and system architect for embedded systems, and these are the qualifications required. But as you can see here, is not only the hard skills that we are looking for, there are also the soft skills. And in fact, actually, the soft skills are much more important than the, hard skills that are required in all these jobs. It's not me. Believe me, it's not me doing that. Though I'm lacking all these hard skills. Okay, now it's okay. It's okay. So the hard skills we are looking for is artificial intelligence, Internet of Things, use of digital scientific tools, cloud computing, users' experience, programming languages, and research and data analysis. I'm sure that everybody that feels that has all of these or some of these skills can apply with us, and we will make sure that he will actually expand on these skills. So we are looking also, or merely, for team working, problem solving, multitasking, creativity, adjustability, and of course, emotional intelligence. We offer internships, as mostly all of these companies, and we are looking for technical studies, PCB assembly and 3D printing, software hardware development, testing and debugging, and technical support. You can all apply to our HR department, and as long as it refers to internships, we usually accept people on September, December, and March, every 3 months actually. And you can send your CVs at cv@Olympia Electronics or HR@Olympia Electronics to Sofia Hadzifoti. And here is a small, actually, sample of our company. A small video. Okay, that's us. The audio lags. So you can't see it. Sorry. I just thought you were all watching now, and I was just sorry. But you're all welcome to watch that outside in our stand, or you can actually get to our URL in our site and watch our video. Okay.
Okay. Thank you very much. And now we can go forward to the next company, uBlocks, which will be presented by Panos Pagratis.
Hi, hello. My name is Panos Pagratis. I'm the HR manager of uBlocks Athens office, and I would like to show you some things about uBlocks and also to give you some information about the office in Athens. So uBlocks is a Swiss semiconductor company founded in 1997 in Zurich from researchers of Swiss Federal Institute of Technology of Zurich, and listed in Swiss market from 2007. And what we are doing is we are designing and producing small interfaces for embedded systems and for small computers. And these interfaces, the technologies that we are designing and producing these interfaces, is satellite-based positioning technologies like GPS and the other satellite-based positioning technologies, and also cellular technologies like 4G, 5G, 2G, 3G, and also short-range radio technologies. And the short-range radio technologies that we are designing and producing interfaces is in Wi-Fi and Bluetooth. What we are offering is chips, the chips that we are designing for GNSS technologies or cellular or short-range technologies, or modules, which means a turnkey solution, something which is ready. It's having also the chip inside and everything else in order to be ready and to be used by the customer. And also we have created some services, cloud services, for our chips and modules. the focus that we have is three markets: is the automotive industry, where we are leaders, especially with GNSS technologies, and then industrial application, industrial customers, and industrial products. And also we have a good market share in consumer-related products and applications. Our business model is fabless. We don't have our own fabs to print our chips, but we're using the well-known fabs in Asia. And also commercial off-the-shelf means that we are not selling designs, or we're not providing our OP, selling our IP or technology. We're offering the product commercially, physically, the chip or the module. We are 600, almost 600, or a little above 600 million Swiss francs company, and founded almost 20% of our revenues are invested again in R&D activities. We have many customers around the world. We are almost 400 people, and what these products that we are designing, what are the business of these products? As I show you in these four areas, we are designing these small chips and modules, as you can see in this slide. And these interfaces, what they do, they bring things to the cloud. So anything which is out there need to be connected somehow with the cloud. So it need a cellular interface or a Wi-Fi interface, need to be connected with the surrounding nodes or with the surrounding other microsystems, so need a Bluetooth interface. And of course, for many of these applications, need to know the geographical location and to report it. And all these things are creating these nice things that is here and is coming, which is the Internet of Things and all these billions of things waiting to be connected. And this is our business, this is our market. We are creating, designing, and producing these interfaces in order all these products to be connected. This is this shows that we have a many different types of chips and modules depending from the application, from the market, from the size, from the pinout, and from other things. About positioning technologies, we are leader and we are considered as a reference for positioning technologies because we have one of the best positioning technologies in the world, and we have a leading role. Our technologies are offering standard precision, GNSS, high precision GNSS, dead reckoning, and also timing-related things. About our cellular chips and modules, these are used mainly for either tracking, like fleet management, or also for metering, as an example, and also for automation, city automation or home automation, and also for some more consumer-oriented application and markets. And then the short-range products that we have are used also for sensor-related applications in medical cases, and also in gateways and networks. We have many customers, well-known customers around the world, working with us for many years, choosing our interfaces for creating their products. The R&D is our growth engine. We are engineers. We are 1,400 people around the world, and 900 of them are engineers. And we have many R&D offices around Europe and also in US and in Asia. One of these offices is in Athens. We are located in Marousi, in the north area of Athens, and we are currently 76 people in Marousi. 70 of them are engineers, and the engineering specialization or the engineering areas that we have and the activities in Athens is in digital IC design, analog IC design, embedded software engineering, firmware development for the chips and the modules, and also we have some colleagues taking care or designing also some of the tools, the web-related tools for the Windows systems and for browsers in order to our customers to be able to evaluate our products. And we have many many job openings all the year. We are looking for more engineers. We want to grow further in Greece, and we are offering internships. We have, from time to time, we are advertising these internships in our website, but of course we are also offering internships through the synergies and the collaboration that we have with the different R&D teams with the universities in Patras and in Thessaloniki, in Athens. And we offer, we have a complete package of benefits, and you can see here the number of benefits. And I would like to thank you for listening.
Thank you, Mr. Pagratis. Any questions here? Okay, you may find Mr. Pagratis in the booth of the company, and you may ask questions there. And now we have the next, the Macy company. It will be presented by Savas Gourenas.
Hi all, my name is Savas Gourenas. I am CEO of ETCEI. ETCEI is a high-tech company in the semiconductor field. Our vision for the company expertise is to build telecommunication chips. Our vision is to transform the way that people connect with each other. The company, our target for the future is to, for the ETCEI to be a global player, so all the people, all the companies across the world would recognize ETCEI as a global player in RFIC design. Our specialty is the wireless and wireline communication, and we support the next generation of the standards. One of our important goals for the company is to make ETCEI a premier hub for engineering and extend our team to include more talented engineers. Our fields of design is the analog mixed signal, milliwave and RF design, digital design that supports mainly the analog as well as layout, physical design. The fields of our expertise are two paths: the wireless transceivers as well as the high-speed transceivers. The wireless application that we are targeting is 5G, Wi-Fi, Bluetooth, and on the other hand, for the high speed, we're targeting USB 4, PCI Express, DisplayPort. In this application that we're presenting here, our company has already completed successful tape-outs. Our key design flow to achieve a successful tape-out at the end, a successful product, has specific steps. We are supporting the architecture design, the electrical design, the circuit design in all the fields like analog, mixed signal, milliwave. We also support the layout, the physical design, and the chip finishing. ETCEI, in ETCEI premises, there is also established a lab that we currently use to characterize our transceivers. In the company expertise regarding the process nodes that we have worked includes FinFET, RF SOI processes by CMOS. At the moment, in our company, there is the expertise, and also there is the chance for the new engineers to work in advanced FinFET processes like 12 or in 7 nanometers. During the 3.5 years of the company, MEXI is a new company. During the 3.5 years, we have completed 6 successful tape-outs. The tape-outs include Wi-Fi transceivers, which are and 5G transceiver. We also expand in the digital design, and one of the projects is ultra-wideband design for the MAC layer. One of the key also project was the Wi-Fi 6, 6E and Bluetooth combo transceiver. This project, this chip has already measured, characterized, and will be in market in 1 year from now. It will be in the routers and the access points. Our designs has also presented in the microwave conference in Barcelona last year. We also started implementing our company IP, which is the ultra low power Bluetooth. And among the projects, we also have expanded in SerDes. Our vision, our next step, is to move to the next generation of Wi-Fi. As I mentioned, also the ultra low power Bluetooth, and one of the targets is to also enter automotive market. The growth of the MEXI started in 2020 with 2 people. We expanded in 3 years to 20 people, and our target is at the end of this year to become 23. This, we don't know now if we can achieve that, but this is our goal. Majority of our design team are analog NRF designers. We also have a dedicated layout group that performs the physical design for our transceivers. There is also a digital group. There is also a lab engineer, dedicated lab engineer to perform the characterization, and also there is the project manager. All of our engineers are qualified with a good education level. So most of them are PhD, they hold a PhD degree, and the rest hold a master in microelectronics. The board team, apart from me, is Chris Avasu, that is a COO and program manager in the company. Haris Basetas is the digital lead, has its own group, and also works on the commercial development. And Vasilis is our CTO, and also do the RF and milliwave lead. For us, one of the important things in our company is to build a long partnership with our customer, and this is what we have already been successful, so our customer keep working with us. We are targeting innovation. Without innovation, we cannot design advanced products, high-end products that we design now in the ETCEI. And one of the important things is the transparent communication. Currently, ETCEI has a strong connection with the universities, and we try to attract talented people in the company. We have open positions in RF and analog design, physical design, and also in we have position in the lab engineer. In ETCEI now gives the choice for the people to work in high-end products, in advanced processes. The products that we are working will be in the market in 2-3 years from the time that we start developing. Please, all the people, feel free to come to our desk if there are any further questions. Also, you can send your CVs in our careers.mexicom mail address.
Thank you, Mr. Zgourinas. Is there any question from the audience here? Okay, thank you. You probably may find Mr. Zgourinas outside the booth. And now we can continue with the keynote speech. Mr. Mathiakis, you may replace me.
Hello, you can hear me. So the next and the last keynote will be presented by Dr. Vasilios Hadzikos. Dr. Hadzikos has made his dissertation in the University of Sheffield in 2004. And since then he has gathered significant managerial experience in the different sectors. The last 8 years he has been with Siemens, and if I'm not mistaken, the last 2 years acting as the Chief Executive Officer of Siemens. So, please, Mr.
So, I think, is there anyone not speaking Greek here? Oh, you, okay. So, I will stay with English then, for you. So, thank you very much for the chance to be here. It's a bit quiet. The day and the hour, it's not very easy for this kind of talk. So I would like to be a bit different from what you had over the last 2 days. I'm not going to deep dive into technology or solutions or new things that are coming up. I will mostly focus on how we implement or what are the mega trends in the world today, how we are adapting in countries like Greece with new ways of doing business, and how, for sure, the digital transformation of the market will affect the future year regarding the solution, the production, the way we live, and for sure how we as Siemens are active in a country like Greece on providing this kind of solutions. So very quickly, we know that industry and industrial production affects all areas of life, from producing clothes, from food, from medicine, from way of living. Pretty much everything is industrialized and produced by the industries. And for sure, lately, over the last years, we know that we face huge issues regarding our planet, climate issues that affect pretty much the strategy of almost all of the multinational companies, is how you adapt to these changes, how you have your CO2 emissions improved, how you reduce your energy consumptions, and for sure how you optimize your resource allocation. And this is one strong lever of how we at Siemens, we are include the technology and the new solutions coming from the technologies used to focus on these areas. It's quite straightforward, and lately we see that almost all the companies around the world adopt these strong KPIs regarding the sustainability thing, and they change the way of doing business everywhere. So for sure, the digital transformation and the technologies behind this, they drive a new potential of how you go to market, how you adapt your ways of doing solutions, and how you nowadays fulfill your environmental KPIs. And this is for us also Siemens, even though engineering company, traditional engineering company that is transforming a lot lately, we adapt our offerings and our solutions to the markets. So let's see very quickly what we mean by digital transformation. When we have an industrial plant, what that means for us. So this is a good example how digital technologies, affect typical things from how you create your products, how you set up your production lines, and how you obtain these really challenging sustainability targets. And for sure, the digital technologies is really coming more and more into this new way of working, new ways of productions. And for us, it's quite important to understand that we have the benefit of having factories around the world where we can implement, and this is how we started, by implement these new technologies into our own factories. So in a sort of, we had a benchmark of examining and doing all these new ways of using the technology within our factories, and for sure use it as a best practices. And it's not only the technology that is coming into the production and the market, but also the way of the market's requirements are changing. So it's very well known that we move from a typical way of producing into a more centric, more customer mindset with certified needs. For example, we see that we don't buy music anymore using CDs and hardware, but we use Spotify. And the new technologies is to optimize this way of how you integrate these new ways of customer needs into your solutions. And typical examples like the Rolls-Royce jet engines machines, that you change also your business model as your pay per hour things. So it's quite clear that we are moving from mass production, that one size fits for all, more to the more personalized. And this is also now you need to adapt this into your productions and to be able to move fast. And we will see later on some of the KPIs of how you optimize and how you change in this. I use an example. Yesterday my son ordered a new Nike shoes. He wanted to have his own color, his own name into the shoes, and to buy it online. So just to understand how a 12-year-old think of the future and how now all these production needs are changing very fast. And we, Siemens, we have change our way of approaching the markets and using these new technologies to adopt our solutions. And as I just said with my son, it's not like we expect, and this is something that I discussed last week with our CTO, Dirk Didaskalu, who was here in Greece. We don't expect many more technologies to come, new technologies to come. Technology is already here, and most of it, we've been knowing AI for many years. We know the cloud thing. We have the computational power to implement it faster, but now it's the mindset that it changed. The mindset of everybody, of us, of our consumers, of our industrial production managers, of our engineers, and etc. And typical examples, and I will go very quickly on this, the way we act, we consume, and for sure the way of new things are coming into the everyday life. So, quite clear, the technologies are also further supported to be implemented quicker by a lot of other issues that are coming. The challenges now for industrial production is for sure the cost pressure and efficiency, quality, flexibility and scalability, faster innovation cycles of your productions. And also it's quite clear to everyone, global-wise, that we have three main issues to tackle very quickly. Also for the local industrial customers here in Greece, apart from the sustainability that I've already mentioned quite clear, we have the lack of talent. That was something I'd already discussed also with Mr. Zervakis outside, and we see that also in Greece now it's really difficult for companies like us, like LP, and a way to find proper talents to use. And this will have a huge issue on the future years. It's estimated around 8 million engineering works will be lacked by 2030, and this is around 600 billion. And also the supply and demand needs. We faced the COVID, where we had the huge issues regarding the logistic thing, and also this can increase prices quite heavily. So technology is coming in a way to adapt, also with customers like speed, flexibility, efficiency, security, high quality, safety, health, smart. I can mention a lot of new numbers of how we need to provide solutions to all these customers in order to proceed for further for that. And for us, the digital approach is one way. I haven't mentioned yet about technologies or commenting, but the digital transformation of the businesses is a must. We see it also here in Greece, that more and more, especially industrial companies, that they export a lot, they need to fulfill specific KPIs, sustainability KPIs, they need to be more cost efficient, they need to produce more. So we need to integrate this digital solution into the way of manufacturing and production. And for us at Siemens, it was quite straightforward. It was not through our R&D. We invested heavily, more than 10 billion, and Tom is well aware, you can see Medor graphics on it, of acquiring software companies. Software companies and software, industrial software that can really give us an edge on what we call designing and simulating and using digital twins, and you will see a lot of other things and interconnecting things, getting expertise on process know-how, and by being a number one automation company, now we are considered ourselves as a number one industrial software company as well. And now, as I mentioned, integrating all the software into our portfolio and our offerings, we move from a typical traditional engineering company to more a software company. And we started with our own plants and how we optimize, how we design and integrate all this technology into our plants. And the three main pillars that for us is a priority, and I think for everybody in the world, it goes from data and analytics and of course AI, how you integrate and how you take advantage of your data in order to provide your solutions. Simulation and digital twins, which is for us the major step for moving into metaverse, and we will see what it means metaverse for us, and for sure the cybersecurity and trust. So within these three pillars, we in a way, we adapted our portfolio, our software solutions. We even acquire Medix, which is a low-code, no-code language, in order to be able to build and interconnect things, and really easy to try to manage data in an efficient way. And for sure, we create a lot of data. We consider that 1/3 of the automation production is based on Siemens PLCs. In a way, we create around 100 terabytes per hour. This is more than all Netflix movies that you see. So we need flexibles, and this was part of our strategy, flexible ways of getting the data, analyzing the data, and really optimizing, getting the expertise from the data to design new solutions. And for sure, having solutions like Medix and all the software and ways of designing things, we see really a lot of easiness of implementing AI, of getting new technologies on site, not just on cloud, but using edge, using all these kind of technologies. And for sure, as I mentioned, having the solutions like Medix for us, and we've already started here in Greece as well to implement quite strong Medix as the main interconnection lever within different software, different production stages, different MES systems in order to interconnect data and get this data quite straightforward and easy, either through edge, which is coming more and more, or using cloud as the benchmark for this. The second thing, and for sure something that we focus a lot in Greece, is the digital twin. As we mentioned, the digital twin is a way of connecting the real and the digital world. You can use all these softwares that we mentioned on designing, on moving from real to the digital world quite accurate, and also include the process know-how on this. And just to give you a typical example, on a plant simulation, you can see that now we have the chance of really getting the real world into the digital world and do the simulations. And it's quite straightforward by being able to provide simulations and analytics on the way, and even to go with the trial and error on a digital world is much more efficient and solution-driven to optimize your backlogs, your preventive maintenance studies, your performance KPIs, and all of these indicators. That is quite straightforward. And Technomatics is a powerful tool that we have also started implementing here in Greece in some of our key customers, and really the results that we see are great. So you can see that you can simulate 500 Morse, a typical production thing, on a real world, on a digital world, much faster, and really you can identify it and improve your ways of performing. It's not only the production, but you see that this range of software, you can analyze pretty much everything. You have a really digital twin of a motor, you can analyze all and I had a nice discussion with Kenaton business of how they do the analysis, how they find. So you can really optimize everything from product to production, and you can have some great results. So from these pillars, what we see as the next step. The next step that we see is industrial metaverse. Industrial metaverse can combine, and it's the next big thing that is coming throughout the world. For us at Siemens, this is a priority for the future as well, how you integrate and move from digital twin to industrial metaverse. Industrial metaverse, it's a virtual world where you pretty much you can integrate everything. You can use your digital twin to have a real-time optimization and to include all your technologies on it, simulate, and have a real-time way of doing. This is not here yet, just to be clear of it. This is what is coming, and we will see later on also the market that we see the industrial metaverse is quite important. What I need to highlight that I haven't mentioned yet is also we, on the regional countries, as Greece, we are transforming our organization structure in order to be able to move to this kind of solution. So we at Siemens, we have created application teams. We're building up an ecosystem of partners with specialized companies that they can really provide this kind of expertise and know-how in the software business, on the cloud application, on all these interconnections, subfloor, cybersecurity things, in order to be able to provide these solutions. And the three main categories that we see metaverse, for sure, is consumer, enterprise, and industrial. And this is coming also from the global trends that, according to many research companies, industrial metaverse by 2030 will be something much bigger that most of the other channels like enterprise and consumer, and we're talking about $100 billion of yearly market. So this thing will grow exponentially the next year and will solve a lot of issues right now, and for sure we will move quite fast. So this is a short video that I think that it can go through what we see in a case study like an industrial metaverse, if I can make it to run.
There's some video link. We cannot.
Maybe the technology is not supporting us yet. 2030 will be much better. So yes, this is the video. This is how a company will look like by 2030 using metaverse. Examining all the factories or the production lines, having the full transparency of the production, on the basic APIs, making Teams conferences where you just move into the metaverse to identify issues, to see your production. This is based on digital twin, I will say real-time digital twin now, not moving into a metaverse world. So you have the chance to go and analyze your machines, your production. For sure, now we're talking much higher graphics and quality of graphics. This is why you will see that we, Siemens, we have collaborated with NVIDIA to optimize this kind of graphics metaverse environment. And then you can optimize, simulate, identify maintenance issues for pretty much everything. I think if we move a bit forward, we see also the production line moving. This is actually, if you consider 100 terabytes of data, this is actually how you interconnect this with metaverse. You have a lot of data that you can get into this. You can optimize your production, your scheduling, your pretty much everything. This thing for sure is not here yet, but it will come. And it seems that most of the companies will invest on it, starting from Facebook, which was the first company that invested in metaverse. Also companies like Siemens and NVIDIA, for example, are really heavily investing on these new trends. So I think we can move forward. So the fourth industrial revolution for us, for sure, is combining the real and the digital world. And for sure, we have here at Siemens Greece, we have really one challenge in how we integrate and implement locally these technologies, how we boost up our customers, our partners on building a strong ecosystem and being able to implement all these strategies in Greece. So this was a rather quick overview of the technology part of how we address the market, and for sure we have some time for questions, I can guess.
Thank you very much, Dr. Hadziko. It was a very nice presentation, very comprehensive. So if there are any questions from the audience. Yes, please, microphone.
So first of all, thank you very much. I have many questions, but I will limit myself to two of them. First of all, you mentioned that you are actively trying, at least what I got here in Greece, to optimize the operation of real industries. Okay, and assuming that one of the main goal will be to reduce the CO2 emissions. If you have to do only one thing in Greek industry, what will be your solution there in order to go to...
For me, it's easy. Coming from the industry from the last 15 years, coming from the automation world, if I exclude some top industries like LP, Titanas, motor oil, then what is lacking to our industrial customers is the way of simulating digital twin and optimizing your production. In order to get on these sustainability targets, and don't get me wrong, most of our top customers, they export. And when there's an aluminum company export to a German company who have high sustainability targets, you cannot be competitive anymore if you don't optimize your production, if you don't have strong sustainability targets on the way you produce or you design your products. So for me, digital twin at the moment, this is our focus area because we move from the more automation into more simulation, and this is how we create our first proof of concept together with our local partners here. We have partners on software, we have partners on automation, on mechatronics design, this kind of partners that we can co-create the solutions using digital twin. We have started quite a few proof of concept that they really give some significant results on industrial customers, how they automate the production, how they improve the mechanical way of producing things, and for sure this is for me really the next step.
Okay, okay. So going to the second question, I know that Siemens is a pioneer in Industry 4.0. So I guess we discussed also yesterday about Industry 5.0. So your comment there, where we are comparing to Industry 5.0 and what we should expect for Industry 5.0.
As I said, we have some top industrial companies that they have moved quite strong on Industry 4. But we're still in the main part of the Greek market, especially for production, even on buildings, on sustainability, we're still in Industry 3. We're still on the automation level. So we need to move faster, getting closer to integrating these new technologies on Industry 4 level. That means interconnecting things, having more advanced algorithms into my production, redesigning the production, having maybe AI more and more coming into decision making, not even real, even offline. This is quite important. And then for us, it's the Industry 5, at least in Greece. In other countries, we know that things are moving faster. 5G started to be available in Northern European countries. In America is moving fast. China is moving fast. For us, still in Europe, we're good on creating a lot of legislation, as we discussed. So for sure, we need to move fast on this.
Okay, thank you.
Yes.
Thank you. I'm Dimitris Kiritis from EPFL and University of Oslo. May I have also two questions?
Yes.
More technical. So you mentioned in this inspiring video of the metaverse, as you call it, so I don't know if I would use this term. It's not the metaverse of Facebook, it's another kind of metaverse.
Yes, exactly.
So you showed in the video, so in fact it's a value chain, and there you have data that are coming from various stakeholders in the value chain. So then there is the question of data sharing, how data are shared, and related to that is my second question. You mentioned also cybersecurity and trust, and I would like to make a comment on data sharing and trust.
No, really great question. I mean, the data sharing, we currently on the digital twin project, we stay locally. We share info based on NDAs and confidentiality within the customers, and we don't use cloud a lot at the moment. As I said, even the legislation is not very fit for a go-to-market at the moment of how you use. Yeah. On the contrary, we see Microsoft, for example, on Azure usage getting more and more into the business, also AWS. That means that big industrial customers, now they get their data in cloud. So the cloud usage will evolve quite fast, especially with all the new AI technologies and the Copilot things announced by Microsoft. More and more data will be done. And so far in Greece, we stay locally, just to share this. And this is a challenge of how we coming from the operational level, how we integrate on this IT world, how we take the data, how is edge implemented properly into the customers. This is still, I would say, not quite forward even for companies like us, what's the go-to-market. The good thing is that on countries, and we as Siemens Greece, we have the liberty on finding the best solution for the customer sometimes. So the customer is in parallel on this journey making strong decisions of what he wants to do. Regarding cybersecurity, cybersecurity is a huge issue. Also in industrial customers, we see more and more the threat that is coming. We have lived over the last couple of years having production lines stopped for ransom, and this is a big issue. I would say that we have worked with some of the top production companies to make these cybersecurity audits, and now to be more and more implementing different layers of security even on the production lines. But most of the market is still not very secured, and this is a huge issue. You can have, if your PC is blocked, you can lose your emails. If a production line is stopped, we're talking about huge losses of money per day, per hour, and etc. So we've seen in Greece quite a few have implemented, to be honest, over the last 2 years, 3 big projects for big industrial customers where we, after issues and incidents, we have implemented cybersecurity activities, defending a bit more on the operational level, but still things are not very good for most of the customers.
Thank you.
Okay, thank you very much for your speech. I would like to ask, you mentioned that you, as Siemens, you partner with, you have a lot of partners and you outsource, of course, some activities. So operationally, in the industrial metaverse field of your activities, your approach is more vertical, or you try to also outsource things? Because I'd like to ask, for example, for a new startup that focuses on this field, on the industrial metaverse, and provides solutions in small projects to smaller companies than Siemens. What would you suggest to these kind of companies?
We are heavily investing on an ecosystem. This is quite clear that the new technologies is not part of Siemens strategy, it's an ecosystem. And startups are the more flexible and easy way to get on board on this kind of new technologies. In Greece, we have the strategy, I would say, to co-create with partners. We are using the vertical approach where we get our best practices, our vertical expert know-how from headquarters or from best practice around the world, and then we co-create locally. This is the challenge, and this is how a strong ecosystem works, and this is what is added value for us as Siemens Greece here. And startups and IT-oriented companies with really flexible ways for us is really strong alliance for implementing all these technologies. As I mentioned, industrial metaverse is not here. Digital twin is here, so you need to have different kind of partners to create a really good digital twin application, coming from the software, from the mechanical part, from the process know-how, from the automation level, so you can co-create with a lot of partners on this.
So you would suggest them to focus on the digital twin aspect of things? To
At the moment, this is where we see the potential. And even though the market is not here yet, you need to convince the market of moving from the real world into a digital twin and do simulations. When you go into an expert production manager, he knows everything. And this is out of 30 years of experience. He knows if a mixer can work 2 ways, 3 ways. But the digital twin, for sure, it's what I would right now focus a lot. Also, cybersecurity is something quite important, but on a different layer.
Thank you.
Okay, Telia.
And since we have some time, I will do the last questions. Or is there some other question? Not really. We have seen a lot of applications in the presentation using digital twins for improving efficiency and optimizing the procedure. Do you also use this for predictive maintenance, or do you see some trend in the future for?
Yes, exactly. Preventive maintenance, asset management is areas where the digital twin can really give you good results, especially having accurate models. You can really optimize your downtimes, your resource allocation, your assets in this way, and for sure it's one of the key areas that digital twin can be good. Also, digital twin is really good on production optimization. So how you improve your production, where you find your backlogs, how you make your improvements. Digital twin, an accurate digital twin, can really give you the transparency of what's happening and things that you can do. For example, on a proof of concept that we do for a really big Greek industry here, we've been asked to automate the fully manually storage of products in a difficult product. So we create a digital twin, we optimize the mechanical part in order to be able to move faster. We simulate this, we connect it with mechatronics design to start and check all the movement, then with simulation studies and PLC sim advanced. So in a way, we had all the way through to the PLCs, and 95% of the PLC code was prepared through the digital twin. We identified all the lags. We saw why manually, how is the behavior of the product, how is the behavior of the machine, all this analytic, and we create a new structure that at the moment improves performance around 25% on the production and also reduce cost around 60%. So this kind of KPIs are really strong. The return of investment is quite fast.
So thank you very much, and thank you very much for being so interactive.
Okay. Now, now we have two invited speeches. Mr. Viron is here. The first talk is from Viron Chrysovergis, manager at Technology Transfer and Innovation Office here from Aristotle University. And the title of his talk is Technology Transfer and Innovation at Aristotle University of Thessaloniki.
Okay, hello everyone. My presentation is here, thank you. Okay, my name is Byron Chrysovergis. I represent the Technology Transfer Office of Aristotle University, and I will talk to you for 10 minutes about our main activities the last couple of years and where we aim to go during the next 5 years approximately. The three main missions of every university across the world are these three: education, research, and technology transfer, what we call innovation or impact to the society, how basically we solve through our research real problems in the real world. Aristotle University is the largest university of Southeastern Europe, of the region in general, and in the educational mission, as you know, has a great history and huge successes along the years. In the research field, and the second mission, as you can see from this side, is also its impact is very big, with more than 300 laboratories. More specifically, I think they, through a very recent count that we did, it's 395, the laboratories that currently exist in the campus and produce very interesting research results and new technologies and new knowledge in every, basically, scientific field. As you can see, approximately about 7,000 active research projects are, during the last 5 years, running at the university, with a total funding of more than 300 million euros, of which about 1/4 comes from the industry, from private institutions, which shows also the connection that already exists with the market and the industry. So, what about this third mission? How is technology transfer achieved in our university? These 5 ways are basically what we do and what every university across the world is doing. First of all is the research in collaboration with industry partners. As I told you, this is very big already. About 30% of our budget is on that. Then the selling of our research results, either after IP protection or without prior IP protection. The licensing in exchange for royalties, exclusive or not, after IP protection or without prior IP protection. The private research project for the commercialization of research results via the research committee through an umbrella, as we call it, project, or a new research project. And finally, the establishment of new companies, what we call spin-offs, which could be either startups, as we said also previously, meaning companies with a business model aiming to scale globally very quickly, or not. Companies just provide services or sell their products in a local or national level. But these spin-offs, these either startups or not, have the specific characteristic that they basically sell products that are created by technologies or methodologies that have been developed inside the university using the university facilities. Our office is part of the Department of the Research Planning and Support of the Research Committee and is the contact point between the academic community and the industry. It operates during the last decade, since 2012, and is responsible for ensuring awareness among the academic community on the commercialization of research results and technology transfer, for the protection, management, and promotion of the intellectual property of the academic community according to the academic code of conduct and principles, and also responsible for creating the mechanism for technology transfer, these licenses, the spin-offs, how these companies will be created, what will be the procedures that we should follow, and the research in collaboration with industry partners. All these activities have specific procedures that need to be followed inside the university. Okay, this is a slide that basically describes the evolution of our office during the last 20, 30 years. The office was launched in 2012. 2015 was an important year because it was further developed and the rectorate authorities realized the importance of the existence of such an office. So, yeah, our university is basically one of the few Greek universities that really support financially and in a policy level this third mission. And from 2020 till today, we have seen an exponential development of our office through funding from either national funds from the Ministry of Education and the Ministry of Development, or from European grants, which we proposed some projects and we got accepted. So we managed to gather enough funding in order to exponentially develop our office. And these are the pillars of, the main pillars of our activities. We start with awareness, as I told you before, that's the most important one, in which we participate. We try to be participating in almost every event that has to do and could help us in the matchmaking with industry partners. We do every day basically meetings with members of the academic community to inform them about their opportunities and capabilities through our office. We created a student antenna. Some members of the academic community, mostly PhD students, candidates, in order to spread our word in every faculty of the university. And we do a lot of work and campaigns on social media. We organize entrepreneurship competitions and hackathons. We participate in the organizing committee of the Technology Forum. So we try to be basically everywhere that a matchmaking or collaboration could happen. After this awareness part, we focus more on working with specific teams that are more mature on exploiting or commercializing their research results, and we consult them and we work with them regarding their protection of intellectual property or the matchmaking or the participation in projects aiming at the protection and commercialization of IP. We have also created a new Center for Entrepreneurship and Innovation at Aristotle University, which is called WOC, Youth Innovation Accelerator, inspired by Aristotle's peripatetic school, and I will tell you a little bit more about that. And a talent pool through this Center for Entrepreneurship. The talent pool is a new and a very ambitious initiative that aims to connect individual students or researchers with no, basically, a team or an innovative idea that could participate in the acceleration program that we organize in WOC. So individual students that just want to somehow take part into this innovation ecosystem of our university could connect with student entrepreneurial or research teams of the university through a matchmaking process that we coordinate according to their needs. So all these actions basically lead to what we call technology transfer, and this is the establishment of new companies, the licensing, and the protection of the intellectual property through patents. These are some numbers, which some of them need to be updated. We have 91 active patents, 16 spin-offs, about 20 licenses for IMP deployment, and more than 1,000 active projects in collaboration with industry. Here you can see the logos of our spin-offs. As you can see, starting from top of the page, Exothermia and Emissia were the first ones, about 2008, created by the School of Mechanical Engineering. And then we had about 7 years that nothing basically happened and no new companies were created. 2015, as I told you, was a seminal year for our office with the creation of 4 new spin-offs, most of them from the School of Engineering. And then during the last basically 5 years, we have seen then exponential development in that, and a lot of new companies from life sciences, from computer science. Also the mechanical engineering department is very active in that, and Athletopia from physical sciences. Indicative partnerships with institutions here, you can see supporting entrepreneurships. We collaborate with almost everyone that is active in supporting the ecosystem, and also some indicative partnerships with the industry. Some more information also about our new Center for Entrepreneurship and Innovation, WOC Youth Innovation Accelerator. It's basically an accelerator, as you have probably heard that this term incubator or accelerator, these limits are not easy to define. We call it as an innovation accelerator because it's something bigger than that. It has an acceleration program that accepts applications from startups or potential spin-offs inside the university, and we support them in a 2-month program with master classes and weekly coaching. But we also create entrepreneurship courses across every faculty of the university we try to focus oral activities in these three pillars: education, culture, and community. The education one basically covers the acceleration program and the courses. What we mean by culture is all these activities that try to change and create a new consciousness inside the university, that every member of the academic community, from the student, from the undergraduate student to the postgraduate one, to researchers at every level, has in their minds that we are here not only to be educated or create research, but also to create impact and transfer the technology to society on a business basis. So we try to change this culture, our biggest ambition yet. And through competitions, through meetups between the student teams and the research teams, and also create this community, gather this ecosystem, these skilled and ambitious people in a specific place, physically and digitally. Physically, we have created a new space which you could see as you enter this building on your left. A new modern place for a co-working space, basically, where everyone can come and work and collaborate with the people from this ecosystem. And also digitally, we have created a Discord platform for this goal in mind. And now we are we are currently in the process of accepting applications from students, basically, for the second acceleration cycle. Today, we will launch the second cycle for researchers. We decided to create 2 cohorts in this second acceleration cycle because we believe that we could provide better services to our researchers and students by defining specifically the reason that we are here for researchers, which is the commercialization of their research results, while for the students it's this change of culture and change of way of thinking about entrepreneurship. So we start today with a cohort for researchers, and the next months we will do a separate cohort for students. We also, as you can see, the QR code on the bottom right is for the talent pool, for this matchmaking tool for individual students and researchers. As I said, we have a lot of funding support from different funding opportunities, either nationally from the Ministry of Development and Education, or in a European level from EIT, raw materials, through a project we are coordinating, which is called Accent, and it aims to accelerate innovation and entrepreneurial excellence in higher education institutes. This is our core team of 7 people right now, and we have 2 more teams, as I told you before, the student antenna and the team that supports the operations of WOC. So with that, I would like to thank you very much for the invitation, and you can find us in these contact details. Thank you very much.
Thank you, Mr. Christoveridis, for this nice information. Any question? Also, I noticed that there are many projects in the university. So, university is one of the biggest employers and gives jobs to many researchers.
Yes,
in Greece.
About 7,000 researchers.
How many this time?
Currently.
Currently?
Yeah.
7,000?
Yes. 6,800 something.
And also you have many activities for students. Mm-hmm. Is there a response from students in this?
Of course. Okay, not as much as we would like to, but more than we expected. Mm-hmm. During the first cycle, we received more than 50 applications from student and research teams, which is a pretty big number for such an application, because you need to have a maturity in the team in order to be able to fill an application for an acceleration program. So 51 applications, 35 teams continued in the bootcamp, and then 18 teams worked with us along the first cycle in general, and 15 teams at the end of the program presented during the demo day, as we call it, in front of investors and people from the ecosystem, the innovation ecosystem, basically of the region, but also from Athens. Some people from venture capital funds of the country came to see the teams. So yes, the interest is bigger than we expected, although not big enough regarding our ambitions. That's why we created two separate cohorts, one for researchers now and a separate one for students, in order to be able to serve them in a better way.
Okay, thank you.
Hello. I saw some very interesting data. I saw that the total budget for the last 5 years is about 320 million euros, and this corresponds to, roughly speaking, 7,000 research projects. Am I correct? 6,000
Yes.
something.
Yeah.
If you divide it, is, let's say, 50,000 euros per project. This is a small amount. And do you have the same, you mentioned also that 25% comes from industry.
Yes.
I would be curious enough to see which is the, for this 25%, the average budget for the industrial related projects, because 50,000 euros is a small amount for a project. For researcher?
Yes, yes. Research projects is about
1,000.
1,200.
Yeah, but 50,000 is for 5 years, so it's 10,000 per year.
Yeah, because we count also some smaller projects that are very low budget.
Low budget.
But for sure, the average budget for the research projects and collaboration with industry, I cannot tell you, I cannot give you a number right now. I'm not responsible for
Yeah, it's okay.
That.
It's okay, but you should
But
decrease
for sure,
it.
there are also, in this number, we have some very small projects with a very small budget that we count here. Yeah.
Okay.
Meaning, I don't know how to say it. Yeah, just very small things that are asked by our research teams. You understand? Like about 10,000 or 20,000, this kind of.
Yeah, understood.
Projects.
You should give more impressive numbers in next presentation then. Okay.
Thank you very much.
Okay, thank you. Is there any other question? Okay, thank you.
Thank you.
Sophoulis. And now we go on with our last speaker, Dr. Spiros Kiartzis, from manager of new technologies and alternative energy sources in Hellenic Petroleum, now Hellenic Energy Holdings. And the title of his presentation is Applying Emerging Technologies to Address the Challenges of Energy Transition. Mr. Kiartzis.
Hello. As you can see, we the guys from industry are the bad boys, asking usually tough questions, but anyway, thank you for the invitation. I'd love to present you some issues regarding the future of energy. We are a leading energy group. 1 year ago, our name, and for the last 65 years, was Hellenic Petroleum. It was a pure petroleum industry. We have shifted towards an energy group, and what is really crucial for us is to have a lower carbon footprint. In fact, we are dealing with everything in the energy and mobility sector. As you can see, this is refining, supply and trading, petrochemicals, petrol stations, renewable energy, power and gas, research, upstream. We have more than 60 affiliate companies dealing with, from engineering services up to marine transportation and, of course, petrol stations. This corresponds to 15 billion per year. In fact, the last years we are shifted towards low carbon energy company, investing heavily in renewable energy, in battery energy storage, in hydrogen, in green hydrogen, examining investments in carbon capturing, and of course running our standard business, which is refining, exploration in hydrocarbons, and of course petrochemicals. In all these things, we are trying to survive due to very strict regulations we are facing, and also we are trying to create a new reality and the future of the world in energy. And when I'm saying we are trying to create the future and be part of the future, is not because we are afraid to be extinct like dinosaurs, is because we want to be pioneers in new issues. And for this, for example, we are converting many of our petrol stations into hubs for charging electric vehicles. We are investing and contributing to the huge consumption of electricity we have, which is more than 1 terawatt hour per year, with renewable electricity produced from our photovoltaic parks, from our wind farms, and hopefully in a few years from our offshore wind farms. And we are also heavily investing in research, both research and development, having numerous projects with academia, with other partners in European Union or in the country, in Greece. And let's say more than 15 Horizon projects, many LIFE projects, many projects that we are funding them by ourselves, trying to see what's going on in the future of fuels, of mobility, of whatever. We are facing a lot of challenges. One of them is the standard regulating framework. There is a lot of uncertainty. I can assure you for this because a few years ago we had the RED directive, it's a Renewable Energy Directive, it was RED 1. A few years ago it changed into RED 2. And a few months ago we had RED 2.1, which means that it's an unstable environment which causes a lot of uncertainty, and especially for investors that invest hundreds of millions of euros, this is not the best thing. The reason we are dealing a lot with academia and with research institutes is because we want to find solutions for the future, but we don't find mature technology. There are a lot of good ideas, especially in advanced fuels, in green hydrogen, in carbon capturing, in whatever. We will see some issues we are doing, but technology is in the infancy state in lots of them. Of course, funding and investment risk is something that we take. We are the investors, so this is not the major issue. The major issue is that you don't have good projects. Everything is under pressure. We have to have solutions tomorrow, but unfortunately, we will not have them even in a couple of years from today. I will give you an example later. And of course, raw materials, sustainable raw materials availability is another nightmare. Where we are moving to a huge electrification. We are talking about fleet electrification. We are talking for heavy vehicles, let's say somehow electrification. We need storage. to absorb also the renewable energy that is produced, and to, let's say, handle the fluctuation of the production of this energy. We are going towards renewable fuels that either their origin is either from biomass or what we call e-fuels. They are based on renewable electricity and, of course, green hydrogen. Hydrogen is an energy carrier, it's not a fuel. So if you want to contribute in all this, we need one thing, green electricity. And we need huge quantities of green electricity for this. I have an example later. I will tell you that in our refinery, in LFC is one of our refineries, we are emitting about, to produce hydrogen, about 1.2 million tons of CO2 per year. Well, in fact, if we want to, and this is produced from a steam methane reforming, is you know, the conversion of natural gas, which is methane, is carbon and 4 atoms of hydrogen, to convert them into hydrogen. Well, in fact, this is a gray hydrogen, and a hydrogen that produces 1.2 million tons of CO2 per year. If we want to convert it into green hydrogen, we simply use 1 gigawatt of electrolyzer. And in order to feed this 1 gigawatt of electrolyzer with renewable electricity, you need 3 to 5 times more renewable electricity, depending on if it is wind farm, that is, let's say, a 30% capacity factor wind farm or a 20% photovoltaic. It's 3 to 5 times more. Well, this is a huge game, and if I ask you which is the biggest electrolyzer today in operation in Europe and of course in the world, do you know which is the size of this biggest electrolyzer? 25 megawatts only. And there are some nice plans. I have talked with nice politicians in Brussels saying, but we are planning 100 megawatt electrolyzer. And they'll say, okay, I simply need for one of our refineries 1 gigawatt, which is 1,000 megawatt electrolyzer. And today we have in operation only 25 megawatt, a single unit. You understand? This is not a simple step. It's a huge step towards what we need. All our colleagues in oil and gas industry are now diversifying into low carbon energies. In fact, there are some pioneers like Equinor. Equinor was a Scandinavian oil company, that Statoil, sorry, the Scandinavian, the Norwegian oil company that even changed their name and became Equinor. And they are heavily investing in offshore wind farms, like Ørsted, which is #1 in wind farms today. Donk Energy changed their name. Everyone is changing their name, in fact, because we want to get rid of the black, let's say, related petroleum name. But on the other hand, we are really investing on this. As you can see, renewable electricity, advanced biofuels, e-mobility are the major fields we are now transforming. And that's what we are doing. We are trying to decarbonize our business. As I told you, we are going into green electricity. We are trying to make some optimization to our existing industrial sites, to improve our efficiency, to do some upgrades, to recover whatever we can, and of course capture emissions. And we are not only looking to capture the CO2 that is produced, we are also looking to utilize it and convert it to some new fuels. But if you want to make it, these are e-fuels from electricity, we need huge quantities of renewable electricity. And believe me, because I participate in this nice affiliated company we have, the Hellenic Renewables, as we call it, and we have invested more than €500 million on this the last years, investing on, all these nice things I told you. It's very, very difficult to get licenses and to find appropriate investments on this. This is the example I mentioned before, because green hydrogen, this is the total emissions of the LFC's refinery. One of our refineries is 2.1 million tons, and more than half of them are dedicated for the production of hydrogen. Hydrogen is one of our core processes. We need to convert crude oil into, and generally hydrocarbon, into our products, which is diesel, gasoline, kerosene, and so on. So this is a huge problem. As I told you, we are working on a very, let's say, strong and diversified renewable portfolio of almost 4 gigawatts. And we already nominated a license, not a license, even we earned the subsidy for this, for 100 megawatt battery energy storage system. We want to support our renewables. This is in the refinery we have in Thessaloniki. And recently, last week, the regulating authority nominated also other 150 megawatt of storage. I want to go back to our R&D business, because this is part also of my job, for example, we have, apart from our Horizon projects, we also have some projects related to the scope of this conference. In our refinery, we had an augmented reality project for the maintenance. We had another project that was leakage prediction that we had with Professor Nikolaidis, and generally we are trying to optimize both operations and maintenance we are doing in our refineries and in our industrial complexes in order to minimize our carbon footprint. So generally speaking, we want to be close to academia. We want to participate in R&D projects. We want from our researchers a lot of effort, and also our colleagues from the universities. We have, let's say, an issue. Most of our researchers and our programs, collaboration projects, are producing only papers, which is disappointing. I participate in various projects. I got rid of hundreds of nice projects published in, journals and so on, and in conferences, but what we want is patents. And closing with this, I want to say that industry, Hellenic Energy, and generally the industry is very keen on working with academia, and we want to produce nice things. I see them becoming reality. Thank you. If you have any question, I'm here.
Questions?
Hello. Thank you very much for the nice presentation. You mentioned a lot about reducing the emission of carbon hydrogen. I know that there is also research in the direction of capturing back these emissions. What's your opinion about it? Is it worth investing in this direction?
I think I have already mentioned something about this. I want to elaborate more. Let's say that there are two ways. Either you keep the existing technology that emits carbon dioxide, or you convert it into green hydrogen or whatever is green. This is called CCS, carbon capture and sequestration. Of course, as I told you, the next step is CCUS, carbon capture, utilization and sequestration. It is worthwhile if you have, let's say, the final storage for this. Today, there is technology that we can easily absorb from various points the carbon dioxide that is emitted, and we can convert it into liquid because you have to compress it and make it liquid in order to store it under pressure. There are vessels, sea vessels, that can transport this captured CO2, but the last part of the equation is where you are going to store it. In fact, you need geological storage facilities, which are former oil fields or gas fields or whatever. In Greece, we have only Prinos, which is a depleted oil field. In the Mediterranean basin, we also have Ravenna in Italy, which is also another depleted oil field from ENI, and nothing else. In the northern part, which means outside Scandinavia, in North Sea and so on, because of the former gas fields and oil fields, and outside Netherlands also, there are more alternatives. In the Mediterranean basin, we have only this, which means we need, not us as a companies, but the owners of these either fields, or mainly they belong to the state. These are some assets that goes to the end of their life to the state. You will find them, and they must be willing to invest on them in order to inject all these captured CO2 into these geological storage facilities.
Thank you.
Okay, so what you said about papers and patents, I think is crucial, right? But from a time perspective, when you are on the project, sometimes it's very challenging to have the patent ready by the end of the project. So there is a trade-off, when you do a patent in EU and when you do it only in Greece, let's say, right?
No, if you do it in Greece, it's immediately also in EU countries, in all EU countries.
Okay, so okay, but I thought also that there was, some processing time that takes longer to do like an EU patent rather than doing only a Greek patent. But it's not the case, you say?
No, because we are members of the European Union, and immediately this is for the whole European Union. And you examine it in two phases, but it goes to all European Union.
Okay, the two phases. Okay, good. Thanks.
Other questions?
Thank you very much for your presentation. About patents, just to say that it's better to submit it in Greece because you have a faster date, and the process is the same. Okay. I would like to, you mentioned in your presentation that one of the issues is technological maturity, and I would like to ask you whether or not you have some projects on maturing technologies or some ways to make them go faster in a way.
Look, we participate in various R&D projects at various TRL levels, which means something is more basic and something is closer to become, let's say, in a lab scale or going into a pilot scale and so on. In fact, you start with something, let's say an Horizon project, and you find something that is an interesting idea, you evolve it in a 3 or 4 years time research, and when it finishes, if you see that, of course, it's not mature, And sometimes this time is not enough, in most cases, to go for a pattern, to file an application for a pattern and so on. But the problem is mainly that this is a low TRL. If you go in higher TRL, you can do it in 4 years. If you other 4 years is a huge amount of time. Sometimes we add, if we have a project and we are satisfied with the results, we continue. We don't care about having only funding from European Union or local funding. Or you give more money and you invest money on this in order to mature it. If you see that, for example, I have a paradigm on this. 10 years ago, we started a project. It was with CERT here in Thessaloniki, center of, how it's called, Eketa, by the way, in the Greek name. They are doing some nice research on biofuels. And they presented us a technology converting used cooking oil into biodiesel. We liked this. It was a 3 years project. We funded by ourselves the other 3 years, and then it was mature. And now we have a project about 20 millions constructing a unit in the refinery of Thessaloniki that will utilize all this research into reality. So, of course, it took, you will tell me, Spiro, this took for you 10 years. Yeah, but it started from something very basic, something from scratch. What we want also from the university is not only starting from TRL 3, for example, or TRL 4. We are happy enough, after all these years, having ideas funded from Horizon and the FP7. I had projects from FP7 we participated. But as I told you, I have produced from all these projects, not me, the teams I was working with, more than 100 papers. Don't ask me how many patents. You will be deeply dissatisfied.
Papers means PhD.
The lady over there, I think.
Papers means that some take the PhD.
Some nice guys became full professors from associate professors, but that's part of the game. This is the one side. So.
Thank you very much for your presentation. I wanted to ask whether you are currently working with any startups, because maybe the maturity level or the technology level you're looking for lies there instead of academic research.
Of course, we are trying to do it, and we are examining also participating in a number of startups. And we are also examining generally as a strategy to, but we have not received the final investment decision on this to have a CCV, a corporate venture capital, a CVC, corporate venture capital, in order to go directly for this. In parallel, there are a lot of startups. I think more than one per month is examined with some nice ideas, or coming from as an output from the collaboration we have the universities in Greece. And we also participate in some, the MIT Enterprise Forum, having a lot of startups in order to evaluate them as potential investment. So yes, as I told you, R&D is research and development. Your research is mainly in the universities, development is in the next step, which is close to startups and so on.
Thank you.
Other question? About your collaboration with university, you mentioned only research projects, but because we have a round table after this session discussing this collaboration and the ideas about this collaboration, as I know, you have also some other activities, funding PhDs, funding master thesis.
Yes,
Can you comment? on that?
Well, in fact, this is also basic research because we support some PhD students and also some master level students, postgraduate students generally. It's nice to have this, but again, this is at a low TRL level, unfortunately. Of course, as I told you, we are one of the major energy companies in southeastern part of Europe, and it's our duty to support both the society and also academia in all the countries. We have a footprint in 6 countries, starting from Cyprus in the south, going up to Serbia, or I think Montenegro is above, northern than Serbia, in all this area. And we are trying to support research, we are trying to support universities, we are trying to support research centers, and we are very happy to have to support young engineers and scientists and make them to utilize their dreams. Hopefully, it is, and I can see I see a lot of these young people coming to me, like having the age of my children, that are finishing their studies and they're doing their postgraduate studies, and they are having a lot of dreams. Someone has to support them.
Thank you. I think we have to finish. Yes, thank you again, Dr.
Λοιπόν, καλησπέρα και καλώς ορίσατε σε αυτήν την συνάντηση με το Roundtable με θέμα την σύνδεση της ακαδημίας και της βιομηχανίας. Ένα θέμα το οποίο συζητιέται εδώ και πάρα πολλά χρόνια. Θεωρώ πως έχουν γίνει κάποια βήματα τα τελευταία χρόνια, αλλά μέσα από τη συζήτηση φαντάζομαι θα δούμε τα υπέρ και τα κατά, πού βρισκόμαστε και τι μπορούμε να βελτιώσουμε. Έχουμε εδώ μαζί μας τον κύριο Γιώργο Φλάμη, από την Renaissance εταιρεία. Καλησπέρα κύριε Φλάμη. Τον κύριο Τηλέμαχο Ματιάκη από την εταιρεία Kenotom. Καλησπέρα. Τον καθηγητή κύριο Στέλιο Σίσκο από το Αριστοτέλειο Πανεπιστήμιο, το Τμήμα Φυσικής. Καλησπέρα κύριε Σίσκο. Τον κύριο Γιώργο Σαββίδη, ο οποίος και αυτός είναι στην βιομηχανία, είναι στην εταιρεία Kenotom, αλλά είναι και πρόσφατα απόφοιτος του τμήματός μας. Καλησπέρα κύριε Σαββίδη. Και έχουμε και τον κύριο Μάριο Κιάτο, ο οποίος είναι από την εταιρεία Progressive Robotics και αυτός πρόσφατα, νομίζω, αποφοίτησε από το τμήμα.
Το διδακτορικό.
Το διδακτορικό, μάλιστα. Πάρα πολύ ωραία. Λοιπόν, επομένως, να ξεκινήσουμε λίγο με την θεματολογία η οποία θα μπορούσε να φανεί χρήσιμη σαν να βγάλει κάποια συμπεράσματα. Καταρχήν θα ήθελα μια σύντομη τοποθέτηση από τα μέλη του πάνελ σχετικά με την κατάσταση που βλέπετε να υπάρχει σήμερα. Δηλαδή πώς αξιολογείτε, πώς βλέπετε τα θετικά και τα αρνητικά της υπάρχουσας κατάστασης όσον αφορά τη συνεργασία της βιομηχανίας με την Ακαδημία σήμερα. Πώς είναι η κατάσταση, τι βλέπετε?
Καλησπέρα σε όλους και από μένα. Είναι ένα πολύ σοβαρό θέμα γιατί και σίγουρα είναι μια αμφίδρομη συνθήκη. Εννοώ με αυτό ότι από τη μία μεριά η Ακαδημία μπορεί να προσφέρει στη βιομηχανία, αλλά μπορεί να συμβαίνει και το αντίθετο. Οπότε, σε αυτές τις δύο διαδρομές είναι πολύ σημαντικό να τοποθετούμαστε με έναν τρόπο ο οποίος μπορεί να γίνει κατά το δυνατόν αποδοτικότερος, δίνοντας τόσο το ενδιαφέρον από τη βιομηχανία προς την Ακαδημία στα θέματα τα οποία μας απασχολούν και πολλές φορές αυτός ξεφεύγει από το κομμάτι της γενίκευσης στην τεχνολογία ή στην έρευνα και γίνεται πιο συγκεκριμένο στο τα τμήματα τα οποία είναι κοντά, είναι στο ίδιο χώρο, στο ίδιο γεωγραφικό χώρο, μπορούν να προσφέρουν και να συνεργαστούν. Έχω πολλά παραδείγματα να φέρω και να σας πω για τέτοιου τύπου συνεργασίες, σαν αυτές που έχω κάνει εγώ και η εταιρεία που δουλεύω με τα τοπικά πανεπιστήμια. Ωστόσο, είναι ιδιαίτερα σημαντικό να ενθαρρύνουμε και το αντίθετο κομμάτι μας. Διαφέρει πάρα πολύ, δηλαδή να πάρουμε τις ιδέες, να πάρουμε τους ίδιους φοιτητές να μπορέσουν να σταθούν σωστά στον χώρο τον οποίο βρισκόμαστε και από εκεί και πέρα να μπορέσουν και οι ίδιοι να αναπτύξουν την καριέρα τους εφόσον τους ενδιαφέρει προφανώς ο συγκεκριμένος τομέα με τον οποίο η εταιρεία που εργάζομαι εγώ ασχολείται, να προχωρήσουν και να κάνουν κάτι καλύτερο για την πορεία τους. Αυτά προς το παρόν.
Και κατά τη δικιά μου την άποψη, προφανώς υπάρχουν και πράγματα που μπορούν να βελτιωθούν στη συνεργασία Πανεπιστημίου-Βιομηχανίας. Κάποια από αυτά αναφέρθηκαν ήδη και στο προηγούμενο ομιλία του κυρίου Κιαρτζή. Αλλά σε αυτή την πρώτη ερώτηση, εγώ θα ήθελα απλά να αφήσω ένα θετικό πρόσημο. Δηλαδή, αν ρωτάτε εμένα και όσον αφορά την καινοτομία σύνδεση Πανεπιστημίου Βιομηχανίας είναι θετική, σίγουρα είναι θετική. Δηλαδή, από την άποψη ότι τα άτομα που βγαίνουν από το Πανεπιστήμιο είναι πολύ ικανά και αρκετά έτοιμα να αναλάβουν κάποιες θέσεις σε μια εταιρεία, να γίνουν παραγωγικά μέλη ενός project. Είναι ο βασικός λόγος που εμάς μας έχει βοηθήσει και έχουμε καταφέρει να αναπτυχθούμε τα τελευταία χρόνια και να φτάσουμε εδώ πέρα. Αν δεν ήταν το Πανεπιστήμιο και η εκπαίδευση και οι φοιτητές, το επίπεδο των φοιτητών που βγαίνουν από το Πανεπιστήμιο, δεν θα τα είχαμε καταφέρει κι εμείς. Φυσικά, σε διαφόρους τομείς υπάρχει σημαντικός χώρος για βελτίωση.
Καλησπέρα σας και από μένα. Θεωρώ ότι τα τελευταία 15 χρόνια το Πανεπιστήμιο με την βιομηχανία έχει κάνει αρκετές συνεργασίες, έχουν γίνει άλματα θα έλεγα, γιατί μέχρι θα έλεγα και το 2005 μάλλον δεν υπήρχε ιδιαίτερη συνεργασία. Με τα project του Κοράλια, θα σας θυμίσω, οι περισσότερες εταιρείες και τα περισσότερα πανεπιστήμια ξεκίνησαν μία συνεργασία η οποία αποδείχθηκε πολύ χρήσιμη για πέρα από το ότι έγιναν βγήκαν κάποια αποτελέσματα, πιθανόν έγιναν κάποια προϊόντα, αλλά το κυριότερο ήταν ότι ήρθαμε σε επαφή, γνωριστήκαμε, καταλάβαμε ο ένας τον άλλον σε ένα βαθμό, γιατί δεν θεωρώ ότι αυτό έχει γίνει στο 100%. Και καταφέραμε επίσης να πείσουμε τους φοιτητές μας να ακούνε διαλέξεις από εταιρείες που ερχόντουσαν στο μεταπτυχιακό κυρίως και να μπορούν να έχουν μία επαφή και μέσα από τα project, άνθρωποι που δούλεψαν τότε στα project γιατί ήταν μεγάλα και με αρκετή χρηματοδότηση, προσλήφθηκαν στις διάφορες εταιρείες. Αυτό ήταν πάρα πολύ χρήσιμο, ήταν μια πολύ καλή αρχή, συνεχίστηκε στα μετέπειτα χρόνια, συνεχίζεται και σήμερα και νομίζω ότι οι φοιτητές μας είναι αρκετά καταρτισμένοι ώστε να μπορούν να προσφέρουν όχι άμεσα αλλά αρκετά γρήγορα στην πρόοδο της εταιρείας. Για την ώρα αυτά από μένα και έχουμε να πούμε και άλλα μετά.
Χαίρετε. Αρχικά να πω ευχαριστώ πολύ για την πρόσκληση. Ίσως σε αυτό το πάνελ είμαι ο νεότερος, οπότε δεν έχω να πω τόσα πράγματα εκ πείρας, αλλά εγώ θα ήθελα να το πάω και ένα βήμα παραπάνω. Δηλαδή, πέρα από την συνεργασία της βιομηχανίας με την ακαδημαϊκή κοινότητα μέσω διπλωματικών ή πρακτικών εργασιών ή να καταφέρνει η ακαδημαϊκή κοινότητα να πηγαίνει τους φοιτητές σε καλύτερο επίπεδο έτσι ώστε να μπορούν να είναι πιο έτοιμοι για τις θέσεις εργασίας τους. Εγώ αυτό που ήθελα να θέσω επίσης είναι να προσπαθεί η ακαδημαϊκή κοινότητα αλλά και οι εταιρείες μέσω χρηματοδοτήσεων πιθανώς να δίνουν ναύσματα στην Ακαδημία, έτσι ώστε να δημιουργεί κάποιο ακαδημαϊκό ερευνητικό έργο, το οποίο θα μπορούσε να μετουσιωθεί ουσιαστικά στο μέλλον σε κάποιο προϊόν ή κάποια τεχνογνωσία, που να μπορούσαμε να την κάνουμε και σε δεύτερο βαθμό, είτε να αφομοιωθεί στο ίδιο υπάρχον οικοσύστημα επιχειρήσεων, όπως τέτοιων που είναι εδώ οι κύριοι, είτε να δημιουργηθούν και νέες εταιρείες, startups και spin-offs του πανεπιστημίου, που ουσιαστικά θα δώσουν και ένα μεγαλύτερο diversity, μια μεγαλύτερη αγορά στο ποια είναι η Θεσσαλονίκη. Και νομίζω ότι αυτό μπορεί και σε αυτό μπορεί να βοηθήσει και η παρουσίαση που έκανε και πριν ο Βίρονας σε σχέση με το walkout των νέων incubator του Πανεπιστημίου. Αυτά είχα να πω εγώ.
Καλησπέρα και από μένα. Ευχαριστώ πολύ για την πρόσκληση. Και εγώ είμαι αρκετά νέος. Με καλύψανε οι προηγούμενοι που μιλήσανε. Αυτό που έχω να πω εγώ είναι ότι προέρχομαι από τον ερευνητικό τομέα και αυτό που παρατηρήσαμε εμείς που ασχοληθήκαμε αρκετά με την έρευνα είναι ότι υπάρχει ένα μεγάλο κενό μεταξύ της έρευνας και της βιομηχανίας. Και κάπου εκεί πρέπει να δουλέψουμε όλοι μαζί και οι ερευνητικοί φορείς και οι βιομηχανίες για να μπορέσουμε κάπως να φτάσουμε να καλύψουμε αυτό το κενό και να φτάσουμε σε ένα επίπεδο συνεργασίας πολύ καλύτερο. Γιατί στα πανεπιστήμια γίνονται πολύ καλές ερευνητικές δουλειές, αλλά σε ένα πολύ χαμηλό TRL επίπεδο, όπως είπε πριν και ο κύριος Κερτζής. Αυτό πρέπει με κάποιο τρόπο, οι ερευνητικές δουλειές μένουν μέσα στα εργαστήρια, δεν προχωράνε. Αυτό βλέπω εγώ σαν ένα πρόβλημα, το οποίο ναι, με τον τελευταίο καιρό αρχίζει σιγά σιγά να εξαλείφεται. Εμείς είμαστε μια spin-off από το Πανεπιστήμιο και αυτό ήταν ο κυριότερος λόγος ο οποίος έγινε η ίδρυση της εταιρείας μας, γιατί κάναμε έρευνα, έμεινε η έρευνα στο Πανεπιστήμιο και λέγαμε γιατί να μείνει στο Πανεπιστήμιο και να μην πάμε προς τα έξω, να βοηθήσουμε, να έχουμε ένα αντίκτυπο. Αλλά σίγουρα αποκτάμε πολλές δεξιότητες κατά τη διάρκεια της έρευνας και σίγουρα μπορούμε να βοηθήσουμε εταιρείες όπως η Kenotom που μίλησαν πριν και σίγουρα σίγουρα βοηθάει η έρευνα. Αυτό από μένα.
Ωραία, σας ευχαριστώ πάρα πολύ και παίρνοντας αφορμή από τις απαντήσεις που ακούστηκαν, είναι το επόμενο θέμα. Δηλαδή, πώς θα μπορούσαν να βελτιωθούν αυτές οι σχέσεις μεταξύ ακαδημίας και εταιριών, είτε σαν θεσμικά, δηλαδή τι θα μπορούσε να βελτιωθεί στο θεσμικό πλαίσιο της συνεργασίας εταιριών και πανεπιστημίου, ή και παραπέρα με εργαλεία εκπαιδευτικά, αυτό που ακούστηκε για πρακτική άσκηση, αυτό που ακούστηκε για χρηματοδότηση διδακτορικών. Ποιες είναι οι σκέψεις που κάνετε σχετικά με το πώς θα μπορέσουμε να τονώσουμε, να βελτιώσουμε αυτό που ξεκίνησε, όπως είπε ο κύριος Σίσκος, πριν από 15 χρόνια, να το τονώσουμε, να το πάμε σε καλύτερο επίπεδο.
Πολύ ωραία. Να συμφωνήσω κι εγώ, το άκουσα από κάποιους ομιλητές, ότι πράγματι οι σχέσεις είναι βελτιωμένες. Και είναι βελτιωμένες και στο επίπεδο των δυνατοτήτων που δίνονται, αλλά και στο επίπεδο της αποδοχής της πιθανής συνεργασίας ανάμεσα σε πανεπιστήμια και βιομηχανία. Δηλαδή πλέον θέλω να πω ότι έχει σταματήσει να υπάρχει μια αγκαθωτή απόσταση ανάμεσα στους δύο τομείς και κυρίως πλέον όλοι βλέπουμε τα κοινά και τα ωφέλη τα οποία υπάρχουν σε αυτό. Αυτό που θα πρότεινα και νομίζω πως είναι και αυτό το οποίο εμείς βρίσκουμε ως πιο σημαντικό είναι ως ενδιάμεσο τομέα την εφαρμοσμένη έρευνα. Είναι ένας όρος ο οποίος χρησιμοποιείται σε πολλές περιπτώσεις, αλλά στην πράξη είναι αυτό το οποίο κάνει την διαφοροποίηση σχετικά με το από πού ή πώς μπορούμε να δημιουργήσουμε δημοσιεύσεις οι οποίες απλά μας προσφέρουν ένα τίτλο και πώς από εκεί και πέρα αυτές τις δουλειές, αυτή την εργασία μπορούμε να την εμφανίσουμε ως εφαρμοσμένη, εφαρμόσιμη δηλαδή, σε κάτι το οποίο μπορεί και η βιομηχανία να ξεκινήσει. Και όπως η τεχνολογία αυξάνεται και μεγαλώνει και η γνώση μεγαλώνει, αντίστοιχα έτσι υπάρχουν και πάρα πολλοί τομείς οι οποίοι πλέον γίνονται δεδαλώδεις, με αποτέλεσμα πολλές φορές και εμείς οι ίδιοι να χανόμαστε. Δηλαδή δεν έχουμε πλήρη άποψη και εικόνα του ότι μία ιδέα ή μία τοποθέτηση μπορεί πραγματικά να είναι εφαρμόσιμη. Άρα η άποψή μου είναι ότι θα πρέπει να πλησιάζουμε με κάποιο τρόπο την βιομηχανία μέσα από την εφαρμοσμένη έρευνα και με τον οποιοδήποτε τρόπο να μπορούμε να αποδεικνύουμε ότι τα αποτελέσματα σε ένα βαθμό μπορούν πρακτικά να εφαρμοστούν. Ευχαριστώ προς το παρόν.
Εγώ θα είχα να προτείνω δύο πράγματα. Πρώτον απ' όλα, όσον αφορά το πλαίσιο, μπορούμε φυσικά να βελτιώσουμε το πλαίσιο, αλλά θεωρώ ότι αυτό που πρώτα απ' όλα πρέπει να βελτιωθεί είναι η εφαρμογή του πλαισίου. Τα ερευνό καινοτομό, για παράδειγμα, τα προγράμματα είναι πολύ ωραία για τη συνεργασία πανεπιστημίου, αλλά όταν έχουν 1, 2, 3 και χρόνια καθυστέρηση, όταν έχουν τόσο πολύ γραφειοκρατία, τελικά δεν μπορούν να λειτουργήσουν στην πράξη ουσιαστικά και να φέρουν τις εταιρείες κοντά στα πανεπιστήμια. Δεν μπορεί να βασιστεί δηλαδή η βασική έρευνα μιας εταιρείας σε μια χρηματοδότηση που δεν ξέρεις άμα θα σου έρθει φέτος ή μετά από 3 χρόνια. Οπότε τελικά καταλήγει να γίνεται περισσότερο δουλειά των πανεπιστημίων ανεξάρτητα μέσα από αυτά τα προγράμματα παρά των εταιριών. Το δεύτερο, που τουλάχιστον κοιτώντας λίγο και τους εαυτούς μας τι θα μπορούσαμε εμείς να βελτιώσουμε, αλλά νομίζω αφορά γενικότερα και τις εταιρείες στην Ελλάδα, είναι να γίνουμε και εμείς λίγο πιο research oriented, να αποφασίσουμε ότι πρέπει να επενδύσουμε περισσότερο στο R&D και να μην περιμένουμε να φτάσουμε να βρούμε έτοιμο ένα μεγάλο επίπεδο ωριμότητας από κάποια startup ή από κάποιο πρόγραμμα που θα το πάρουμε και με μεγάλη σιγουριά θα το φτάσουμε σε ένα προϊόν, αλλά να είμαστε έτοιμοι να ξεκινήσουμε και από χαμηλότερα επίπεδα ωριμότητας, να επενδύσουμε και φυσικά, αφού το κάνουμε αυτό, να είμαστε έτοιμοι και να αποτύχουμε σε κάποια από αυτά.
Θα συμφωνήσω με τον κύριο Ματιάκης. Σωστά. Ότι οι εταιρείες πράγματι δεν έχουν R&D, σοβαρά R&D τμήματα. Οι περισσότερες, γιατί είναι μικρές στην Ελλάδα, ζητάνε πολύ γρήγορα να έχουν προσωπικό από τα πανεπιστήμια το οποίο να είναι έτοιμο να παράγει. Αυτό είναι δύσκολο και εφόσον δεν έχουν τμήματα έρευνας, δεν μπορούμε να έχουμε μία πολύ καλή αλληλεπίδραση εμείς ως ερευνητές στα πανεπιστήμια με τις εταιρείες και σοβαρή συνεργασία σε αυτό το θέμα. Πράγματι, στα ερευνό καινοτομό το βλέπουμε αυτό το πρόβλημα, ας πούμε, το είδαμε αυτό το πρόβλημα. Γίνεται μία συνεργασία, αλλά δεν είναι αυτή που θα έπρεπε. Για να γίνει μια τέτοια συνεργασία, χρειάζεται σε ένα τέτοιο πρόγραμμα ερευνό καινοτομό, χρειάζεται τουλάχιστον ένας ερευνητής να είναι για αυτό το πράγμα και χρειάζεται σίγουρα και κάποιον από πίσω να υποστηρίζει γραφειοκρατικά αυτή τη δραστηριότητα, γιατί η γραφειοκρατία στα project είναι τεράστια. Από εκεί και πέρα, η εταιρεία, το πανεπιστήμιο προσπαθεί να παράγει καινούργιες ιδέες, γιατί υπάρχει και ένας στόχος να βγάλουμε δημοσιεύσεις, να παράγουμε καινούργια γνώση που χρειάζεται, γιατί διαφορετικά δεν θα πήγαινε τίποτε μπροστά. Και οι εταιρείες, εξαιτίας του ότι είναι και μικρές, προσπαθούν να βγάλουν όσο πιο γρήγορα ένα προϊόν για να προλάβουν την αγορά, να προλάβουν να το πουλήσουν. Οπότε δεν είναι εύκολη η συνεργασία, γιατί ειδικά με τα πανεπιστήμια, δεν λέω για το ΕΚΕΤΑ που είναι ερευνητικό κέντρο ή πιθανόν το Δημόκριτο, ειδικά στα πανεπιστήμια ένας καθηγητής έχει διδακτικό έργο, έχει διοικητικό έργο και το κυριότερο μετά έχει και από άψη χρόνου το κυριότερο για μένα είναι το διδακτικό έργο, το ερευνητικό έργο, το οποίο αν δεν το κάνεις δεν υποστηρίζει και καλά τη διδασκαλία σου σε βάθος χρόνου. Οπότε δεν μπορεί να θέλουν, παραδείγματος χάρη το ερευνό καινοτομό, λέει θα βγάλετε ένα προϊόν. Δεν γίνεται αυτό εάν η εταιρεία δεν βάλει πολύ κόπο σε αυτή τη δραστηριότητα. Δεν γίνεται. Το πανεπιστήμιο μπορεί να φτάσει σε ένα TRL, ξέρω εγώ, 4, 5, πόσο να πω. Δεν μπορεί να φτάσει στο 7, στο 8, στο 9, να βγει ένα προϊόν στην αγορά. Και το πρόβλημα είναι αυτό, ότι αυτά που λέγαμε σε ένα project συγκεκριμένο τώρα που τελείωσε, πέρσι τελείωσε, το 2017, το 2019 ήταν στο εμπόριο. Δεν προλάβαμε, ενώ κάναμε τη δουλειά, ήδη είχε βγει όμως αντίστοιχο τσιπάκι στο εμπόριο. Δεν προλαβαίνεις δηλαδή. Η κυβέρνηση ναι μεν πρέπει να βοηθάει εταιρείες και πανεπιστήμια να συνεργάζονται, αλλά δεν προλαβαίνεις. Νομίζω ότι για να μπορέσουμε να συνεργαστούμε καλύτερα θα πρέπει κυριολεκτικά να το σκεφτούν καλά οι εταιρείες και να έχουν κάποιο ερευνητικό τμήμα έστω και μικρό. Αυτά είναι από μένα για την ώρα.
Εγώ, για να είμαι ειλικρινής, δεν έχω τόσο πολλή εμπειρία σχετικά με προγράμματα. Επίσης, έκανα και ήδη μια πρόταση. Αυτό που ίσως έχω παραπάνω να πω είναι ότι, τουλάχιστον προσωπική εμπειρία, μιας και σπούδασα στο Πολυτεχνείο, κάποια στιγμή προς το τέλος σπουδών μου ήθελα κάπου όλη αυτή τη γνώση που είχα πάρει, κάπως να τη χρησιμοποιήσω άμεσα, έτσι ώστε να δημιουργήσω κάτι. Τώρα για αυτό το πράγμα, εγώ θεωρώ ότι υπάρχουν κάποιες φοιτητικές ομάδες, κάποια ερευνητικά εργαστήρια ή και μόνος σου μπορείς να κάνεις κάποια έρευνα, αλλά θεωρώ ότι θα μπορούσε να γίνει και σε μεγαλύτερο βαθμό. Ίσως η λύση που εγώ θα έδινα στο πώς η έρευνα θα μπορούσε να είναι χρήσιμη για την βιομηχανία της Θεσσαλονίκης, ας μιλήσουμε συγκεκριμένα, είναι η ίδια βιομηχανία της Θεσσαλονίκης να έρθει στο πανεπιστήμιο και να πει «εγώ θα ήθελα αυτή τη διπλωματική, αν θεωρείτε πως το εργαστήριό σας θα ήταν χρήσιμη» ή «εγώ σκέφτομαι να δουλέψω προς αυτή την κατεύθυνση, θεωρείτε ότι θα μπορούσαμε να συνδυάσουμε τα δύο, το επιχειρησιακό κομμάτι με το ερευνητικό αντικείμενο, έτσι ώστε να παράξουμε ως ένα βαθμό κάτι». Οπότε νομίζω αυτό είναι κάτι που εγώ σκέφτομαι. Αυτά.
Από τη δική μου εμπειρία, όπως φαίνεται, ο μοναδικός τρόπος το τελευταίο καιρό είναι τα ερευνό καινοτομό και όπως είπα και πριν από μένα, σίγουρα δεν δουλεύουν πολύ καλά. Αλλά κρατάω κάτι, και εμείς σαν spin-off έχουμε στο DNA μας την έρευνα, και κρατάω κάτι που είπε ο Τηλέμαχος πριν, ότι πρέπει να επενδύσουμε στην έρευνα και πρέπει να είμαστε διατεθειμένοι να αποτύχουμε. Αυτό ήταν πάρα πολύ ωραίο. Έτσι θα πάμε μπροστά. Οπότε πρέπει να μπορούμε να κάνουμε πράγματα προς αυτή την κατεύθυνση και με κόπο, με αποτυχίες, εν τέλει θα πετύχουμε και θα βελτιώσουμε και το προϊόν μας και το προϊόντα μεγαλύτερων εταιριών. Σίγουρα όχι μικρές εταιρείες όπως είμαστε εμείς στην αρχή, αλλά αυτό το κυριότερο. Σίγουρα υπάρχουν και άλλοι τρόποι, μέσα από διπλωματικές, από internships, αλλά αυτά είναι μικρά κομμάτια, τα οποία δεν νομίζω ότι θα βελτιώσουν τόσο πολύ τη συνεργασία. Πρέπει να γίνει κάτι πιο 38. Αυτό.
Πολύ ωραία, σας ευχαριστώ πολύ. Και θα ήθελα τώρα να ξεκινήσω με την αντίστροφη σειρά των απαντήσεων, θέτοντας ένα θέμα όσον αφορά την προετοιμασία των αποφύτων, των φοιτητών, στον ακαδημαϊκό χώρο. Πόσο νιώθετε εσείς ως πρόσφατοι αποφοιτήσαντες και οι συνάδελφοι εδώ από τον επαγγελματικό χώρο ή ο κύριος Σίσκος, πόσο νομίζετε ότι αυτή τη στιγμή, έτσι πως είναι οργανωμένες οι σπουδές, βοηθούν τον φοιτητή να αποκτήσει επαγγελματική συνείδηση, δηλαδή να βρει το δρόμο του, αυτά που είπε και νωρίτερα η κυρία Παπακώτα, πόσο τον βοηθάει το πλαίσιο των σπουδών, αν δεν πάει στο γραφείο διασύνδεσης, να βρει το δρόμο του.
Νομίζω ότι αυτό που αποκτάμε περισσότερο στο πανεπιστήμιο, αποκτάμε πολύ καλές δεξιότητες, πολλές γνώσεις, αλλά υπάρχει ένα κενό όσον αφορά το τι θέλουμε να κάνουμε και πόσο έτοιμοι είμαστε να προσφέρουμε. Δεν είμαστε 100% πιστεύω έτοιμοι να προσφέρουμε. Έχουμε πολλές γνώσεις, πολλές δεξιότητες, αλλά θέλουμε το χρόνο, θέλουμε μια καλύτερη διασύνδεση με την βιομηχανία, ίσως περισσότερες πρακτικές, ίσως περισσότερα ερευνητικά, τα οποία να έχουν όντως πρακτική σημασία. Έχουμε πολλές γνώσεις. Αυτές οι γνώσεις νομίζω ότι πρέπει κάπως να βρουν εφαρμογή και πραγματικό αντίκτυπο. Άρα νομίζω ότι υπάρχει ένα κενό εκεί πέρα και προς τα εκεί θα έπρεπε να δουλέψουμε.
Συμφωνώ με τον κύριο Κιάτο και σε αυτό, αυτό που έχω παρατηρήσει προσωπικά τουλάχιστον, είναι ότι οι περισσότεροι απόφοιτοι, βασικά εγώ είμαι απόφοιτος του τμήματος ηλεκτρολόγων, οπότε θα μιλήσω κυρίως για αυτό το κομμάτι, οπότε για ανθρώπους που έχουν είτε αποφοιτήσει από το Πολυτεχνείο είτε από πιο θετικές σχολές. Οι περισσότεροι απόφοιτοι έχουν πολλές φορές στο νου τους ότι πρέπει να γίνουν οι καλύτεροι στο αντικείμενό τους, να βρουν κάτι το απίστευτο, το ένα βήμα παραπάνω που θα το καταφέρουν μόνοι τους με την προσωπική τους δουλειά. Αλλά νομίζω στην πράξη, στο τέλος της ημέρας, στην αγορά εργασίας και στην πραγματική ζωή είναι πολύ σημαντικό σε πρώτη φάση να μάθεις να συνεργάζεσαι και είναι κάτι που το πανεπιστήμιο θεωρώ ότι θα μπορούσε να το προωθήσει περισσότερο, δηλαδή τη συνεργασία μεταξύ φοιτητών, είτε σε μικρές ομάδες στα πλαίσια ενός μαθήματος, είτε και σε κάτι μεγαλύτερο για ένα πιο μεγάλο στόχο. Οπότε να μάθουμε να επικοινωνούμε μεταξύ μας, να βρίσκουμε ο ένας τα όρια του άλλου και να καταφέρουμε τέλος πάντων στο τέλος της ημέρας να συνεννοούμαστε και να πετυχαίνουμε ένα κοινό στόχο. Αυτό είναι το ένα. Και το δεύτερο κομμάτι είναι ότι πολλοί άνθρωποι θεωρώ πως δεν βλέπουν πως στο τέλος της ημέρας στην αγορά εργασίας μιλάμε για επιχειρήσεις. Οπότε μιλάμε για κόστος, χρόνο, κέρδος, κεφάλαιο, τέτοια πράγματα. Κάτι τέτοιο δεν υπάρχει στο πανεπιστήμιο και κατά μία έννοια καλό είναι, γιατί πρέπει να γίνεται έρευνα και πρέπει να γίνεται και έρευνα για να το πάμε παραπάνω, αλλά στο τέλος της ημέρας θα προσπαθήσουμε και αυτή η έρευνα να γίνει έμπρακτη, οπότε να μπει και στο μυαλό του καθενός ότι πώς αυτό που κάνω την επόμενη μέρα, όταν φύγω από εδώ, θα μπορούσα να το χρησιμοποιήσω για εμένα ή θα μπορούσε να φανεί χρήσιμο στην κοινωνία ή στην αγορά εργασίας. Αυτά από μένα.
Για να πιαστώ από αυτό το τελευταίο, θεωρώ ότι ένας μηχανικός διδάσκεται λίγο πολύ τι σημαίνει χρόνος παράδοσης και τι σημαίνει κόστος. Εμείς στο φυσικό, στο μεταπτυχιακό, προσπαθούμε να το μεταδώσουμε αυτό στους φοιτητές μας, γιατί οι φυσικοί καθαροί δεν μπορούν να το αντιληφθούν ιδιαίτερα, οι θεωρητικοί δεν το συζητάω. Δεν τους ενδιαφέρει ο χρόνος. Δεδομένου ότι είναι πρακτική η δουλειά των ηλεκτρονικών, χρειάζεται να ξέρεις ότι πρέπει να παραδώσεις γρήγορα κλπ. Τώρα, η συνεργασία με την βιομηχανία, η εμπειρία που έχω 30 χρόνια πριν με τη Γαλλία, είναι ότι υπήρχαν χρηματοδοτούμενα διδακτορικά και σήμερα ο νόμος το επιτρέπει. Μέχρι λίγο πριν δεν υπήρχε αυτό, τα οποία είναι industrial PhDs. Οπότε χρηματοδοτούνταν από τη βιομηχανία και ο φοιτητής ήταν 3 μέρες στο εργαστήριο και έκανε τη δουλειά του και 2 μέρες στη βιομηχανία. Βέβαια τώρα στη Θεσσαλονίκη δεν έχουμε τόσο πολλές εταιρείες, αλλά στην Αθήνα, ας πούμε, παραδείγματος χάρη, έχει πολλές εταιρείες, θα μπορούσε να είναι ευκολότερο. Με αυτόν τον τρόπο η εταιρεία γνώριζε τον φοιτητή, έβλεπε πώς πηγαίνει. Προφανώς υπήρχε κάποια ομάδα που έκανε έρευνα και καθοδηγούσε τον φοιτητή και μπορούσε να αποδώσει. Το ίδιο πράγμα το είδαμε, αν θυμάσαι, στην Κρενόμπλ με τον Λευτέρη, τότε τον Ιωαννίδη, ας πούμε, που δούλευε στην ST Microelectronics. Θέλω να πω δηλαδή ότι δεν κατηγορώ την βιομηχανία, την ελληνική. Καταλαβαίνω ότι είναι μικρές εταιρείες, πιθανόν δεν μπορούν να επενδύσουν χρήματα πολλά σε μια τέτοια διαδικασία, αλλά δεν γίνεται να θέλουν και προσωπικό το οποίο να είναι έτοιμο να καταλαβαίνει το πώς λειτουργεί μια εταιρεία, το πώς συνεργάζεσαι σε μια εταιρεία και το πώς συμπεριφέρεσαι, γιατί είναι σημαντικό, υπόθηκε κιόλας, χωρίς να έχει μπει ο φοιτητής μες στην εταιρεία. Πέρσι που πήγαμε πάλι Γαλλία στο Πολυτεχνείο, μας είπαν ότι ο φοιτητής είναι υποχρεωμένος 2 καλοκαίρια να πάει και να δουλέψει internship σε εταιρείες μέσα. Οπότε είναι έτοιμος, τον ξέρουν, τον έχουν δει και είναι έτοιμος να δουλέψει. Και έχει δει και αυτός, αν του αρέσει αυτή η δουλειά που πάει να κάνει η τάδε εταιρεία. Θα πρέπει κάπως και εδώ να δημιουργηθεί αυτό το κλίμα. Εμείς προσπαθούμε να δώσουμε και γνώσεις όσο το δυνατόν περισσότερες, και αυτό που θέλω να πω στους φοιτητές, ακόμη μια φορά το λέμε και το ξαναλέμε, είναι ότι τώρα έχετε άπλετο χρόνο για να μπορέσετε να πάρετε γνώση, να διαβάσετε. Στις εταιρείες θα πάρετε εμπειρία, αλλά διάβασμα δεν θα έχετε χρόνο να κάνετε ιδιαίτερο. Επομένως, τις βασικές γνώσεις πρέπει να τις έχετε και να είναι πολύ στέρεες φεύγοντας από το πανεπιστήμιο, είτε για τους ηλεκτρολόγους μηχανικούς, είτε για τους δικούς μας μεταπτυχιακούς φοιτητές.
Θα συμφωνήσω και εγώ με τους κυρίους. Θεωρώ ότι υπάρχει ένα κενό στο mentality που, εντάξει, ειδικά θα το τοποθετούσα στο θέμα των διαδικασιών. Δηλαδή, στο πανεπιστήμιο μαθαίνεις να λύνεις ένα πρόβλημα γρήγορα και να πας στο επόμενο. Εμείς αυτό που πρέπει να κάνουμε πολλές φορές είναι μία λύση που ενδεχομένως υπάρχει ήδη σε ένα επίπεδο ωριμότητας, να δουλέψουμε πολλά χρόνια και μεθοδικά εκεί πάνω, με πολύ verification, με πολύ testing, με πολλές διαδικασίες για να μπορέσουμε να την κάνουμε τόσο ώριμη ώστε να βγει στην αγορά. Θα ήθελα απλά να αναφέρω ότι βλέπουμε ότι υπάρχει μεγάλη διαφορά όντως ανάμεσα στους φοιτητές που δεν έχουν συμμετάσχει στις ομάδες που αναπτύσσουν κάτι εντός του πανεπιστημίου, όπως είναι η Φόρμουλα 1, όπως είναι η SpaceDot, που είναι και project manager ο Γιώργος Σαββίδης που κάθεται εδώ δίπλα μας. Τα άτομα που έχουν περάσει από αυτές τις ομάδες σίγουρα είναι πολύ πιο κοντά σε αυτό το mentality, σε αυτό που χρειαζόμαστε εμείς σαν εταιρεία. Και ενδεχομένως αυτές οι φοιτητικές ομάδες ίσως πρέπει μέσα από ένα πλαίσιο να ενσωματωθούν περισσότερο μέσα στο πανεπιστήμιο. Αυτή τη στιγμή, αν καταλαβαίνω καλά, λειτουργούν κατά βάση από πρωτοβουλίες των φοιτητών που από τις φιλοδοξίες τους κάθονται κάτω, δουλεύουν έξτρα ώρες πέρα από τα μαθήματα και πέρα από ό,τι χρειάζεται να κάνουν για να φτιάξουν κάτι τέτοιο.
Υπέροχα. Εγώ να πω ότι στο κοινό βλέπω συναδέλφους μου, όλοι ήμασταν πρώοι φοιτητές, τους οποίους έχω συναντήσει στην αρχή της καριέρας τους ως φοιτητές και χαίρομαι πάρα πολύ που τελικά είναι μαζί μας. Και τόσο σε επίπεδο ερευνητικό έχουν κάνει σπουδαίο έργο, αλλά και ως φοιτητές έχουν δείξει το ενδιαφέρον στη συνεργασία, στην εργατικότητα και στην δυνατότητα να μπορούν να ληχθούν και να κινηθούν σε ένα εταιρικό περιβάλλον. Και τι θέλω να πω με αυτό? Θέλω να πω ότι κατά την άποψή μου δεν μπορούμε να περιμένουμε έναν φοιτητή να τελειώσει το διδακτορικό του για να τον πάρουμε ως βασικό μηχανικό. Αυτό είναι κάτι το οποίο δεν έχει κάποιο νόημα. Γιατί αφενός είναι περιορισμένη η ποσότητα των ανθρώπων που θα φτάσουν σε αυτό το επίπεδο και ο χρόνος πάρα πολύς. Άρα όλο το επίπεδο πρέπει να ανέβει και να μπορούμε να έχουμε μηχανικούς σε επίπεδο ερευνητή, διδακτορικού ή μεταδοχειακού, το οποίο να μπορεί αμέσως να χρησιμοποιηθεί σε κάποια από τα ανώτερα επίπεδα της εταιρείας και ταυτόχρονα να έχουμε φοιτητές από το βασικό πτυχίο, όπου μπορούν να φανούν άμεσα χρήσιμοι σε εμάς. Και εγώ προέρχομαι από τον κόσμο των ηλεκτρολόγων και πιθανόν ξέρετε ότι η Renesas είναι μια εταιρεία η οποία ασχολείται με την μικροηλεκτρονική ως επιτοπλίστων. Επομένως, μας ενδιαφέρει πάρα πολύ να έχουμε απόφοιτους που έρχονται σε εμάς και γνωρίζουν τα βασικά του embedded software, τα βασικά των hardware components και των τομέων των οποίων θέλουν και οι ίδιοι να ασχοληθούν. Και εδώ θέλω να περάσω στο δεύτερο κομμάτι, μια άλλη παράγραφο, ότι το βλέπουμε ότι λειτουργεί πάρα πολύ καλά και πολλές φορές και οι ίδιοι οι φοιτητές μας το ζητάνε. Ξεκινούν μια πρακτική στο software development και βλέπουν για 3 μήνες ποια είναι η διαδικασία του να αναπτύξεις ένα προϊόν σε επίπεδο embedded software σε αυτό που κάνουμε. Αλλά δίπλα ακριβώς, μερικά γραφεία πιο πέρα, είναι ένας άλλος χώρος όπου υπάρχει ένα εργαστήριο διερεύνησης του hardware, για παράδειγμα, ή ένα εργαστήριο διερεύνησης ακουστικής. Και αυτό μπορεί να δημιουργήσει μια άλλου είδους επίδραση και πολλές φορές μας το ζητάνε. Θέλω να δω και αυτό, και το επόμενο, και το μεθεπόμενο. Και είναι κάτι το οποίο είναι απόλυτα δεκτό και με κάποιο τρόπο πρέπει να μπορέσει να περάσει στους φοιτητές ότι δεν ξεκινάμε ένα πρόγραμμα πρακτικής με ένα συγκεκριμένο στόχο και από εκεί και πέρα αυτό θα είναι και η επαγγελματική σου ζωή από εκεί και πέρα. Το αντίθετο είναι ότι πρέπει να έρθουν στις εταιρείες ακριβώς για να δημιουργηθούν οι ερωτήσεις, για να δουν όχι μόνο ο συγκεκριμένος τομέας πώς λειτουργεί, αλλά και πώς μπορούν να δουν διαφορετικά αντικείμενα και κατόπιν να αποφασίσουν τι είναι αυτό το οποίο τους ταιριάζει ή τους αρέσει καλύτερα. Και αυτό το βλέπουμε να συμβαίνει όχι μόνο σε εμάς, το κάνουμε δηλαδή εμείς εδώ στην Ελλάδα, το κάνει όμως και η εταιρεία σε όλο τον κόσμο. Φοιτητές δηλαδή με τους οποίους συνεργαζόμαστε όχι μόνο από ελληνικά πανεπιστήμια και προφανώς όχι στα ελληνικά τμήματα της εταιρείας, έχουν την ίδια αντιμετώπιση. Και αυτό είναι πάρα πολύ σημαντικό να γίνει κατανοητό και με κάποιο τρόπο να μεθοδευτεί κιόλας. Δηλαδή να γίνεται γνωστό ότι ξεκινάμε εδώ, αλλά δεν ξέρουμε ακριβώς πού θα καταλήξουμε. Γιατί θέλουμε να ανοίξουμε την όρεξη. Όχι να καταναλώσουμε και να βρούμε θέσεις εργασίας οι οποίες με κάποιο τρόπο θα τις βρούμε, αν όλο αυτό ισχύσει. Ευχαριστώ.
Ωραία. Σας ευχαριστώ πάρα πολύ. Βγάζω το συμπέρασμα από όλα αυτά που ακούστηκαν ότι τα εργαλεία υπάρχουν, οι ιδέες υπάρχουν. Είτε από τη μεριά των εταιριών, είτε από τη μεριά του κράτους έχουν δημιουργηθεί διάφορες μορφές θεσμικές για τη συνεργασία. Ίσως αυτό που λείπει είναι το να υλοποιηθούν. Να υλοποιηθούν με κατάλληλο τρόπο. Έτσι, δηλαδή και έρευνα καινοτομό υπάρχουν και προγράμματα πρακτικής άσκησης υπάρχουν. Απλώς πρέπει ίσως να τα ζεστάνουμε λίγο, να τα προωθήσουμε με κατάλληλο τρόπο στους φοιτητές. Οι φοιτητικές ομάδες κάνουν άριστη δουλειά και είναι απίστευτη θερμοκοιτίδα για τους φοιτητές να αποκτήσουν μια αίσθηση πώς είναι να δουλεύεις ομαδικά, πώς είναι να σχεδιάζεις κάτι και να το παραδίδεις στις 17 του μηνός, γιατί αλλιώς υπάρχει πρόβλημα. Αυτά είναι πράγματα που στο ακαδημαϊκό πλαίσιο δεν τους τα δίνουμε, αυτό είναι αλήθεια. Δηλαδή, δυστυχώς το ακαδημαϊκό πλαίσιο έχει μια ελαστικότητα χρόνου. Το βλέπουμε και στις συναντήσεις και στα πάντα. Επομένως, ναι, υπάρχουν τα εργαλεία, ίσως θα πρέπει να υπογραμμίσουμε αυτά τα οποία θα έπρεπε να τονιστούν. Δεν ξέρω αν θέλετε από μισό λεπτό ο καθένας ένα μήνυμα που θα μπορούσε να φύγει είτε προς τη μία είτε προς την άλλη κατεύθυνση ή ακόμα και προς την κεντρική εξουσία να κάνει κάτι διαφορετικό για αυτή τη σύνδεση.
Είναι σημαντικό να δούμε τα success stories και νομίζω ότι και σε αυτό το πάνελ έχουμε ένα ή δύο success stories τα οποία έχουν προέρθει από τα ελληνικά πανεπιστήμια Μελετώντας λοιπόν αυτές τις περιπτώσεις, οι οποίες έχουν γίνει με κόπο και με πολλές δυσκολίες και πολλά εμπόδια, μπορεί να βγει το πλαίσιο αυτό, το οποίο πρέπει να ανατροφοδοτηθεί στους φοιτητές, καθηγητές και στη βιομηχανία, με τρόπο που να μπορέσει με κάποιο τρόπο να γίνουν περισσότερα από αυτές τις περιπτώσεις. Αυτό νομίζω από μένα είναι το σημαντικό.
Εγώ θα μείνω λίγο για το κλείσιμο στα θετικά. Θεωρώ ότι όντως, όπως υπόθηκε ήδη, η κατάσταση είναι πολύ καλύτερη από ό,τι ήταν 10-15 χρόνια πριν. Έχει όντως αλλάξει το κλίμα, υπάρχει όντως μεγαλύτερη συνεργασία και θεωρώ με συνειδητοποιημένη δουλειά από όλες τις πλευρές θα συνεχίζουμε να πηγαίνουμε προς την σωστή κατεύθυνση. Αυτό.
Και από μένα πιστεύω ότι με λίγη προσπάθεια παραπάνω και από τη μεριά των πανεπιστημίων και από τη μεριά των εταιριών, τουλάχιστον εδώ είναι, στη Χετία είναι οι περισσότερες ελληνικές εταιρείες στο ICT, θα μπορέσουμε να έχουμε μια καλύτερη και αποκατάσταση των φοιτητών μας και επάνδρωση των εταιριών με πολύ καλούς φοιτητές, με στόχο να κρατήσουμε και τον κόσμο στην Ελλάδα. Γιατί καλός ή κακός πάρα πολλοί φοιτητές μας φεύγουν στο εξωτερικό, το οποίο δεν είναι και κακό, γιατί παίρνουν μια εμπειρία. Πιθανότατα αρκετοί από αυτούς, σήμερα είδα κάποιον παλιό μας φοιτητή δεκαετίας που γύρισε πίσω και δεν είναι ο μόνος. Υπάρχει ένα ρεύμα, ας πούμε, που επιστρέφει στην Ελλάδα μετά από την κρίση, αλλά καλά θα είναι να μπορούμε να κρατήσουμε τον κόσμο στην Ελλάδα και αν είναι δυνατόν και στην πόλη του. Και αυτό μπορεί να γίνει εάν προσπαθήσει λίγο και το Πανεπιστήμιο και οι εταιρείες και αν μπορούν να χρηματοδοτούν λίγο παραπάνω και πρακτικές και internships και επίσης μισθολογικά να είναι, αν είναι δυνατόν, λίγο καλύτερα για να μπορούν να παραμένουν, δεδομένου ότι στο εξωτερικό πληρώνονται πολύ καλύτερα. Αυτό από μένα.
Από τη δική μου μεριά θα πάρω το λόγο των προηγουμένων και θα θεωρήσω πως οι ερευνητές και οι άνθρωποι που βγαίνουν από το πανεπιστήμιο μας είναι πολύ αξιόλογοι στο να βγουν έξω και να δουλέψουν στην αγορά εργασίας. Εκείνο το κομμάτι το οποίο θα μπορούσε το Πανεπιστήμιο να προωθήσει περισσότερο, ίσως βάζοντάς το και στο πρόγραμμα σπουδών του, είναι με κάποιο τρόπο να προωθήσει και δίνοντας κάποια ECDS ίσως τις πρακτικές ασκήσεις των φοιτητών, είτε κάποια research projects των φοιτητών, έτσι ώστε το ίδιο επιβαρημένο πρόγραμμά του φοιτητή να έχει νόημα και ουσιαστικά αυτή η δράση και η ασχολία του σε τέτοια προγράμματα να φανούν και στο ίδιο το πτυχίο. Αυτό είναι ένα κομμάτι. Και το δεύτερο που θα ήθελα να ξαναπώ είναι η ίδια η επιχειρηματικότητα εν γέννη του Πανεπιστημίου μέσω startups και spin-offs να αρχίσει να προωθείται και να λέμε στους ανθρώπους που κάνουν έρευνα ότι αυτή η έρευνα που γίνεται, αν υπάρχει αγορά και αν η κοινωνία ενδιαφέρεται για την έρευνά σου, να μπορείς, αν και εσύ θέλεις να το κυνηγήσεις, να το κάνεις μια επιχείρηση ή να το προσπαθήσεις στο τέλος της ημέρας. Αυτό από μένα.
Εγώ θα μείνω στο τελευταίο που υπόθηκε, ότι πρέπει αυτή η έρευνα να έχει πραγματικό αντίκτυπο και πρέπει το Πανεπιστήμιο με κάποιο τρόπο να βοηθάει σε αυτή την κατεύθυνση. Σίγουρα κινούμαστε σε καλύτερο δρόμο ως προς τη συνεργασία, αλλά σίγουρα η έρευνα που γίνεται πρέπει εκεί έξω να έχει ένα πραγματικό αντίκτυπο και να βοηθάει. Αυτό.
Σας ευχαριστώ πάρα πολύ όλους για την συμμετοχή στο πάνελ και εσάς για την παρουσία σας εδώ στο τελευταίο κομμάτι αυτό του συνεδρίου και νομίζω ότι τώρα μπορούμε να περάσουμε στο κλείσιμο του συνεδρίου.
κύριος Μούρτζης είναι συνδεδεμένος, οπότε κύριε Μούρτζη, αν θέλετε να πείτε κάτι.
Ευχαριστώ πολύ. Να χαιρετήσω το κοινό μας και να ζητήσω συγγνώμη που δεν μπόρεσα να παραβρίσκομαι εκεί. Δυστυχώς υποχρεώσεις που έχουν να κάνουν με την ιδιότητά μου σαν υπεύθυνος διοργάνωσης του Πάτρα Σακιού και αντιπρόεδρος της ΕΠΕΤΡΟΕΛΚΕ του Πανεπιστημίου Πατρών. Με κρατάνε εδώ στην Πάτρα για να πω και αυτό. Να σας θυμίσω ότι 25, 26, 27 Νοεμβρίου θα έχει διοργανωθεί η 8η έκθεση του Πάτρα Σαϊκιού, όπου ελπίζουμε πολλούς από εσάς να σας δούμε εκεί. Τώρα, αν θέλω να πω κάτι, δεν θέλω να πω πολλά, αλλά ο χρόνος του κλεισίματος δεν είναι ο κατάλληλος για να πεις πολλά. Το πρώτο πράγμα που ήθελα να πω είναι ότι θεωρώ ότι αυτή η συγκεκριμένη δραστηριότητα, δηλαδή αυτή η συγκεκριμένη πρωτοβουλία του Edge, εγώ το λέω, μου αρέσει να το λέω Edge, Intelligence, που έγινε στην Πάτρα πρώτη φορά, Θεσσαλονίκη δεύτερη, και είχα την τιμή από τους συναδέλφους να με προσκαλέσουν να είμαι στην Οργανωτική Επιτροπή και στη Θεσσαλονίκη. Θεωρώ ότι είναι μια πολύ σπουδαία δραστηριότητα, η οποία έχει να κάνει με το να φέρει κοντά βιομηχανία ή τέλος πάντων παραγωγή, αγορά και εκπαίδευση, πανεπιστήμια και έρευνα. Θα ήθελα να πω ότι αυτό το περίφημο gap ανάμεσα στην έρευνα και στην αγορά εργασία, στην παραγωγή, ας το πούμε παραγωγή με τη γενικότερη έννοια υπηρεσιών και προϊόντων, δεν είναι ούτε ελληνικό φαινόμενο, ούτε τοπική αρρώστια. Είναι ένα παγκόσμιο, ας πούμε, μια παγκόσμια πρόκληση, την οποία τη βρίσκουμε από χώρες που έχουν πολύ μικρό χρόνο στο time to market και αξιοποιούν πολύ περισσότερο την έρευνά τους, την έρευνα που κάνουν στα Ινστιτούτα και στα πανεπιστήμια, και έχουν πολύ πιο ισχυρή βιομηχανία από τη δική μας. Αν μου επιτρέψετε να πάρω ένα λεπτό, θα αναφέρω ένα success story, το οποίο έχει ζωή πίσω, ξέρετε πόσα, περίπου 70 χρόνια. Όταν δηλαδή έγινε το πρώτο CNC, το πρώτο Computer Numerical Control Machine, που ήταν ένα project το οποίο έδωσε ο Αμερικάνικος στρατός στην Parsons Corporation. Αυτή συνεργάστηκε με το MIT, γιατί δεν γινόταν με τις δικές της δυνάμεις να προχωρήσει το project, και μετά το MIT μαζί με την Cincinnati Millacron, η οποία υπάρχει ακόμα και φτιάχνει controllers και CNC στην Αμερική, κατασκεύασαν μεταξύ 48 και 52 το πρώτο συγγνώμη, έχω δυστυχώς παρεμβολές που ξέχασα να τις κλείσουν. Το πρώτο CNC, το οποίο άνοιξε το δρόμο, το πρώτο MC για την ακρίβεια, Numerical Control System, το οποίο άνοιξε το δρόμο για τα CNC, για τα World Centers και για μια τεράστια ανάπτυξη τεχνολογίας. Πήρε μόλις 4 χρόνια, 1948-1952, για να υλοποιηθεί. Το 1955 ήταν στην παραγωγή. Και μιλάμε για κάτι το οποίο στην κυριολεξία άλλαξε τον κόσμο της παραγωγής και τον κόσμο του manufacturing. Άρα, καλά παραδείγματα και καλές πρακτικές έχουμε. Και πολλές άλλες. Μπορώ να φέρω δεκάδες, εκατοντάδες αν θέλετε. Εκείνο το οποίο νομίζω ότι έχει νόημα να υποθεί είναι ένα σημείο το οποίο ανέφερε ο συνάδελφος από την Ενστάσεις, ο οποίος είπε ότι εδώ στην Ελλάδα είναι σαν τους ποδοσφαιριστές ένα πράγμα. Θεωρούμε ότι είναι ταλέντο μέχρι τα 25. Δεν μπαίνουμε στα πανεπιστήμια νωρίς, δεν πάνε οι εταιρείες, ούτε τα πανεπιστήμια πηγαίνουν νωρίς στην αγορά εργασίας, στις εταιρείες που έχουν ενδιαφέρον, για να αρχίσουν σιγά σιγά από πολύ νωρίς, από πρώιμα στάδια, να ζυμώνουν, να γίνεται αυτή η ζύμωση μεταξύ επιστημόνων που διαμορφώνονται και μεταξύ αναγκών της κοινωνίας και της παραγωγής. Επομένως, από εκεί ξεκινάει το πρόβλημα. Σε άλλες χώρες όπως η Γερμανία, για παράδειγμα, αυτό είναι σε έναν βαθμό λυμένο. Εμείς έχουμε δρόμο να το λύσουμε. Εκείνο το οποίο θα ήθελα τέλος να πω, και δεν θα πάρω πολύ χρόνο, είναι πρώτον ότι οι σπουδές μας, και αυτό έχει να κάνει με εμάς τους ακαδημαϊκούς, αν θέλετε, ή τέλος πάντων τους πανεπιστημιακούς, πέστε το όπως θέλετε, για να μην μπερδευόμαστε και με τους όρους. Οι σπουδές μας, δυστυχώς, είναι πάρα πολύ αναλυτικές. φτιάχνουμε ανθρώπους οι οποίοι είναι πάρα πολύ καλοί στην ανάλυση, είναι πολύ καλοί στα μαθηματικά, ακόμα και μηχανικοί δηλαδή. Παίρνουν ένα μηχανισμό, τον αναλύουν, βλέπουν τι κάνει κλπ. Είναι όμως, θα έλεγα να μην πω κακή, είναι ανεπαρκής η εκπαίδευσή μας στη σύνθεση. Και εκείνο το οποίο θέλει η αγορά, όταν θα έρθει η ώρα για να παράξεις ένα νέο προϊόν και να το προωθήσεις, είναι κυρίως η σύνθεση. Και όχι η σύνθεση μόνο με την έννοια την καθαρά τεχνική, δηλαδή να συνθέσω ένα μηχανισμό, ένα ρομποτικό βραχείο να κάνει κάτι, είναι και με τη σύνθεση των διαφόρων ειδικοτήτων, των διαφόρων αντιλήψεων, των διαφόρων συμπληρωματικών επιστημών κλπ. Αυτό το πράγμα λείπει. Και γι' αυτό η ευθύνη είναι αποκλειστικά των πανεπιστημιακών, οι οποίοι δεν φροντίζουν να δώσουν την απαραίτητη κατεύθυνση στο να δημιουργούμε συνθετικά projects σε όλη τη διάρκεια των σπουδών, ειδικά στις θετικές επιστήμες, ώστε να προετοιμάσουμε ανθρώπους με ένα πνεύμα δημιουργικότητας. Καλή ανάλυση, αλλά όταν πας σε μια συνέντευξη, κανένας δεν θα σου δώσει ένα φουργέ transform, να του πεις τι είναι αυτό ή μια μερική διαφορική αντιλήσεις. Θα σας ρωτήσει άλλα πράγματα και ξέρετε πολύ καλά εσείς από τις εταιρείες τι εννοώ. Λοιπόν, κλείνοντας, θέλω να πω ότι θέλουμε πολλή δουλειά και από τις επιχειρήσεις και από τα πανεπιστήμια. Το gap υπάρχει και όπως και να έχει το πράγμα, η προσπάθεια που γίνεται μέσα από το EDGE, το οποίο του χρόνου, αν δεν κάνω λάθος, θα πάει στο Βόλο, είναι μια καλή προσπάθεια, η οποία όμως θα πρέπει να αποκτήσει μεγαλύτερη δυναμική. Το να έχουμε 30-40 papers ή τέλος πάντων contributions τη μια χρονιά και άλλα 30-40 την άλλη, αυτό δεν είναι επαρκές. Η Πάτρα είναι μικρή πόλη με ανύπαρκτη βιομηχανία. Η Θεσσαλονίκη είναι πολύ μεγαλύτερη πόλη με ισχυρότερη βιομηχανία. Ο Βόλος είναι αυτός που είναι. Δεν φτάνει. Πρέπει να δημιουργήσουμε μια δομή, μια κίνηση, μια πρωτοβουλία σε εθνικό επίπεδο, ούτως ώστε να προσελκύσουμε βιομηχανίες πολλές, μεγάλες βιομηχανίες και μεγάλα πανεπιστήμια και μεγάλα εργαστήρια να έρθουν και να συμμετάσχουν σε πραγματικούς όρους στο edge intelligence, όπως θέλουμε να το πούμε. Και νομίζω ότι πρέπει να φύγουμε σιγά σιγά και από την καθαρά ICT μορφή και να προχωρήσουμε και σε άλλες μορφές παραγωγής προϊόντων και υπηρεσιών. Αυτά και εύχομαι όλα να πάνε καλά για την επόμενη έκθεση. Περιττώ να πω ότι είμαι στη διάθεση και της επόμενης Οργανωτικής Επιτροπής με τους συνεργάτες μου όσο μπορούμε να βοηθήσουμε.
Ευχαριστούμε κύριε Μούρτζη. Φτάσαμε στο τέλος. Ήταν ένα γεγονός, ένα συνέδριο που είχε πολλά, ένα πλούσιο πρόγραμμα, ομιλίες από διακεκριμένους επιστήμονες, από εταιρείες, από πανεπιστήμια, από ερευνητές από όλη την Ελλάδα, από προσκεκλημένους ομιλητές και επίσης είχαμε και Career Day με συμμετοχή πολλών εταιριών. Τα είχαμε όλα γενικά. Και τέλος είχαμε και ένα round table όπου συζητήθηκε το θέμα πάντα hot όπως λέμε, το θέμα της συνεργασίας του Πανεπιστημίου με την βιομηχανία. Στο τέλος της ημέρας θα κρατούσα δύο συμπεράσματα. Ένα είναι ότι φαίνεται πως έχουμε κάποιο οικοσύστημα, το ζητούμενο, εδώ στην Ελλάδα και στην περιοχή μας και στη Θεσσαλονίκη, αλλά ενδιαφερόμαστε για όλη την Ελλάδα, το οποίο αναπτύσσεται και υπάρχει και διάθεση για ανάπτυξη και έχουν ακουστεί πολλά πράγματα, γίνανε ζωντανές συζητήσεις, ακόμα και στις παρουσιάσεις των ομιλιών, αλλά και στα άλλα session. Και το δεύτερο θα έλεγα είναι ότι φαίνεται και η Ακαδημία και οι εταιρείες μοιράζονται το ίδιο όραμα, ότι θέλουν αυτή τη συνεργασία, την πιστεύουν και υπάρχει συνεργασία με τα πανεπιστήμια, όπως ακούστηκε βελτιώνεται συνεχώς και στο χέρι μας είναι να δούμε και άλλες ιδέες και άλλους τρόπους να την κάνουμε ακόμα πιο στενή. Με αυτά τα δύο θα ήθελα να κλείσω εδώ και να σας ευχαριστήσω που ήσασταν εδώ σε όλη τη διάρκεια του συνεδρίου. Επίσης να ευχαριστήσω τη Χετία για αυτή την πολύ θετική πρωτοβουλία που είχε και που επέλεξε τη Θεσσαλονίκη σαν διοργάνωση αυτού του event. Και επίσης θα πρέπει να ευχαριστήσω και όλους τους συμμετέχοντες σε αυτό το event, στην Οργανωτική Επιτροπή, το Scientific Committee που είναι ουσιαστικός ο ρόλος τους, γιατί θέλουμε reviewers για τα paper, αλλιώς δεν γίνεται συνέδριο. Όλα τα παιδιά τους εθελοντές που βοήθησαν. Ελπίζω αυτή η προσπάθεια να συνεχιστεί και στο μέλλον προφανώς και θα θέλαμε να σας έχουμε, να σας δούμε και στο επόμενο event. Το που θα μας το πούνε τώρα ο κύριος Σταμούρης, βλέπω είναι εδώ στο πάνελ, και ο κύριος Δακαγής. Ευχαριστώ. Γεια σας, ευχαριστώ πολύ που ήσασταν εδώ.
Λοιπόν, νομίζω ότι ο κύριος Νικολαίδης τα κάλυψε όλα, οπότε εγώ θα είμαι πολύ πιο σύντομος. Να ευχαριστήσω καταρχήν όλους τους καθηγητές και όλα τα μέλη του Αριστοτέλειου Πανεπιστημίου για την συνεργασία που είχαμε. Καταφέραμε και συνεργαστήκαμε για να κάνουμε το δεύτερο conference εδώ στη Θεσσαλονίκη. Είχαμε πολύ ενδιαφέρουσες συζητήσεις αυτές τις μέρες. Ελπίζω να βοήθησε αυτή η εκδήλωση και αυτό το συνέδριο ώστε να μειώσουμε λίγο το κενό που υπάρχει μεταξύ βιομηχανίας και ακαδημίας. Να ευχαριστήσω τους προσκεκλημένους μας που μας κάναν την τιμή να έρθουν να παρουσιάσουν εδώ πέρα. Να ευχαριστήσω προφανώς τις εταιρείες που υποστήριξαν αυτή την εκδήλωση και συμμετείχαν στο Career Day. Όπως σας είπα και στην εισαγωγή, εμείς σαν σύνδεσμος έχουμε τη διάθεση το συγκεκριμένο συνέδριο να το κάνουμε θεσμό. Ξεκινήσαμε πέρσι με την Πάτρα, συνεχίζουμε σήμερα φέτος με τη Θεσσαλονίκη και είμαι στην ευχάριστη θέση να σας ανακοινώσω ότι του χρόνου έχουμε αποφασίσει να συνεργαστούμε με το Πανεπιστήμιο του Βόλου. Γι' αυτό έχουμε και μαζί μας τον Γιώργο το Σταμούλη, που δυστυχώς δεν κατάφερε να έρθει μαζί μας, αλλά τον έχουμε κοντά μας online να μας πει λίγα λόγια και Γιώργο, σίγουρα προσδοκούμε σε μια καλή συνεργασία όλο τον επόμενο χρόνο για να διοργανώσουμε ένα ακόμα καλύτερο event του χρόνου στο Βόλο. Ευχαριστώ πάρα πολύ όλους σας και δίνω το λόγο στον Γιώργο το Σταμούλη.
Θα ήθελα να σας ευχαριστήσω όλους. Θεωρώ ότι το να επιλεγεί το Πανεπιστήμιο Θεσσαλίας και ο Βόλος για την διοργάνωση του τρίτου συνεδρίου θα είναι κάτι το οποίο μας τιμά ιδιαίτερα και προφανώς θα μας αναγκάσει να δώσουμε τον καλύτερό μας σε αυτό. Έρχεται σε κολλητά πλέον με τις καταστροφές που έχει υποστεί η υποδομή του Πανεπιστημίου Θεσσαλίας, όχι μόνο στο Βόλο, αλλά και στις υπόλοιπες πόλεις. Είμαι στην ευχάριστη θέση να πω ότι προχωράμε πολύ γρήγορα στην αποκατάσταση και θα είμαστε απόλυτα έτοιμοι του χρόνου να σας υποδεχτούμε στο Βόλο. Από την άλλη πλευρά, θεωρώ ότι η σχέση των πανεπιστήμιων με τη βιομηχανία πρέπει να μπει σε διαφορετικές βάσεις, να επαναδιαπραγματευτούμε τις σχέσεις που έχουμε και να δούμε τι είναι επωφελές για όλους, έτσι ώστε να καταλήξουμε στο καλύτερο αποτέλεσμα. Στα 20 λίγα χρόνια που έχω στο Πανεπιστήμιο στην Ελλάδα, έχω δει πολύ κόσμο, πολύ ικανό κόσμο να αποκτά γνώσεις, να αποκτά τον τρόπο σκέψης του μηχανικού και να στελεχώνει εταιρείες στο εξωτερικό. Αυτό πρέπει να σταματήσει, πρέπει να δουλέψουμε για την εγχώρια βιομηχανία και η εγχώρια βιομηχανία πρέπει να στηριχτεί στα ελληνικά πανεπιστήμια και να προχωρήσουμε σε μια ανάπτυξη την οποία περιμένουμε εδώ και πάρα πολύ καιρό. Υπάρχουν πισωγυρίσματα, υπάρχουν λάθος αποφάσεις τόσο σε εθνικό όσο και σε ευρωπαϊκό επίπεδο, αλλά αυτά πρέπει να τα αναγνωρίσουμε και να τα ξεπεράσουμε. Και θεωρώ ότι το κλίμα αυτή την εποχή είναι αυτό που πρέπει να είναι για να μπορέσουμε να προχωρήσουμε. Για να περιαυτολογήσουμε και λίγο, μέχρι τώρα, τουλάχιστον στους τομείς που καταλαβαίνω εγώ, βλέπω ότι οι απόφοιτοι των ελληνικών πανεπιστημίων και πολυτεχνείων έχουν το κάτι παραπάνω όταν φτάνουν να ανταγωνιστούν μηχανικούς από άλλες χώρες. Δεν είναι τυχαίο που ένα μεγάλο, νομίζω ότι τα στατιστικά δείχνουν ότι αναλογικά με τον πληθυσμό της η Ελλάδα έχει το μεγαλύτερο ποσοστό μηχανικών στην Αμερική, τουλάχιστον κάποια στοιχεία που είχα δει. Αυτό δείχνει ότι κάτι κάνουμε σωστά, απλά αυτό το κάνουμε σωστά πρέπει να μπορέσουμε να το εκμεταλλευτούμε και εμείς ήδη. Λοιπόν, θα χαρώ να τα πούμε όλοι μαζί στο Βόλο και περιμένω, προσβλέπω σε μια εξαιρετική συνεργασία. Σας ευχαριστώ όλους.
Ευχαριστούμε πολύ. Καταρχήν να πούμε ότι την απόφαση για να κάνουμε το επόμενο συνέδριο στο Βόλο την είχαμε πάρει πριν γίνουν οι καταστροφές, αλλά μια και τις ανέφερε ο Γιώργος, να πω ότι το γεγονός ότι συνέβη αυτό μας δίνει έξτρα κίνητρο να επιβεβαιώσουμε ότι 100% θα πάμε εκεί πέρα, γιατί είναι καλό δείγμα να θέλουμε να τονώσουμε την επαρχία. Όπως σας είπα, εμείς έχουμε πάρει μια απόφαση αυτή την εκδήλωση όσο το δυνατόν να την κρατάμε εκτός Αθήνας, όχι προφανώς γιατί για κάποιο λόγο θέλουμε να υποτιμήσουμε τα πανεπιστήμια της Αθήνας, αλλά θέλουμε αυτό να είναι μια ευκαιρία να πάμε στην επαρχία που υπάρχουν αξιόλογα πανεπιστήμια και να τονώσουμε και εκεί τις εταιρείες και την παρουσία μας. Λοιπόν, ευχαριστώ πολύ, δεν θα μιλήσω άλλο. Ευχαριστώ πολύ και τον κύριο Μούρτζη και τον κύριο Σταμούλη. Κύριε Μούρτζη, προφανώς όπως καταλάβατε, σας περιμένουμε και στην καινούργια Οργανωτική Επιτροπή. Ελπίζω να έχετε τον χρόνο να συμμετέχετε. Πάντα η μεταφορά τεχνογνωσίας από τη μία χρονιά στην άλλη βοηθάει ώστε να βελτιωνόμαστε και σας υποσχόμαστε ότι θα βελτιώσουμε σιγά σιγά όλη αυτή την προσπάθεια. Οπότε σας περιμένουμε και στην καινούργια Οργανωτική Επιτροπή, που σίγουρα προφανώς θα είναι και ο κύριος Σταμούλης. Λοιπόν, ευχαριστώ πολύ όλους σας. Να είστε καλά. Καλό απόγευμα. Γεια σας.
Καλό απόγευμα. Χαρητήρια σε όλους.
Γεια σας.
Να είστε καλά. Γεια σας.
This is Renaissance. Renaissance was born after three Japanese technology giants, Hitachi, Mitsubishi Electric, and NEC, took the bold step of merging their semiconductor businesses to create one company. It is from this rich technological heritage derived from these companies that the foundation of Renaissance is formed. Our proven technology and unwavering commitment to quality are what set us apart from our peers as a world-leading semiconductor company. More recently, Renaissance began expanding its footprint in Silicon Valley, first with the acquisition of Intercell in 2017, and then IDT in 2019. Renaissance successfully combined its proven quality with top-class safety standards and technical competency with the innovative products and entrepreneurial spirit of Intercell and IDT. In 2021, Renesas completes its acquisition of Dialog, expanding its footprint in Europe. With Intercell, IDT, and Dialog now in the fold, Renesas enters a new era as a truly cosmopolitan company with a progressive mindset and a modern vision to lead the industry. What is Renesas's purpose in business? Our purpose is simple: to make our lives easier. We do this by harnessing the power of technology to complement human capabilities. And our lives don't just mean the people who use the final products that are powered by our technology. It means the lives of our suppliers, customers, our employees, and their families. To make human lives easier, our products provide advanced driver assistance systems, alternative fuel vehicles, robotics and human-machine interaction for smart factories, state-of-the-art medical devices, home appliances with intelligence, data centers handling big data and data explosion, fast and low-latency 5G wireless communication networks. To make our customers' lives easier, we deliver a vast array of semiconductor products such as MCUs or SoCs, analog and power to provide complete coverage for the broad signal chain in electronic systems. Renesas customers win by tapping our rich portfolio of analog power and embedded processing solutions. Our winning combinations help customers accelerate their designs and get to market faster with high performance and high quality products. The winning combinations address the needs of new and expanded customers and continue to power our customers' systems with compelling products and solutions designed with our proven technology. Renesas has weathered many storms and changes and is in a constant state of transformation to become a stronger organization. We will continue this journey to make a better world through our technology and make a positive impact on the way we live and work. Here at Renesas, everyone can make a difference. Together, we can make change happen.
Kenetom is an engineering services provider for embedded systems and industrial automation, based in Thessaloniki, Greece. Today, Kenetom employs more than 180 people, and the team keeps growing. Our vision at Kenetom is to get established as a customer-oriented center of excellence in the field of embedded systems. Our philosophy of delivering the highest quality engineering services is built on our values of trust, evolution, commitment, talent. Since 2014, we have established partnerships with some of the largest Tier 1 automotive electronics suppliers, gaining significant experience and developing know-how across our team. Our customers come from 4 major sectors: automotive, industrial automation, medical, aviation. They include major Tier 1 automotive electronic suppliers and global market leaders. Having significant experience in both agile and waterfall development, we tailor the development processes to our customers' requirements. Our main activities lie in the areas of basic software development, application software development for control and automation, testing and validation of ECUs, electronics design and development, systems engineering, software requirements and architecture. Our strength is our people, and that's why we offer excellent working conditions, challenging projects, and significant development opportunities. We are happy to be one of the most popular employers in Greece, and our strong connection to the academic community enables us to constantly strengthen our team with highly talented people. As we focus on developing automotive, safety-critical embedded systems, we comply with quality, information security, and functional safety standards. For major Tier 1 automotive electronic suppliers, we develop, integrate, and validate hardware and software modules for powertrain, interior, and ADAS ECUs, from requirements up to system qualification tests. Kenetom actively supports its customers from prototype to series production. Thanks to our extensive collaborations, we have gained significant experience with different technologies and tools. Our customer satisfaction is the key factor in our constant growth. So if you are looking for a reliable partner, Kenetom's team is ready and motivated to create a positive and productive partnership with you. Kenetom, embedded engineering excellence.